So the topic for today's session is operating system, and operating system is a part of. It's a very important subject, as you can see in both UGC NET, GATE, and even set examination. On all these examination, operating system is one of the most important part, which is present, right? Secondly, operating system is one of the very easy subject. Operating system सबसे easy subjects में से भी एक है, because the marks you are going to score in operating system, you can score 100% marks in operating system. There's only one or two portions where you might face some difficulty in solving the questions. For example, you have the areas which are related to synchronization. So in chapters like synchronization, you might face issues in the examination in solving the question, but otherwise in 99% of the cases you will be able to score full marks in operating system. आप full marks operating system में score कर सकते हैं 99% cases में. So before we start, let us look at what are the topics we will be covering in this session, in this operating system subjects. So we will start with the topic that is introduction to operating system. We'll start by introduction to operating system. Then we will be looking at some concepts regarding process management. So in this process management, we will also be studying regarding process scheduling. Then we will be looking at something called as memory management, or before memory management we'll be taking synchronization. After process management, then we will be taking memory management. Then we will be looking at file system and disk scheduling. Okay, and these are the chapters which are important. We will be covering all of these chapters one by one, and I believe some of you have already seen all these chapters. आप लोगों ने काफ़ी जो student है उन्होंने सभी chapters को देखा होगा. Okay, and this is kind of very easy subject, right? So in process management you have CPU scheduling algorithm. In synchronization we have various synchronization mechanisms, like for example you have synchronization mechanisms related to semaphores. We can have Peterson solution, we can have lock variable solution. A lot of these synchronization mechanism we are going to discuss, as well as this is also called as inter-process communication, which is IPC. And inter-process communication, here also we are also going to study about concurrency. Inter-process communication, IPC and concurrency. Then we also deal with deadlocks here. तो deadlocks के बारे में हम लोग study करेंगे, as well as we will also study about threads. Okay. Then we have memory management. So we have various memory management techniques, like we have contiguous memory management, we can have non-contiguous memory management. After this, there are various parts of non-contiguous memory management. For example, you have paging scheme, you can have multi-level paging, you can have single level paging, you can have TLB, that is a translation look aside buffer, and we can also see inverted paging, right? So, and we can also have segmentation. So these all are the memory management techniques. A part of this, we also look at what is a virtual memory here. हम लोग यहाँ पर virtual memory के बारे में study करेंगे, and more things regarding RAM organization, or can say RAM management. So RAM organization and RAM management we'll be discussing here in this section. Then in the here also we also discuss about the page replacement algorithm. page replacement algorithms, and so on. And then in the file system and disk scheduling, we will be looking at what are the interfaces, that there is a file interface, and then their implementation, details of file systems. Then in disk scheduling, we will be looking at how to schedule the disk, that is your hard disk drive. So lot of questions we'll be discussing it regarding this hard disk drive, regarding the structure of this hard disk drive, as well as regarding how can you do disk scheduling, right? So both of these things we'll be discussing. And then we'll also discuss about the device management. So here we have multiple devices like keyboard, printers, monitors, and all these devices, how your operating system is going to manage all of these devices. तो ये सभी चीज़ें हम लोग यहाँ पर discuss करेंगे, and all of these are very important portion for your examination. So this is basically a broad way syllabus. This is a broad way how you can see broad syllabus. And once we start studying all of these things one by one, then you will find that these things are very interesting, and the understanding of operating system will improve, right? So the way we see your operating systems, that is just like I would say in OOPS concept, right? So you have a concept like encapsulation, you have a concept like polymorphism, right? So there are various concepts, right? So there's a concept which is related to that you are only interested in the upper level details, but you are not interested in the lower level details, right? So sometimes in operating in OOPS, that is object oriented programming language, we do not look at the implementation, we look at what are the upper level details of this. क्या बोलते हैं इस concept को? Abstraction. So we have abstraction, right? So this abstraction, we use the operating systems, right? For us this is an abstraction, but we do not really know what is the internal functioning of the operating system. Operating system internally कैसे काम करता है, तो वो सब चीज़ें हम लोग यहाँ पर study करेंगे, and we'll try to like just like we have a onion, right? So we try to peel the layers of the operating system. We try to go in depth in the operating system. Okay, so we will try to unleash this abstraction. ठीक है, तो we can start, right? Fine. So we have operating systems, like there are a lot of examples of operating system. काफ़ी examples हैं, जैसे कि you have a Windows based operating system, like I'm using this Windows 10 operating system. Then we have Linux based operating system. We can also have Unix based operating system. Even if you see your Android operating system on your mobile phone, this is basically a Linux based operating system. जो आपका Android operating system है mobile phone में, वो एक Linux based operating system है. Then you have something called as iOS, right, which is in Apple devices. Then you can also have operating systems, for example Macintosh, right? So this is in Apple devices, right? So Apple MacBook, Apple iMac, all of them are having Macintosh operating system. A part of this, you can also have operating systems which are working on different devices, like you have microwave oven, right? So microwave oven also contains an operating system which is used to manage the microwave. A part of this, you can also have washing machine. So in washing machine also we can have a operating system. We can have operating system in air conditioners. We can have operating system in televisions. So there are a lot of devices where we do not really know कि operating system कहाँ पर use है. So what are the places we are using operating system unconsciously? Even if you see a simple calculator is also having an operating system which is basically used so that you can work on the calculator, right? Even your printer is also having an operating system. All of these devices are having operating systems, and the main goal of operating system is to manage the resource, correct? So we have a lot of resources in the device, and to manage all of these resources we use an operating system. Okay, so you can have operating system in your mobile phone, computers, tablets, as well as there are a lot of devices where you have operating systems: microwave, air conditioners, TVs, calculators. Even for example cars are also having operating system. If you see the latest cars that are coming, uh, so the latest cars that are coming, which is from Tesla. So these Tesla cars are also having operating systems, right? So we are using operating system in so many places that you do not even know. Satellites is also a very good example. So a lot of places we are using operating system, fine. Now these operating systems can be of different types. Like for example, we have an operating system which is made for home user based operating system, home user based operating system, and we can also have operating system which is for professionals, right? So professionals, or maybe like server systems, your web servers and all, they are also having operating system. So for this home user based operating system, the primary goal of operating system is convenience, and the secondary goal here is efficiency, right? And for professional operating system, the primary goal is efficiency and the secondary goal is convenience. What do I mean to say by this is, जो आपके home user based operating system, like you and me, we guys are home user based operating system. We do not really do a lot of professional work in our systems. अगर आप अपने लैपटॉप्स में या फिर नॉर्मल एक स्टूडेंट लाइफ को एक्सप्लेन करेंगे, so in a normal student life, people do not really do a lot of meaningful tasks in the laptops. They use a laptop to watch Netflix, they use a laptop to watch movies, play games, all of these things, right? So he do not like people like for example a student or a housewife, they do not really want to go they do not really want to do a lot of in-depth, or you can say meaningful work in the operating system, or you can say laptops. So for them it is main purpose is convenience. उनके लिए जो सबसे बड़ा purpose है वो convenience है, कि वो अपने system या laptop को conveniently use कर सके, correct? But efficiency is a secondary part from them. So they do not really care about efficiency, they only care about कि how conveniently they can use the laptops, how conveniently they can use the device. वो अपनी device को कितने conveniently use कर सकते हैं, उनके लिए वो main सबसे important portion है, that is the most important portion for them. But if you look at the professional, for example, you have web servers, you can see the example of a Google server, or you can see the example of a web host, right? So for all these web servers, their main goal is efficiency, that is how efficiently you are going to utilize the resources. आप resources को कितना efficiently utilize करते हैं. For this professional people, this is the main goal, right? And the convenience is the secondary goal, because they are very highly skilled or highly trained people, and they can work using commands. They do not need a graphical user interface. उनको graphical user interface की ज़रूरत नहीं है, वो सिर्फ command line से भी अपना काम कर सकते हैं. So that is why convenience is a secondary portion there. So convenience is a secondary goal, but the primary goal for those systems is efficiency. उन सभी systems के लिए जो primary goal है वो efficiency रहेगा, और जो convenience है वो उनका secondary goal रहेगा. Okay. So again I'm repeating, for all the home user based operating system, or you can say like you and me, we are basically a normal user, a home user based operating system. For us the main goal of operating system is to provide convenience. हमारे लिए operating system जो है वो convenience provide करे. That means how can you work on this operating system, आप कैसे काम कर सकते हैं. Maybe you want to work on MS Office, or maybe you want to work on Google Chrome as a web browser, or you surf internet or so on, right? तो हमारे लिए जो प्राइमरी गोल रहेगा ऑपरेटिंग सिस्टम का वो कन्वीनियंस है, कि हम कितनी ईजीली और कन्वीनियंटली अपने काम को फिनिश कर सकते हैं. एंड एफिशिएंसी इज़ द सेकेंडरी गोल फॉर अस, कि आप कितने एफिशिएंटली अपने काम को कर सकते हैं, दैट इज़ अ सेकेंडरी गोल, राइट? But for the other people, like for example you have professional people or server system, the main goal is efficiency and the secondary goal is convenience, correct? ठीक है. But in the examination, if anybody asks you what is the goal of operating system, अगर कोई भी आपसे पूछता है कि operating system का goal क्या है, then you will answer this. You will say the primary goal of operating system is convenience and the secondary goal is efficiency. And this efficiency is related to how efficiently you are managing the hardware. How efficiently you are managing the hardware. आप हार्डवेयर को कितना एफिशिएंटली मैनेज करते हैं, सो दैट इज़ योर सेकेंडरी गोल. which is efficiency. Clear so far? Good. So if it is clear, there was a previous year question based on this also. So in ISRO examination they have asked this question, that is, what is the goal of operating system. In 2009 also they have asked this question. In 2011 electronics and communication, they have asked this question, right? So they have asked this question before also. So just read this question. They are asking the primary purpose of operating system is, इसमें से operating system का primary purpose क्या है. And this question was also repeated in UGC net. ये question जो है UGC net के अंदर भी आया था. So you can see this line itself is a very interesting part, क्योंकि काफ़ी examination में पूछा गया है. The primary purpose of operating system is which of the following? Option number A, to make most efficient use of the computer hardware. Option number B, to allow people to use the computer. Option number C, to keep system programmers employed. And option number D, to make the computers easier to use. Okay, what is the answer here, guys? Answer क्या रहेगा यहाँ पर? So the answer is option number D. Option number A is not a correct answer, because option number A is talking about efficiency. The primary purpose of operating system is not efficiency, it is the convenience. Convenience जो है वो primary purpose है, efficiency is not a primary purpose. So to make the most efficient use of the computer hardware, that is a secondary purpose for the operating system. Correct? So that is why most of the people, they are confused with the answer is as A. जो ऑप्शन नंबर ए है वो ज़्यादा सभी जो स्टूडेंट्स है वहाँ पर ऑप्शन नंबर ए के लिए कंफ्यूज होते हैं, बट ऑप्शन नंबर ए इज़ नॉट द करेक्ट आंसर. ऑप्शन नंबर ए जो है वो करेक्ट आंसर नहीं है. ओके, सो द करेक्ट आंसर इज ऑप्शन नंबर डी, दैट इज़ टू मेक इट ईजियर फॉर द यूज़र to access the operating system, to make it easier for the user to work on the operating system. That is the primary goal. Okay, and if you can see this link also, this is a Wikipedia link. In this Wikipedia link also, they are also saying the same, that the main purpose of operating system is to provide convenience, and the secondary purpose is efficiency. So we are really not worrying about efficiency, we are mostly worrying about convenience. If anybody asks you what is the main purpose of operating system, the correct answer will be convenience. It is not efficiency. Okay, so if you look at how this operating system works, you can have a computer hardware. Over this computer hardware there is an operating system. So this operating system is over this computer hardware. ये इसके ऊपर काम करता है. And how does this operating system works here? So this operating system is used to manage the resources. So operating system is a resource manager. That means how and what resource to use and which resource should be allocated to which process. And all your processes work on this operating system. So this is a process, maybe your MS Word is a process, maybe your web browser is a process, right? So all these processes, all these applications, software applications, they work on this operating system, and the end user works on these processes. जैसे Word है, so we are the end user, we are going to work on MS Word. We are the end user, we are going to work on browser. We are the end user, we are going to work on these software applications. So these software application communicates with the operating system, and further this operating system communicates with the hardware. तो ये जो software applications हैं ये operating system के साथ communicate करते हैं, और ये जो operating system है ये अपने computer hardware के साथ communicate करते हैं. So we do not directly communicate with the computer hardware, but rather there is an abstraction, there is a layer here, and the layer here is operating system. Right, so what is the operating system? Operating system is a resource manager. जो आपका operating system है वो resource manager है. That means it tries to manage all the resources in your computer. Resources, there can be various types of resources. For example, you can have a printer. Printer is a resource. You can have a scanner. Scanner is a resource. You can have a monitor. That is also a resource. You can have data variables. These are they can be shared data variables, they can be not shared data variables. These are resources. You can have a piece of code, a code written, that is also a resource, right? So there are various kind of resources that we have. So this operating system tries to manage all these resources. It tries to see which resource should be allocated to which process. कौन से resource को हमें किस process को allocate करना है, that is managed by your operating system. So for example, there is a file here. There is a file which is present in C drive. There is a file which is present in C drive, and now this MS Word also want to work on this file, and this web browser also want to work on this file. इस same file पर एक से ज़्यादा जो हमारे पास processes हैं वो काम करना चाहती है. More than one processes can want to access the same file at the same time. So this is the responsibility of operating system to decide to which of these processes we should give this file. To which of these process we should give access to this file. इसमें से किस process को हमें इस file की access देनी है, that is done by your operating system. Okay, fine. And secondly, all your process scheduling, or you can say CPU scheduling, that is also done by operating system. ठीक है, जो CPU शेड्यूलिंग है वो भी ऑपरेटिंग सिस्टम करता है. सो व्हाट डू यू मीन बाय CPU शेड्यूलिंग? CPU शेड्यूलिंग मीन्स बेसिकली CPU इज़ अ रिसोर्स. जो आपका CPU है वो एक रिसोर्स है, एंड टू विच प्रोसेस वी हैव टू गिव दिस रिसोर्स, दैट इज़ द रिस्पॉन्सिबिलिटी ऑफ ऑपरेटिंग सिस्टम. आपके पास किस प्रोसेस को ये CPU देना है वो हमारे ऑपरेटिंग सिस्टम की रिस्पॉन्सिबिलिटी है. एंड व्हाट इज़ अ प्रोसेस? प्रोसेस क्या होता है? अ प्रोसेस इज़ अ प्रोग्राम इन एग्जीक्यूशन. इज़ ए प्रोग्राम इन एग्जीक्यूशन. अगर आप किसी प्रोग्राम को एग्जीक्यूट करते हो देन दैट प्रोग्राम बिकम्स अ प्रोसेस. ठीक है, ओके. लेट मी एक्सप्लेन एंड इलैबोरेट इन मोर डिटेल्स. मैं थोड़ा सा और डिटेल्स में इसको इलैबोरेट करता हूँ. सो देयर इज समथिंग कॉल्ड एज सर वॉन न्यूमैन आर्किटेक्चर. So what does this von Neumann architecture says? That we do not really have to keep everything in your main memory at all times. So all of your program can reside in the secondary memory, and the program that we execute that can come in the main memory. Okay, let me explain. So here we have a CPU, and then we have a cache memory here. Then we have a main memory here. And then we have your secondary memory. ठीक है, and this secondary memory can be anything. The secondary memory can be your hard disk drive, it can be your solid state drive, it can be your pen drive, it can be your floppy disk, it can be your CD or DVD drive. All these things are secondary memory. And your main memory is your RAM, or you can say the random access memory, and this is your cache memory. If you look at all this memory, go from this direction to this direction, you will see that the speed of these memories are increasing and the cost of these memories are also increasing. Okay, तो यहाँ पर जो speed है वो भी increase होती है और cost भी increase होती है. So this main memory is faster than your secondary memory. This cache memory is faster than your main memory, and these registers are very fast as compared to cache memory. But the thing is, if you go from this direction to this direction, the cost will also increase. यहाँ पर जो cost है वो भी increase होती है, right? And secondly, your main memory is a volatile memory. It is a volatile memory. Even your cache memory is a volatile memory. What do you mean by volatile? Volatile का मतलब क्या है? As soon as you turn off your computer, as soon as you turn off your systems, these memories will be wiped out. ये जो memory है इसमें जो भी data present है वो delete हो जाएगा. That will be completely wiped out. Even your registers are also volatile. जो registers हैं आपके वो भी volatile है, right? So that means as soon as you power off your system, power off your computer, these memories will be, deleted or erased. But this secondary memory is a non-volatile memory. ये आपकी non-volatile है. That means if you turn off your computer, then the data which is present in the secondary memory, that will still be present. Next time when you turn it on, your data will still be present. So what does this von Neumann architecture says? It says that any program that you have to execute, that program do not have to reside in the main memory at all times. उस प्रोग्राम को मेन मेमोरी में हमें हर समय पर वो प्रोग्राम जो है ज़रूर नहीं है कि हमेशा वो मेन मेमोरी पर प्रेजेंट हो, राइट? सो ही सेड अकॉर्डिंग टू द नीड यू कैन store the program in the secondary memory and then you can bring the program in the main memory. आप अपनी नीड के अकॉर्डिंग प्रोग्राम को सेकेंडरी मेमोरी पर स्टोर कर सकते हैं और उसको ज़रूरत के हिसाब से मेन मेमोरी पर लेकर आ सकते हैं. इसको हम बोलते हैं स्टोर्ड प्रोग्राम कॉन्सेप्ट. We call it as a stored program concept. Okay, so it's a very simple and elegant computer architecture. Okay, let me repeat again. So stored program concept says that any program that we want to execute will be stored in the main RAM memory, in RAM, right? And so during execution you have to bring the program in the RAM, otherwise you can keep the program in the secondary memory, right? So for example, this is your program. So when you execute this program, you take this program from secondary memory, you put this program in the main memory. आप इसको secondary memory से उठाएंगे और main memory पर रखेंगे, and in the main memory this program will execute. Main memory पे जब program main memory में होगा उस समय पर हम लोग program का execution करेंगे. Okay, that is your von Neumann architecture. Fine. On the basis of this von Neumann architecture, we have various different kinds of operating systems. There is types of operating systems, right? So the first type of operating system is your batch operating system. Then the second type of operating system will be multi-programming operating system. The third type will be multitasking operating system. Batch operating system, multi-programming operating system, and multitasking operating system. A part of this, this multitasking operating system is also called as your shared, time shared operating system. Time shared operating system. Then we can also have a real-time operating system. Correct. Again, there are a lot of different types of OS. So हम लोग वो सभी के बारे में discuss करेंगे. We will discuss all of them one by one. So first we will start with the batch operating system. So this batch operating system was introduced in 1970s. तो 1970s में और 1960s में I should say instead of 1970s, because 1970s itself is a very good time. I mean, we progressed a lot in 1970s. So in 1960s there used to be batch operating system. So what does this batch operating system is? In 1960s आपके पास जो कंप्यूटर्स होते थे, these computers are very very big. Computers are very big. Computers were actually are very huge, or you can say very big, right? And everyone cannot afford the computers. उस समय पर सभी जो लोग हैं वो computers afford नहीं कर सकते थे. So there used to be big organizations who used to afford the computers. Like you have organizations, for example, you have IBM. So IBM used to have a mainframe computer, right? So initially in 1960s when everything started, so these computers, they you can input the program into these computers by using punch card. तो वहाँ पर हमारे पास कुछ punch card हुआ करते थे. Using these punch cards we can give some input to the computers, and these punch cards are basically metallic plates like this. और जो प्रोग्राम है, so these programs are written in binary in these punch cards. आप इन सभी punch cards पर अपने प्रोग्राम को binary फॉर्म में लिखते थे. So there are a lot of punch cards like this. So every company, I mean most of the companies, they cannot afford the operating systems or they cannot afford the computers. ज़्यादातर लोग हैं जो computers को afford नहीं कर सकते थे. So what they used to do is they used to give these punch cards to someone called as an operator. एक computer operator होता था. तो जितनी भी companies हैं, for example we have a company which is Microsoft, we have a company which is maybe Oracle, we have a company which is maybe Apple, some company, right? So all of these companies used to make their programs. They used to punch these programs into these punch cards. और ये जो punch cards हैं, these punch cards are basically metallic plates where we write the program in binary, and then these companies used to submit this program to this operator, and further this operator used to make batches of these program. ये इन सब के batches को बना देता था. So what does this batches says? Batches means you are going to organize these programs according to their requirement. इन सभी प्रोग्राम्स को हम उनकी रिक्वायरमेंट के हिसाब से ऑर्गेनाइज करेंगे. द प्रोग्राम्स विद सिमिलर काइंड ऑफ रिक्वायरमेंट्स आर बैच्ड टुगेदर एंड द प्रोग्राम विच इज़ हैविंग अगेन जिन सभी प्रोग्राम की सेम टाइप की रिक्वायरमेंट होती थी हम सबको एक तरीके से बैच में बना देते थे. एंड इन दिस सेम वे वी मेक मल्टीपल बैचेस. आप यहाँ से मल्टीपल बैचेस भी बनाते थे. ओके, एंड देन वी गिव दीज बैचेस टू योर कंप्यूटर्स टू एग्जीक्यूट एंड देन कंप्यूटर प्रोसेसेस दीज प्रोग्राम्स एंड देन कंप्यूटर गिव्स अस द आउटपुट. जो कंप्यूटर जो है वो इस प्रोग्राम को प्रोसेस करता था और फर्दर जो है कंप्यूटर वहाँ से हमें एक आउटपुट को जनरेट करता था. सो व्हेन आई से रिक्वायरमेंट ऑफ अ प्रोग्राम, so there can be different requirements. For example, there's a requirement which is called as a CPU time. CPU time is the time at which the process is going to perform its CPU calculations. जो जिस टाइम पर अपनी जो प्रोसेस है वो CPU के अंदर कैलकुलेशंस परफॉर्म करती है, दैट इज़ कॉल्ड एज योर CPU टाइम. एंड सेकंड इज योर इनपुट आउटपुट टाइम, दैट इज IO टाइम. So the time at which the process is giving some input to the user or taking some input from the user, that is called as your IO time. So from the user maybe some other program. तो जो प्रोसेस जो है अगर वो किसी और यूज़र से या किसी प्रोग्राम से इनपुट ले रही है या इनपुट दे रही है, दैट इज़ योर IO टाइम. सो अगेन द प्रोसेसेस और दीज प्रोग्राम्स आर हैविंग डिफरेंट काइंड्स ऑफ रिक्वायरमेंट. कुछ ऐसी प्रोसेस हैं विच आर CPU इंटेंसिव प्रोसेस. CPU इंटेंसिव प्रोसेस मीन्स द प्रोसेसेस विच रिक्वायर मोर CPU टाइम. ऐसी जो भी प्रोसेसेस हैं जिनको ज़्यादा CPU टाइम की रिक्वायरमेंट होती है एज कम्पेयर टू इनपुट आउटपुट टाइम, दोज प्रोसेसेस आर कॉल्ड एज CPU इंटेंसिव प्रोसेसेस. द प्रोसेसेस विच रिक्वायर मोर CPU टाइम एंड लेस IO टाइम, दे आर CPU इंटेंसिव प्रोसेस. And when we say we have a IO intensive process, that means a process which require more input output time and less CPU time, that is called as IO intensive processes. ठीक है, ऐसे प्रोसेसेस जिनको ज़्यादा CPU टाइम चाहिए और कम इनपुट आउटपुट टाइम चाहिए, तो जिनको ज़्यादा CPU टाइम चाहिए और कम इनपुट आउटपुट टाइम चाहिए, दे आर कॉल्ड एज CPU इंटेंसिव. द प्रोसेसेस विच रिक्वायर मोर इनपुट आउटपुट टाइम एंड लेस CPU टाइम, दे आर कॉल्ड एज IO intensive. Okay, so the processes which are having same kind of requirement, I mean we are going to group together all the processes which are CPU intensive processes. जितनी भी CPU इंटेंसिव प्रोसेस है हम सबको एक साथ ग्रुप कर देंगे, और जितनी भी IO इंटेंसिव प्रोसेस है वी आर गोइंग टू ग्रुप ऑल दोज प्रोसेसेस टुगेदर. तो IO इंटेंसिव प्रोसेस को हम एक साथ ग्रुप कर देंगे. सो बेसिकली वी आर गोइंग टू मेक डिफरेंट बैचेस ऑफ दिस प्रोसेसेस एंड देन वी आर गोइंग टू गिव दीज बैचेस टू दिस कंप्यूटर एंड द फर्दर द कंप्यूटर इज गोइंग टू प्रोसेस दीज प्रोग्राम्स एंड देन कंप्यूटर विल गिव आउटपुट. जो कंप्यूटर है वो इन सभी प्रोग्राम्स को प्रोसेस करेगा और जो कंप्यूटर है वो हमें फिर आउटपुट को दे देगा. ठीक है, so that is your batch operating system. Fine, is it clear so far? So if you look at this batch operating system in more details, so that means a new program is created. You give this new program to something called as a ready queue, and further from this ready queue you select a program, you give it to CPU for execution, and then the program go to a termination state. Right? So what do I mean to say by this is, देखो, this is your secondary memory, this is your main memory, and this is your CPU. So when a new program is created, that program is present in the secondary memory. जब एक न्यू प्रोग्राम क्रिएट होता है तो उस समय पर जो प्रोग्राम है वो सेकेंडरी मेमोरी पे होता है. Then you take the program from the secondary memory and you put this program in the main memory. आप इस प्रोग्राम को मेन मेमोरी के अंदर डाल देते हैं, right? So when the program is present in the main memory, that means the program is in the ready queue. उस समय पर प्रोग्राम जो है वो रेडी क्यू के अंदर है. So we are going to maintain a queue here which is called as a ready queue. And further you take the program from here and you give it to a CPU for execution. So हमने इस प्रोग्राम को CPU के अंदर एग्जीक्यूशन के दे दिया. So here the program is present in the CPU. Here the program is present in the main memory and here the program is present in the CPU. And as soon as the program finishes its task, so when I say the program is in CPU, that means here in this case the program will finish both its CPU time as well as the program will finish both its IO time. Okay, let me repeat again. देखो, in case of batch operating system, we do not have a concept of preemption. यहाँ पर preemption का concept नहीं होता है. We do not have a concept of preemption. So we'll discuss what is a preemption later on. So what I'm saying here is that when you give a process to the CPU, the process will vacate the CPU as when the process is completely finished. Process जो है वो CPU को तभी vacate करेगा जब process completely finish हो जाएगा. जब process completely ख़त्म हो जाएगा तभी वो CPU को vacate करेगा. Otherwise the process will not vacate the CPU. Okay. So when I say process execution process finish हो गया, that means the process has to finish both its CPU time as well as both of its IO time. The process को अपना CPU time और input output time दोनों finish करना है, then only we can say the process is finished. Otherwise the process will not be finished. Okay. So then as soon as the process finishes all its time, it will be sent for termination. जो process है हम उसको termination state पर भेज देंगे. Okay. That is done in batch operating system. Okay. Then we have a multi-programming operating system. So what does this multi-programming operating system says? So this multi-programming operating system tries to remove the limitation of batch operating system. तो batch operating system में जो भी limitations थी, so this multi-programming operating system tried to remove that limitation. So what was that limitation? Limitation is when you are going to execute a process, the process requires both CPU time as well as the process requires an IO time. So when the process is doing input output in that time, during that time the CPU will remain idle. तो उस समय पर जो CPU है हमारा वो idle रहता है, right? So that means CPU is not performing any meaningful task in that case. So that is a wastage of CPU time. तो वो जो time है उसमें हम CPU time को waste कर रहे हैं. Okay. So this multi-programming operating system tried to utilize that time by introducing a concept of waiting state. तो हम एक waiting state के concept को हमने यहाँ पर introduce किया. What do I mean to say by this is, so you have a new process. So when a new process is created, that means the process is in secondary memory. Fine. Then you give this process, you take this process from secondary memory and you put this process in a ready queue. So ready queue means the process is currently in the main memory. Fine. Then you select all of one process out of these processes. जितनी भी processes ready queue में है तो हम उन सब में से एक process को select करेंगे and you give this process to the CPU for execution, right? So maybe you are having 5 or 6 processes. Maybe you have a process P1, you have a process P2, you have a process P3, you have a process P4. There are more than one processes which are present in the ready queue at the same time. Fine. So you have given the process P2 for execution in the CPU. अपने process P2 को CPU के अंदर execution के लिए दिया. Okay. Now when the process P2 is performing CPU, that means it is executing in the CPU. But if the process P2 is going to perform input output, अगर process P2 जो है वो input output को perform करता है, that means I can take this process P2 out of the CPU and I can put it in something called as a waiting state, or you can say waiting queue, right? So that means if a process is performing input output, in that case put the process in the waiting queue, and as soon as the process finished its input output, you are again going to put the process in the ready queue. जैसे ही process अपना waiting state यानी कि input output को finish करेगा, आप दोबारा से process को ready queue में डाल दीजिए. And if the process finished both of its input output as well as CPU time, then you are going to take this process to the termination state. Okay. So here you can see if the process is in CPU execution, that means it is in the CPU. Here the process is in main memory and here the process is in secondary memory. Okay. Let me explain you with the help of a diagram here. This is your secondary memory. This is your main memory and this is your CPU. ठीक है. अब जब भी एक न्यू प्रोसेस क्रिएट होगी, सो न्यू प्रोसेसेस विल बी इन द सेकेंडरी मेमोरी. ठीक है. सो दीज ऑल आर द न्यू प्रोसेसेस. When you are going to execute a process, that means you will take these processes from secondary memory and you are going to maintain a queue here in the main memory which is called as a ready queue, और इस ready queue के अंदर you are going to put all of these processes which are available for execution. जो processes execution के लिए available है हम सभी को ready queue में डाल देंगे. Now your CPU scheduling algorithm will select one of these process. इसमें से किसी एक process को CPU scheduling algorithm select करेगी and then we will take this process to the CPU. अब हम इस process को CPU के अंदर लेकर आ जाएंगे. Now this process require both of its CPU time as well as is also going to perform input output, right? यानी कि when the process requires a CPU time, that means the process is executing in the CPU. But if the process needs an IO, अगर process को input output को perform करना है, that means taking some input from the user or giving some output to the user, then in that case we are going to put this process in something called as a waiting state, or you can say waiting queue. So this process P3 will be in the waiting queue. So when the process P3 is in the waiting queue, in that time, during that time, we can bring another process P4 in the CPU. उस समय पर हम एक दूसरी process P4 को CPU के अंदर लेकर आ सकते हैं. And then, as soon as the process P3 finishes its waiting time, that is IO, it is again put back in the ready queue. हम दोबारा से P3 process को ready queue के अंदर डाल सकते हैं. So this is your multi-programming operating system. So multi-programming operating system will remove the limitation of batch operating system. That means it reduced the CPU idle time. CPU idle time. यानी कि जिस समय पर CPU खाली बैठा हुआ था तो हम multi-programmed operating system ने उस time को utilize किया, because when the CPU is sitting idle in that time, we can bring another process from the ready queue for execution and we can put current process in the waiting state. ठीक है, तो इससे हमने CPU idle time को reduce करने की कोशिश की. That is your multi-programmed operating system. So we have seen two types of operating system. The first was your batch operating system and second was your multi-programmed operating system. Right? So what was the limitation of batch operating system? So the limitation of batch operating system was very simple, that it is having CPU idle time. I mean, CPU is not utilized efficiently. Right? CPU जो है वो efficiently utilized नहीं होता है. Okay, let me show you an example. This is a very interesting example for all of you. Let us assume, let every process requires 60% CPU time and 40% IO time. अगर हर एक प्रोसेस को 60% CPU टाइम चाहिए और 40% IO टाइम चाहिए, then what will happen in that case? So this is your main memory and this is your CPU. ठीक है? So in that case we have processes P1, P2, P3 and P4. So you will take the process P1 from the main memory, you will put the process P1 in the CPU. So P1 process will utilize the CPU 60% of the time. 60% of the time the CPU is busy and rest 40% of the time the CPU will be idle. As soon as the P1 process finished both of its time, then we can take this P1 for termination state and then we can bring the process P2. जैसे ही आप process P2 को लेकर आएंगे, again the process P2 is going to utilize the CPU for 60% of the time and the 40% of the time the CPU will remain idle. 40% time CPU जो है वो दोबारा से idle रहेगा. Then we can as soon as the P2 is finished, जैसे ही P2 finish होगा, we can bring the process P3. So again this P3 process will utilize the 60% of the time in the CPU and 40% of the time of the CPU will remain idle. तो 40% time जो CPU है वो idle रहेगा. So during the execution of these three processes, out of this 300% of the time, the CPU was utilized 180% of the time and total 120% of the time the CPU was idle. I mean to say कि आपके पास overall 40% टाइम जो है वो CPU idle रहेगा. 40% टाइम CPU will not be performing any task or any operation in batch operating system. But if you look at this multi-programmed operating system, what can happen in multi-programmed? This is your CPU and this is your main memory, right? So what we can do is, if we have these multiple processes here, अगर आपके पास यहाँ पर multiple process हैं, so take first process P1 in the CPU. हमने P1 process को CPU के अंदर डाला. So this P1 process will, utilize 60% of the time, and as soon as this P1 process requires this input output, जैसे ही P1 process को इस input output की requirement होगी, in that case we can take P1 process out of the CPU and we can give P2 process in the CPU. तो इस समय पर हम P1 process को CPU से बाहर लेकर आएंगे और P2 process को CPU के अंदर डाल देंगे, right? So this is total, you can see 40% of the time the P1 process is doing output, and this 60% of the time the P2 process is present. ठीक है? Or if I try to draw it in a better manner, I can draw it this way, that the first, this is for the P1 process, this is the 60% of the time when the CPU is busy, and when the 40% of the time when the CPU is idle, in that case I can bring the process P2 in the CPU. So process P2 will again make the CPU busy for 60% of the time. Again, when the 40% of the time the CPU is idle, I can bring the process P3 in the CPU. तो हम process P3 को CPU के अंदर डाल सकते हैं. Again the process P3 will make the CPU busy for 60% of the time, and rest 40% of the time the CPU will remain idle, right? So if you look at this total time, अगर आप इस पूरे total time को check करेंगे, so how much time it is? So it is 60 plus 60 plus 40, right? So which is 180 plus 40, which is 220% of the time. Out of this 220% of the time, 180% time the CPU was busy, right? And rest of 40% of the time the CPU was idle. ठीक है, तो यहाँ पर आप चेक करोगे the total overall CPU utilization has improved. ज़्यादा जो CPU utilization है वो improve हुआ. So in this case the CPU utilization was 60%. So how I calculate 60%? So this is 180 divided by 300 into 100. So if you calculate this value, so this is basically 60%. तो यहाँ पर CPU utilization 60% था, and rest 40% of the time the CPU was idle. But in the second scenario, if you do 180 divided by 220 multiplied by 100, so you can calculate how much time the CPU was idle. ठीक है, so it is 1800 divided by 220 divided by 20. If you calculate this value, let me do this calculation. So it is total 1800 and divide by 22, so it comes out to be 81.81. so this value is 81.81. so basically you can see the CPU is utilized 80% of the time. So CPU efficiency has improved. CPU की जो efficiency है वो ज़्यादा improve हो गई. Again if you see, if you have more number of processes, अगर इससे ज़्यादा processes है, so maybe you can have 5 process, maybe you can have 6 process. In case of multi-programmed operating system, the efficiency of the CPU will be high. यहाँ पर CPU की जो efficiency है वो higher रहेगी, और in case of batch operating system, the CPU efficiency will be low. So because the CPU efficiency is high, right? So because यहाँ पर CPU efficiency high है, therefore the throughput of the system will increase. Throughput of the system will increase. Correct? So what do you mean by throughput? Throughput means what is the jobs completed per unit time. Jobs completed per unit time. Per unit time पर कितनी jobs complete हो रही है, और can say how many processes you are completing per unit time. That is your throughput of the system. So in case of multi-programmed operating system, the throughput of the system is very high as compared to the batch operating system. Batch operating system से ज़्यादा जो throughput है system का, वो multi-programmed operating system में high रहेगा. Okay, correct? So that means in case of batch OS, the efficiency of the system is low. In case of multi-programmed OS, the efficiency of the system will be high. यहाँ पर जो system की efficiency है वो high रहेगी, और batch operating system में system की efficiency low रहेगी. Okay. Second, the throughput of the system will be low in batch operating system, and the throughput of the system will be high in multi-program operating system. That means tasks completed per unit time will be more in multi-programming operating system. Multi-programming operating system में जो per unit time पर जितने टास्क कंप्लीट होंगे वो ज़्यादा रहेगा as compared to the batch operating system. If it is clear, is there any scenario where batch operating system can be beneficial? क्या ऐसा कोई scenario है जहाँ पर batch operating system beneficial हो सकता है? Yes, there is one scenario. And what is that scenario? The scenario is very simple. If your processes are CPU intensive processes, अगर आपकी जो processes है वो CPU intensive processes हैं, in that case the batch operating system will be very beneficial. Correct? So that means if let us suppose if every process require 100% CPU time, then batch operating system will be better as compared to any other operating systems. Okay. Secondly, what is the limitation of multi-programming operating system? यहाँ पर इसकी limitation क्या है? What is the limitation of multi-programming operating system? The limitation is very simple. That means you cannot assign priorities to the process. आप यहाँ पर प्रोसेस को प्रायोरिटीज असाइन नहीं कर सकते. वी आर नॉट एग्जीक्यूटिंग processes according to their priorities. Okay, so I mean to say preemption is not there. If preemption is there, अगर preemption होता है then implementing the priority becomes easy. If preemption is there, then implementing the priorities become easy. But in case of multi-programmed operating system, we do not have preemption. In case of batch operating system also, we do not have preemption. यहाँ पर हमारे पास preemption नहीं है. Batch operating system में भी preemption नहीं होता और multi-programmed operating system में भी preemption नहीं होता. Okay. Now what do you mean by preemption? Preemption का मतलब क्या है? देखो, whenever a process is being executed in the CPU, जैसे ये आपका CPU है and you have multiple process P1, P2, P3 and P4. Let us assume जो process P1 जो है वो CPU के अंदर execute कर रहा है. So whenever a process is being executed in the CPU, now during execution, if you can forcefully take the process out of the CPU, that is called as preemption, right? Preemption का मतलब क्या है? It is pre plus empty. Preemption means it is pre plus empty, यानी कि किसी प्रोसेस को ज़बरदस्ती CPU से बाहर निकालना, किसी प्रोसेस को फोर्सफुली CPU से बाहर निकालना, that is called as preemption. If you are going to take one process out of the CPU forcefully, that is preemption. Okay. So let us assume we have a process P1 which is present in the CPU. It is being executed in the CPU. Now we have a process P2 and the priority of P2 is high. Priority of P2 is high. तो P2 की प्रोसेस की जो प्रायोरिटी है वो P1 से ज़्यादा है. That means I can take this P1 process forcefully out of the CPU, and I can put this process P2 inside the CPU. हम P1 को forcefully CPU से बाहर निकाल कर P2 प्रोसेस को CPU के अंदर डाल सकते हैं. Now that is called as preemption. Okay, so it is more like, for example, this is your maybe public toilet, okay, who is using the washroom very happily, fine, and suppose there is a very important person who just arrived, and the important person is Narendra Modi, right? So you can see Narendra Modi is having very high precedence as compared to Jay, right? So because Narendra Modi is such an important person, and even though Jay is currently using this washroom, and Narendra Modi also want to use a washroom, so what will do? The guards of Narendra Modi will throw Jay out of the CPU. जो भी guards होंगे नरेंद्र मोदी के, वो जय को मतलब public toilet से बाहर निकाल देंगे, so that he can go inside the CPU, right? So you will be forcefully taken out, right? And he will not be very happy. So you will be forcefully taken out. So this condition here is called as preemption. So if this cannot happen, that is a scenario which is no preemption. So no preemption means if preemption is not possible, that is a case of no preemption. Fine. Yes, when we do input-output operation, in that case, the process is voluntarily removed from the process voluntarily releases the CPU in case of मल्टी प्रोग्राम्ड ऑपरेटिंग सिस्टम, उस केस में प्रोसेस जो है वो वॉलंटरली रिलीज करती है. ओके, सो ड्यूरिंग प्रीएम्पशन वी आर फोर्सफुली टेकिंग आउट. In case of multi-programmed, it is voluntarily releasing the CPU. Okay. So then we have a concept of multitasking operating system. Multitasking operating system. Okay. So what is this multitasking operating system? It is a multi-programming operating system. It is a multi-programming operating system with some preemption. Multi-programming operating system with preemption. So that is called as your multitasking operating system. What do I mean to say by this multitasking operating system? A new process is there. So that means the process is in secondary memory. You take this process to a ready state. That means the process is in main memory. You can take this process from ready state to the CPU for execution. And further from the CPU, you can forcefully take the process out to the CPU. You can put this process in the ready state, and then the process can also go for termination. Correct? So in case of multitasking operating system, we also have a concept of a waiting state. Like this. Okay, so this is your multitasking operating system. That means if a process which is having a higher priority needs the CPU, then we can take a lower priority process out of the CPU. Okay. Plus we also add a concept of round robin. We also add a concept of round robin. Okay. What do I mean to say by this round robin concept? Dekho, if you go to a movie theater, right? So we have, let me also show you with the help of an example. So movie theater mein you have a projectors, right? Movie projectors. With reel. Right, so if you have seen this movie projector, so these movie projectors, you can see we have something which is rotating here. Just see this example. Let me explain you the concept first, then maybe you can figure out what we are doing here. ठीक है. So होता क्या है in those projectors? What happens in those projectors? This is your projector. So projector is just basically a light. Projector जो है वो सिर्फ एक light की तरह ही है, and it is going to throw some light on the white screen. This is your screen. It is going to throw some light on this screen. Correct? Now what we do is we add a reel here, which is basically just a sequence of images. जो reel है वो sequence of images हैं, and this reel is organized like this. तो यहाँ पर क्या है, you have a lot of images here. This is a man, this is a man walking, this is a man doing something, this is a man doing something like this. This is the reel, right? And this is basically, this is called as a frame of the reel. इसको हम बोलते हैं frame. So what we do is, when the movie is in progress, that means this reel is moving from this projector, and when this projector puts a light on this reel, it creates an image on the screen. तो यहाँ पर इस screen के ऊपर कुछ image create होती है. And what we do is we project 24 images per minute. Sorry, per second. We project 24 images per second on the screen, and it feels like the character of the movie, they are walking, they are talking, they are performing some task and so on. Correct? तो होता क्या है कि यहाँ पर जो रील है उसके ऊपर कुछ लाइट थ्रो होती है, and it shows 24 images per second on the screen, and we feel like जो यहाँ पर audience है, any audience here is there, so this audience will feel like the person on the screen, they are performing some task. The person on the screen, they are walking. The person on the screen, they are talking. they're performing some dance sequence and so on, right? तो यहाँ पर they are going to project this images at such a high pace कि human eyes detect नहीं कर पाती कि that these are still images or these are moving images. तो human eyes से हमें पता नहीं चलता कि still images हैं या फिर ये moving images है. This is how the projector in the movie theater works. In the same way, when you have this multitasking operating system, this multitasking operating system performs the task in the similar fashion. What does it do? This is your CPU, and these are the processes: process P1, P2, P3, P4, and P5. So in case of multitasking operating system, you are going to take one process P1 in the CPU. You are going to execute this process in the CPU for some time. Maybe it is 2 nanosecond. हमने 2 nanosecond तक process P1 को CPU के अंदर execute किया. Then we can take this process P1 out of the CPU and we can put the process P2 inside the CPU. Right? Again, we are going to execute the process P2 for 2 nanosecond. Again, we can take this process P2 out of the CPU. Again, we can put the process P3 in the CPU for 2 nanosecond और फिर हम process P3 को निकाल देंगे. So in the same way, we are going to perform this cycle again and again. इस cycle को हम continuously perform करेंगे and for us it will feel like all of these processes are working simultaneously. हमें ऐसा लगेगा कि जितनी भी processes हैं ये simultaneously काम कर रही हैं, but this is not the case. Just for example, you are seeing me on the screen, right? आप मुझे screen पर देख पा रहे हैं. When I am present on the screen, then I also have a camera, right? So this camera itself is creating a process. I also have a display, screen display, right? I also have this pen application, right? So or you can say this pen software. I also have various software, or maybe I can also have a web browser. A lot of processes are there and all these processes are working simultaneously. तो मुझे क्या लगता है कि मेरी जो स्क्रीन है इसमें सब कुछ पैरेलली चल रहा है, but this is not the case. Each of these applications are executing for some time unit and तो कुछ टाइम यूनिट तक सभी processes execute हो रही हैं और and I feel like everything is working parallelly, correct? If you look at it here, I can go to this task manager in my operating system. In my task manager, you can see the details of all of these processes which are running. So we have a background process, we can also have applications which are running, okay? And I can also go to details here. So it is showing all the processes which are running on my system. जितनी भी processes मेरे system पर चल रही है, I can see all of these processes. I can see their process IDs, I can see their status, whether they are running, whether they are terminated, whether they are suspended. You can see some of my processes, like for example Skype, Search UI, some of these processes are suspended, right? And some of these processes are running. Okay, and I can also see the history for each of these process. That means which process is utilizing how much amount of memory. तो यहाँ पर आप देख सकते हैं, you can see the entire data here. You can see that I have total of 197 process in my CPU in my system. Out of these 197 processes, my CPU utilization is 36% to 39%. This is my average CPU utilization, and this is the speed of my CPU on which my CPU is currently performing. ठीक है, तो आप यहाँ से देख सकते हैं multiple processes are working parallelly. So but all of these processes are not getting the CPU at the same time. सभी process को CPU एक समय पर नहीं मिल रहा, but these processes are performing a round robin fashion. That means these processes are getting executed in the CPU for some time, and then again the process is taken out from the CPU, again next process is put in the CPU. Okay, so that means when you have a batch operating system, in case of batch operating system, a new process is created. You give this process to the ready state, and from this ready state the process will go to the CPU for execution, and from CPU the process will go for termination. Then we have a multi-programmed operating system. So in case of multi-programmed operating system, a new process is created. The process can go from secondary memory to the main memory in the ready state. Then again the process will go to the CPU. Here we have a concept of a waiting state. That means अगर किसी process को IO perform करना है, that means the process can be taken to the waiting state, and from the CPU we can take the process to the termination state. And then we have multitasking operating system. In this multitasking operating system, you have a new process. You can take the process from second memory to the main memory from ready state. From here we can take the process to the CPU, and from CPU we can take the process back to the ready state. CPU से process जो है दोबारा से ready state पर भी आ सकती है यहाँ से ऐसे, and then the process can also go to the termination state. And here we also have a concept of a waiting state. यहाँ पर आपके पास waiting state का भी concept होता है. See, the first chapter is completely theory. तो आज का जो session है, the first session is more about theory rather than any numericals. आज session में हम लोग सिर्फ theory ही cover करेंगे. Maybe in tomorrow's session we will take numericals, and today we are just taking theory. ठीक है? Fine. Now this multitasking operating system, as I said, this multitasking operating system can be categorized as multitasking, or it can also be categorized as time shared operating system. So time shared means, when I say we have a time shared operating system, right? So this is time shared means it is multitasking plus round robin. टाइम शेयर का मतलब है कि मल्टीटास्किंग ऑपरेटिंग सिस्टम में हम अगर राउंड रॉबिन को जोड़ देंगे, सो दैट इज कॉल्ड एज योर टाइम शेयर्ड ऑपरेटिंग सिस्टम. मल्टीटास्किंग मीन्स वी कैन ऑल्सो असाइन प्रायोरिटीज. मल्टीटास्किंग मीन्स we can assign priorities to the process. That means we can execute a higher priority process over a lower priority process. Okay, so generally what happens is this multitasking and time shared both are considered as same. हम दोनों को सेम ही कंसिडर करते हैं. Only in a very few books they have given a difference between multitasking and time shared. काफ़ी कम books में इनके बीच में difference दिया गया है, but in most of the cases we consider multitasking and time sharing as the same. Okay, so what is this priority? देखो, if a process is currently executing in the CPU and there's a process P2 which is having a higher priority, it is a higher priority process. If a higher priority process arrived in the CPU arrived for execution, then we can take this lower priority process out of the CPU. हम इस lower priority process को CPU से बाहर लेकर जा सकते हैं, and we can execute this higher priority process in the CPU. Okay, if you see in your system also, in your Windows maybe, you can see the details of each of these processes. For example, you have a Google Chrome as a process. You can have a lot of different processes there. So let me arrange them according to CPU utilization. So various processes are there. So you can click on one process. You can just do a right click on this, and you can see set priority. So you have a priority which is a normal priority, which is above normal. You have a higher priority. We have a real time process, right? तो आप किसी प्रोसेस की प्रायोरिटी को इंक्रीज कर सकते हैं. फॉर एग्जांपल, आई हैव दिस OBS सॉफ्टवेयर, सो आई कैन चेंज द प्रायोरिटी टू द अबव नॉर्मल प्रायोरिटी. तो अब जो OBS की जो प्रायोरिटी है वो यहाँ से अबव नॉर्मल हो गई है, राइट? आई कैन अगेन चेंज द प्रायोरिटी टू द नॉर्मल प्रायोरिटी. तो हम एक प्रोसेस की प्रायोरिटी को चेंज की जा सकती है, बट जनरली द प्रोसेस प्रायोरिटी इज जनरली सेट बाय योर ऑपरेटिंग सिस्टम. आपका जो ऑपरेटिंग सिस्टम है वही प्रोसेस की प्रायोरिटी को सेट करता है. वी डू नॉट रियली हैव टू सेट द प्रायोरिटीज़, बट अगेन इफ़ यू वांट टू डू इट, डेफिनेटली यू कैन चेंज द प्रायोरिटी ऑफ अ प्रोसेस. आप किसी प्रोसेस की प्रायोरिटी को भी चेंज कर सकते हैं. क्लियर? फाइन. एंड नेक्स्ट वन इज योर रियल टाइम ऑपरेटिंग सिस्टम. So what are these real-time operating systems? So real-time operating system is an operating system where we cannot have delays. We cannot have delays. आप यहाँ पर delays नहीं ले सकते. We cannot have delays in a real-time operating system. Okay. So just for example purpose, assuming that this is an aircraft. This is your aircraft, right, like this, and this is your Indigo flight with Arnab Goswami in this, right? So this is your Indigo flight. Okay, now in this Indigo flight it's also using an operating system. ये एक operating system को use करता है, correct? So when the pilot says I want to land the plane, so this flight will try and land on this runway. जो ये फ्लाइट है ये रनवे पर लैंड करने की कोशिश करेगी. ओके, नाउ लेट अस अज्यूम देयर इज अ गाय हियर. व्हाट ही डज इज ही जो ऑपरेटिंग सिस्टम है ट्राइज एंड डिले दिस लैंडिंग टास्क, यानी कि वो कोशिश करता है कि जो हमारा ऑपरेटिंग सिस्टम है वो स्लो बिहेव करे, वो थोड़ा स्लो चले, राइट. सो व्हाट विल हैपन, दिस फ्लाइट फ्लाइज एट ए वेरी वेरी हाई स्पीड. So generally the flight flies at 900 kilometers per hour, or at minimum you can see on an average these domestic flights they fly at 600 kilometers per hour. तो जो आपकी डोमेस्टिक फ़्लाइट है वो 600 किलोमीटर्स पर आवर के अकॉर्डिंगली फ्लाई करती है. एंड देन यू हैव इंटरनेशनल फ्लाइट, दे जनरली डू 900 किलोमीटर्स पर आवर और 1000 किलोमीटर्स पर आवर, समथिंग लाइक दैट. ओके, सो 600 kilometers per hour means in 60 minutes the flight travel to 600 kilometers, or you can say in 1 minute the flight takes 6 kilometers. एक मिनट में फ्लाइट जो है वो 6 किलोमीटर ट्रैवल करती है. ओके, so which is 600 divided by 60. If you see in 60 seconds the flight is traveling 6000 meters. So you can say in 1 second the flight is traveling 6000 divided by 60, which is equal to 100 meters. जो फ्लाइट है वो 1 सेकेंड में 100 मीटर्स तक ट्रैवल करती है. एंड दिस योर एंटायर रनवे इज, लेट अस अज्यूम इट इज़ 2 किलोमीटर्स. आपका 2 किलोमीटर का रनवे है एंड दिस फ्लाइट नीड्स मे बी 1 किलोमीटर ऑफ रनवे. इसको कम से कम 1 किलोमीटर का रनवे चाहिए. नाउ व्हाट डज दिस गाय डू? What does this guy do? He performs some operation. He performs a DOS attack on this operating system of this flight, so that the flight operating system respond 10 second slower. जो इसका जो ऑपरेटिंग सिस्टम है वो 10 सेकेंड तक स्लो काम करेगा. सो इफ़ दिस ऑपरेटिंग सिस्टम ऑफ दिस फ्लाइट विल बी स्लो बाय 10 सेकेंड, व्हाट विल हैपन? इन दोज 10 सेकेंड्स द फ्लाइट विल ट्रैवल अनदर 1 किलोमीटर. जो फ्लाइट है वो अगले 1 किलोमीटर तक ट्रैवल करेगा. एंड फर्दर देन एज सुन एज द फ्लाइट विल ट्राई एंड लैंड, सो द फ्लाइट विल गो टू इट विल एंड द रनवे. तो फ्लाइट जो है वो रनवे को एंड कर देगा, देन दिल बी कबूम, राइट. तो होगा क्या? सिंपली इट्स वेरी सिंपल. इफ़ in these kind of applications where we cannot accept any kind of delay, if some delay is introduced, then your applications will lose the task, या फिर applications will fail. जैसे कि in this case if you delay the operating system of the flight, then instead of landing here where the flight was supposed to be landing, we are landing somewhere here. तो अब यहाँ से आप यहाँ पर land कर रहे हैं, so which is wasting a lot of time and which is wasting a lot of space here, so the flight will not be able to land properly. ठीक है. So in these scenarios we need something called as a real-time operating system where the delays where delays cannot be introduced. Somehow delays introduce नहीं किए जा सकते. Somehow we have to make the operating system such a way that nobody can introduce delays in them. So these real-time operating system are mostly hardwired operating system. Hardwired operating system, that means you cannot change the operating system on the device. आप device के operating system को change नहीं कर सकते. It is embedded in the hardware. The operating system itself is embedded in the hardware. See, let me give you an example. If you have your Windows, right, on your PCs or computer systems, you can uninstall this window, you can insert a Mac in this. आप यहाँ पर Unix को इंस्टॉल कर सकते हैं, you can install a Linux in this, right? तो आप अपने ऑपरेटिंग सिस्टम को चेंज कर सकते हैं. You can change operating system on your computer systems, right? So that means these operating systems here on your systems or on your machines, they are not hardwired. वो hardwired नहीं है. They are just a software based operating system, and these software based operating system can change, right? So once you install a window, next time you can install a Mac on the same hardware. आप same hardware Mac को install कर सकते हैं. So whenever you have a software based operating system, then there's a possibility, there's a chance that somehow that operating system might be slow. किसी केस में ऑपरेटिंग सिस्टम स्लो हो सकता है, मे बी आई एम यूजिंग मल्टीपल प्रोसेसेस. अगर मैं इस समय पर ड्यूरिंग दिस क्लास इफ़ आई ट्राई एंड कॉपी वन फाइल फ्रॉम वन ड्राइव टू अनदर ड्राइव, इट माइट हैपन दैट विल स्लो माई ऑपरेटिंग सिस्टम. इफ़ आई परफॉर्म सम हाई कंप्यूटेशनल टास्क, अगर मैं कोई बहुत ज़्यादा कंप्यूटेशनल टास्क करूँगा तो उस कंप्यूटेशनल टास्क से भी मेरा जो ऑपरेटिंग सिस्टम है वो स्लो हो सकता है. सो दैट हाई कंप्यूटेशनल टास्क माइट ऑल्सो स्लो माई ऑपरेटिंग, might also delay the working or of my operating system. Okay, so in these cases we need real-time operating system which are hardwired. Hardwired means you cannot change these operating systems, you cannot they will not be having any kind of delay because they are embedded in the hardware. उनको हमने हार्डवेयर में एम्बेड किया हुआ है, so they are going to communicate well with the hardware and they need a special hardware support. रियल टाइम के लिए हमें स्पेशल हार्डवेयर सपोर्ट की ज़रूरत है. स्पेशल हार्डवेयर सपोर्ट्स आर रिक्वायर्ड फॉर रियल टाइम ऑपरेटिंग सिस्टम. इनके लिए हमें स्पेशल हार्डवेयर सपोर्ट की रिक्वायरमेंट होती है. ओके, सो दीज आर योर हार्डवेयर्ड ऑपरेटिंग सिस्टम विच आर रियल टाइम ऑपरेटिंग सिस्टम वेयर वी कैन नॉट हैव एनी काइंड ऑफ डिले. फाइन, एंड दैट मच वॉज एनफ. नाउ okay, let me open the book also. The book that, if you want to refer a book, so book for operating system is Galvin. So you can just do a simple Google search, you will find the same book here. I can just search it here, operating system Galvin PDF. You can just do a simple Google search and you will find that there are a lot of links which are available which are giving the same book. तो काफ़ी सारे लिंक्स अवेलेबल है यहाँ पर. यू कैन ओपन एनी वन ऑफ दिस बुक्स, आई मीन यू कैन ओपन एनी वन ऑफ दिस लिंक्स टू डाउनलोड द बुक. तो मे बी आई कैन सेव द बुक हियर. सो दिस द बुक दैट यू विल बी रेफरिंग फॉर ऑपरेटिंग सिस्टम विच इज़ Galvin. ठीक है. So in this Galvin book, this is the first introduction chapter. ये आपका introduction chapter है where you can go through all of these details. Let me zoom it up a little. So this introduction chapters covers the basic theory regarding operating system, that what is an operating system होता क्या है, and some operating systems are, you can see it here also, the operating systems are designed to be convenient, others are designed to be efficient, right, and the combination of two. But the operating system that we are studying, they are designed for convenience, they are not designed for efficiency. Okay, efficiency is a secondary core in those cases. Then they say what is an operating system does do, the operating system करता क्या है. So you can read all this theory from here. So it is a management of the resource manager. Operating system is more like a government. It does not perform any meaningful task, but it provides an environment. जैसे कि हमारे पास मोदी गवर्नमेंट है. So मोदी गवर्नमेंट is not doing any meaningful task, but it is only providing environment for us so that we can run our companies, we can परफॉर्म लॉट ऑफ ऑपरेशंस, हम अपना काम प्रॉपरली कर सके. तो गवर्नमेंट का काम बस यही है कि वो हमें एक एनवायरनमेंट को प्रोवाइड करे रेदर देन खुद से काम करने के लिए. तो गवर्नमेंट इज़ मोर लाइक एन एडमिनिस्ट्रेटर, राइट. तो द सेम वे ऑपरेटिंग सिस्टम इज़ देयर. like, so you can read it here, like a government, it performs no useful function by itself. Government खुद में कोई useful function perform नहीं करती. It simply provides an environment within which the other programs can do the useful work. Okay. Then you can see the theory regarding operating system, that operating system are designed for ease of use and the resource utilization will be the secondary purpose. So we have various kind of operating systems here. This is the definition of operating system, so you can skip it here. You can skip this part. So you have seen this memory organization. You have magnetic tape, optical disk, magnetic disk, registers, cache memory, the entire memory organization, memory hierarchy. So you can see this memory hierarchy. After this you can go through skip all this part. is not required. This is regarding the type of operating system that we have. So this is, we can have a multi-programmed operating system. आपके पास एक multi-programmed operating system हो सकता है. So this is an example here where we also have a time sharing operating system. We also have interactive operating systems. You can go through them. Dual mode operations. Skip all this part, it's not required. Cache memory is not required. Protection security is not required. So this is just example of operating system, that we have a real-time embedded operating system. We can have handheld operating system. So peer-to-peer operating systems, all these things. तो आप इसको study कर सकते हैं. Just go to the first chapter once. तो first chapter में आप इसको check कर सकते हैं. What are the different types of operating system are there? If you want to study from here, you can go through with it. So this is the introduction to operating system. You can go through this system conceptual view. Let me just submit. You can go through this. So you can see what is the purpose of operating system. This is a batch operating system, the theory regarding batch operating system. Then we have advantages. Then we have disadvantages. Priority cannot be set. CPU may remain idle for a long time. There's a lack of interaction between user and the CPU jobs. Then we have multi-programming operating system. Then we can see advantage and disadvantage of the same. Then you have multitasking operating system. And after this you have time sharing operating system. So then you can see the difference between time sharing, multi-programming and multitasking. Then we can have advantages of this. फिर आपके पास distributed operating system है, that you can do a self read by yourself. Then you have real time operating systems, and the types of real time operating system, we can have a hard real time as well as we can also have a soft real time operating system. Then this is the advantages of real time operating system. These are the disadvantages of real time operating system. Okay. Then we have these things we are going to cover later on. What is the 32-bit architecture? What is the 64-bit architecture? ये हम लोग बाद में cover करेंगे. Okay. So I hope that today's session was here just for example. It was more like a theoretical section. ये ज़्यादा theoretical section था. In the next section we will take numericals also. जो इसका second session हमारे पास रहेगा, उसमें हम numericals को discuss करेंगे. First session हमारा एक completely theory section था regarding the operating systems. So the topic for today's session is operating system, which is process management. Process management is the second chapter in operating system. Okay, and this chapter is interesting as well as so this chapter is interesting as well as this chapter is a kind of a chapter that you generally want to study. आप इस चैप्टर को जनरली स्टडी करना चाहेंगे because there are a lot of things that you will be able to relate after studying this chapter. Okay, so what does this process management says? We have seen the process cycle in the previous session. हमारे पास एक process state diagram था. So what was the process state diagram? We have a new process. When you execute this new process, so that means you take it from secondary memory to the main memory, and this new process go to a ready queue. इसको हम एक ready queue के अंदर लेकर जाते हैं. Okay. Now from this ready queue we take this process to the CPU for execution. So that is your execution state. From execution again you can take this process back to the ready queue. From execution you can take this process to the waiting state, and further from the waiting state itself you can take this process back to the ready queue. Now we also have one more additional state here which is called as a blocked state. आपके पास एक और state यहाँ पर होते हैं जिसको हम लोग बोलते हैं blocked state. And from blocked state from waiting state the process can go to a blocked state, and from blocked state the process can go to a waiting state. Further from blocked state a process can go to suspended ready state. So this blocked state can also be called as a suspended state. हम इसको suspended state भी बोलते हैं. You either call it as a blocked state or you can call it as a suspended state. Further from the suspended ready the process can go back to the ready state, and from this execution the process can go to a termination state. Right. So this is the general process state diagram. If you look at this process state diagram, If the process is new, that means the process is present in secondary memory. If the process is in ready queue, that means the process is present in the main memory. If the process is executing, that means the process is present in the CPU. If the process is in waiting state, that means the process is still present in the main memory. If the process is blocked or suspended, that means the process is present in the secondary memory. In the suspended ready queue, the process is present in the secondary memory. And when the process is terminated, it is still present in the secondary memory. Okay, so here I have introduced one more state here, which is called as a blocked state or suspended state. So first of all, let us look at what is this blocked and suspended state. Assuming that this is your secondary memory, this is your main memory, and this is your CPU. Fine. Now when you execute a process, that means you are taking this process from the secondary memory to the main memory. In main memory, I'm going to maintain a queue. So this process, let us suppose it is a process P1, so these processes will wait in this queue. Now out of these processes, which process we have to execute, that is taken care by the short term scheduler. And from secondary memory, which process we have to bring in the main memory, that is taken care by the long term scheduler. तो आपके पास you have something called as a long term scheduler, you have something called as a short term scheduler. So this transition is taken care by short term scheduler. And then you have something called as a medium term scheduler. So this transition is taken care by medium term scheduler. So what is the responsibility of long term scheduler? Long term scheduler की responsibility क्या है कि अगर secondary memory में एक से ज़्यादा processes available है, तो इसमें से हम किस process को main memory पर लेकर जाए execution के लिए. Again I am repeating, the responsibility of long term scheduler is to choose a process from the secondary memory to take this process to the main memory in the ready queue. अब सेकेंडरी मेमोरी से किस प्रोसेस को चूज़ करेंगे मेन मेमोरी पर लेके जाने के लिए रेडी क्यू के अंदर, तो दैट इज़ द रिस्पॉन्सिबिलिटी ऑफ लॉन्ग टर्म शेड्यूलर. देन इन द मेन मेमोरी, इफ़ मैनी प्रोसेसेस आर प्रेजेंट इन द रेडी क्यू, अगर एक से ज़्यादा प्रोसेसेस रेडी क्यू में प्रेजेंट है, इफ़ मैनी प्रोसेसेस आर प्रेजेंट इन द रेडी क्यू, आउट ऑफ ऑल दोज प्रोसेसेस, विच प्रोसेस वी हैव टू take to the CPU for execution, that is taken care by the short term scheduler. अगर एक से ज़्यादा प्रोसेसेस मेन मेमोरी पे अवेलेबल है, तो उसमें से किस प्रोसेस को हम CPU के अंदर एग्जीक्यूट करेंगे, उसको टेक केयर करता है शॉर्ट टर्म शेड्यूलर. नाउ इफ़ अ प्रोसेस इज करंटली बीइंग एग्जीक्यूटेड इन द CPU, नाउ समटाइम्स दिस प्रोसेस may have to do input output. That means I'm going to maintain a queue here, and this queue will be called as a waiting queue, or you can say waiting state. So generally in many books you will find that waiting state is also called as a blocked state. In many books you can find, and sometimes you can also find that this suspended state is called as a blocked state. So roughly you can also name it this way, that this waiting state is also called as a blocked state, and then we can have a suspended state. So waiting state means the process is present in the main memory for finishing its input output. Process जो है वो main memory में है ताकि process अपना input output को finish कर सके. Now sometimes what happens is your main memory is full. काफ़ी बार ऐसा हो सकता है कि आपकी main memory full है and it cannot hold these processes which are in the waiting state. Why these processes are in waiting state? Because they are performing input output. ये processes waiting state पर क्यों है? क्योंकि input output को perform कर रही है. But if in your main memory enough space is not available, then what will happen? In that case, we will choose one process from the waiting state and we will take it back to the secondary memory because space is not available, right? तो जैसे यहाँ पर अगर for example this process is there, now because memory is not available, I have taken back it to a secondary memory. That means the process is present in the suspended state. उस समय पर जो process है वो suspended state पर है. Now sometimes when the process finish its execution in the secondary memory, that means the process finishes its input output in the secondary memory, then we can take it to the suspended ready state, and from the suspended ready state the process can directly go to the ready state, or right. So in this way this entire thing happens, or the process can go to the waiting state again. So you can see this transition, the process can also go back to the waiting state. ठीक है. सो इट्स वेरी सिंपल कि आपके पास जो भी प्रोसेसेस हैं So either the process will be present in the secondary memory, or the process will be present in the main memory, or the process will be present in the CPU. If the process is available for execution, that means it is in the ready queue. Otherwise, either the process is in the waiting state or the process is in the suspended state. Waiting state means the process is in secondary memory, suspended state means the process is in main memory. Suspended state का मतलब है process जो है वो main memory के अंदर present है, available है. Okay. So when we discuss about the CPU scheduling algorithm, so the responsibility of the CPU scheduling algorithm is to perform this short term scheduling. CPU scheduling algorithm का काम है इस short term scheduling को perform करना कि if there are more than one processes are available in the ready queue, then out of all those processes which process do we have to execute. उन सभी processes में से हमने किस process को execute करना है, that is taken care by the short term scheduler, and it is also called as a CPU scheduler. CPU scheduler, why? Because we have to schedule the processes to be executed in the CPU. That is why the short term scheduler is also called as a CPU scheduler. Okay. Now in this case we have this ready queue. So there's something called as degree of multiprogramming. So what does this degree of multiprogramming says? It means how many processes are present in the ready queue at the same time. रेडी क्यू में एक साथ कितनी processes present हो सकती हैं, उसको हम बोलते हैं degree of multiprogramming. How many processes can be present in the ready queue at a given time? So that is called as degree of multiprogramming. Okay. So this degree of multiprogramming is controlled by the long-term scheduler, because it is the responsibility of a long-term scheduler to bring a process from the secondary memory to the main memory. ये long-term scheduler की responsibility है कि वो process को secondary memory से लेकर main memory के अंदर लेकर आए, right? So it controls, long-term scheduler controls the degree of multiprogramming. Right? And there's one more very important thing here. When you are bringing new processes from the secondary memory to the main memory, then you have to maintain a balance. What kind of balance it is? Balance means a process needs two kind of time. Either the process needs CPU time or the process needs input output time. If all the processes that this long term scheduler is bringing from the secondary memory are basically IO intensive, अगर ज़्यादा जो processes long term scheduler लेकर आ रहा है वो सभी processes IO intensive है. IO intensive means they need more input output time as compared to CPU time, कि उनको ज़्यादा input output time की ज़रूरत है CPU time की जगह पर. So if your long term scheduler is bringing the processes which all of those processes are IO intensive, that means sometimes your CPU will remain idle. जो CPU है जो है वो idle रहेगा, CPU will not be doing any task, so CPU will remain idle, right? But if you bring more processes which are CPU intensive, अगर आप ज़्यादा CPU intensive processes को लेकर आएंगे, it means that sometimes the waiting time of the processes will increase, because in that case all these processes have to wait in the ready queue. So we have to maintain a perfect balance between a CPU intensive as well as IO intensive processes, so that we can keep the CPU busy at all the times. Okay. So this is taken care by long-term scheduler. So it is the responsibility of a long-term scheduler to maintain a balance. And how will it maintain the balance? It will maintain a balance by choosing which process we have to bring from the secondary memory to the main memory. Okay. So let us see some of the terminologies first of all. So the first terminology is regarding the process. What exactly is a process? A process is a program in execution. Generally, when you call a program is a passive entity, but a process is an active entity. So you can read it here. A process is a program in execution. अगर किसी program को आप execute करेंगे, then it becomes a process. So for example, if you write a C programming code or C++ code and you compile it, the compiler creates a binary code. The original code and the binary code are both programs, but when you actually run the binary program, it becomes a process. जब आप उस प्रोग्राम को रन करेंगे तो उस केस में ये प्रोसेस बन जाएगा. So a process is an active entity as opposed to a program. and program is basically a passive entity. Program जो है वो passive entity है, process is an active entity. So if somebody asks you what is a process, you can simply say a process is a program in execution. So when you allocate memory to a process, as you can see, in that memory we will be having various sections. We will be having a text section, we will be having data section, we will be having a heap, as well as we will be having a stack. And we have seen all of these things in your C programming lectures. In C programming lectures we have discussed about each of these sections in more details. We have discussed that this text section is basically a read only section. Why it is a read only section? Because your executable code will be present in the text section. This data section will be having two parts. One is your initialized data section, second is your uninitialized data section. So these uninitialized data section, here I'm going to store my static variables as well as I'm going to store my global variables, and these static variables and global variables, they are by default initialized with the value 0. We have already discussed this, and we have seen that we have a heap as well as we have a stack as a data structure. Why we are using a heap? Because using heap we can manage और dynamic memory allocation. जो dynamic memory allocation है वो heap की वजह से possible है, right? So without heap we will not be able to do dynamic memory allocation, because heap manages all these dynamic memories, और कैसे memories allocated by malloc function or so. But because of this stack we are able to do recursive programming. Stack की वजह से हम recursive programming को मतलब we can do recursive programming because of this stack. If stack is not present, then we cannot do recursive programming, as well as we can also not do function calls. Function calls भी नहीं कर पाएंगे और recursive programming भी नहीं कर पाएंगे. So this stack contains all your auto variables, or you can say temporary variables. It contains all your functions and their program counters of those functions. It contains all the return addresses and local variables. Okay, we have already seen in the C programming, so I believe all of you remember it. आप सभी को याद होगा. So then we can easily move forward from this. ठीक है. Now, if you have a process is having various attributes. Okay. So we have a process ID, we have a process state, we have the number of CPU registers the process is currently using, we have account information, we have input output status, that means what are the input output devices which are allocated to the process, and then we have CPU scheduling information, that means what is the priority of a process. If you look at your operating system itself, let me show you here with the help of my screen. So I can go to the task manager here, and in the task manager I can see all these apps which are running, and these all are basically representing your processes, right? I can go to details section. So with every process, I hope it is visible. If it is not visible, let me change my screen resolution. It should be visible now. Let me try and change the screen resolution here. I'll make it 720p, I guess. Yeah. Keep changes. I hope it should be visible now. ये visible होना चाहिए. So I hope it should be visible. So here you can see we have a lot of information regarding a process. For example, if this Adobe Acrobat Reader is a process, for this Adobe Acrobat Reader we have something called as a process ID, PID, process ID. So we give a unique number to every process so that we can identify the process uniquely. जिस तरीके से in a database we have a primary key, right? In the same way, this process ID is kind of a primary key so that I will be able to identify every process uniquely. Secondly, we have a status of the process, whether the process is in running state, whether the process is in waiting state, whether the process is in suspended state. You can see some of the processes here are in suspended state. मेरे पास कुछ ऐसी processes हैं जो suspended state पर है, correct? Then we can see here what is the amount of memory which is allocated to the process. So this memory is basically your main memory. How much main memory is allocated to the process, right? And this is I think it is representing the CPU utilization, how much process CPU the process is using. Okay, the total processor utilization across all cores. So this is representing the CPU utilization by the process. I can also see more details regarding a process. Let us suppose I take this process as open OBS. So I can do a right click. I can see process priority. What is the priority of the process? For example, it is a high process having high priority, process is having a low priority or below low priority, I can see the priority of the process. I can also see more properties regarding a process. तो क्या properties है, what is the location where the file is stored, lot of information regarding a process is available. Okay, so in the same way, so for my system also I can clearly see how many processes are available. So you can see here, जैसे कि this is open broadcast software. So for this process, this is the process ID, this is the description, this is the status, this is the running process, and how many threads this process is running, how much CPU it is being utilized, and what is the average CPU consumption, how much average CPU consumption per 60 seconds the process is doing. Out of all the 60 seconds, the process is getting executed for 14 seconds. 60 seconds में ये process 14 seconds तक execute करती है. Then I can see regarding how much disk space it is utilizing, how much network space it is utilizing, and how much memory it is utilizing. I can see all this information regarding a process. Okay, so a lot of information is available regarding a process. So all this information regarding the processes are called as, so all this information regarding a process is called as process attributes or characteristic of the process. तो कौन कौन से characteristics आपके पास है? The characteristics is process ID, process state, the CPU register, account information, input output status, and CPU scheduling information. That means what is the information required for the CPU scheduling? Maybe the priority of a process. Okay, what is the time taken for this process to execute, what is the size of the process, all this information is there. In the input output status, what is the open files, how many files the process has opened, how many devices the process is currently using. So this is IO status. And then we have CPU register, what are the CPU registers which are utilized by the process. So there are more details regarding the same. So further you can see these more details, that what is the process control information. So सबसे पहले process state is a process control information. So these all are basically characteristics of a process. ये सभी process के characteristics हैं. Next, process structuring information, whether it is a child process or whether it is a parent process, what kind of process is it, that is process structuring information. Then we have some information regarding inter-process communication, that means what are the flags it is using, what are the signals or messages it is using. Then we have process privileges, whether the process is allowed to use some resource or whether the process is not allowed to use a particular resource, that is process privilege. Then we have process state, the process is a new state, process is in ready state, the process is in running state, the process is in waiting state, or process is in dead state. What state of the process is it? So that is called as a process state. Then we have process number, which is a unique process ID, or you can say PID. Then we have program counter. Program counter means what is the next statement or next statement that needs to be executed in the process. अगली statement कौन सी execute होने वाली है या फिर अगली statement हमें कौन सी execute करनी है, that is called as your program. Program counter will take care of that कि अगली कौन सी जो statement है, instruction है, वो हमें execute करनी है, that is taken care by the program counter. Then we have CPU registers. What are the CPU registers that are used by the process? Okay. Then we have CPU scheduling information, right? So what is the CPU time needed by the process? What is the priority of the process? All these things are stored in the CPU scheduling information. Then we have memory management information. What is the information regarding the page table of the process, memory limits of the process, segment table of the process, depending on what kind of memory management technique we are using. Whether you are using a paging concept, whether you are using a segmentation concept, whether you are using a TLB concept, what kind of concept you are using. So that is your memory management information. Then we have accounting information. That means the accounting information is regarding the process, right? So that is what is the amount of CPU that is used by the process. Currently the process is using 15% of the CPU. So what is the amount of CPU that is used by the process, or what is the time limits, or what is the execution ID, and so on. एंड देन वी हैव IO स्टेटस इन्फॉर्मेशन कि कौन कौन सी इनपुट आउटपुट डिवाइसेस जो है वो प्रोसेस यूज़ करे, व्हाट आर द फाइल्स दैट द प्रोसेस इज यूजिंग और व्हाट आर द डिवाइसेस दैट द प्रोसेस इज यूजिंग. All these are called as a process attributes. See, sometimes the process can be a child process, it can be a parent process. What do you mean by this is, let us suppose that we have created a new process which is your web browser. Maybe you are using a Chrome browser. Now if a new process is created by this Chrome browser, अगर Chrome browser ने एक और process को create किया, maybe that process is Flash player, right? So this Flash player is a child process of Chrome. तो जो फ्लैश प्लेयर है वो क्रोम के चाइल्ड प्रोसेस है. सो दैट इज दिस काइंड ऑफ स्ट्रक्चरिंग इन्फॉर्मेशन विच प्रोसेस इज अ चाइल्ड ऑफ विच प्रोसेस एंड व्हाट इज अ पेरेंट. सो दैट इज कॉल्ड एज प्रोसेस स्ट्रक्चरिंग इन्फॉर्मेशन. ओके, then here we have process control block. So all this information regarding the process, it is stored in the process control block. ये सभी information जो है ये process control block में store होती है. So the process control block stores the process state, the process number, the program counter, the register, the limit, memory limit, the open files, all this miscellaneous data information, everything is stored in the process control block. And you can see the process control block also stores a pointer. So all the processes which are available, it will store a pointer to those processes. I'll show you the structure, right? So this is basically how your operating system manages everything. So whatever processes are available, जितने भी processes अभी आपके operating system में available है, so this operating system will create a table. आपका operating system एक table को create करेगा. And in this table the operating system will store what is the process ID and what is the link to the process control block of that process ID. Again the process ID of second process, and then we'll be having a link to the process control block of the second process, and then we have a process ID of the third process, and then we'll be having a link to the process control block of the third process. तो जितने भी आपके process control blocks है, for all of these process control blocks we are going to maintain a table here, right? So that we can easily manage all of these informations, right? Secondly, whenever you have a process control block, so in process control block we store information regarding a process. We store information regarding a process. आप किसी प्रोसेस से रिलेटेड जो भी इंफॉर्मेशन है उसको प्रोसेस कंट्रोल ब्लॉक में स्टोर करते हैं, एंड दिस इज ऑल्सो कॉल्ड एज ए context of the process. It's also called as context of the process, right? Process control block is just storing the information regarding the process. जैसे कि आपका process ID है, what is the process ID, what is accounting information, what is the list of open files, what is the list of open devices, right? What is the priority of the process, what is, you know, what is the CPU utilization. So all of these information जो भी हमने स्टडी किया था, all these process attributes are stored in the process control block. All the process attributes are stored in process control block. जो process के attributes होते हैं हम उसको process control block में store करते हैं. All the process attributes are stored in the process control block. And this process control block, if it is storing information regarding a process, then it is also called as a context of the process. हम इसको किसी process का context भी बोलते हैं. Now what do I mean to say by this is, if this is your CPU and this is your main memory, if this process P1 is currently being executing in the CPU, that means the CPU is reading the context of the process P1. या फिर कहो the CPU is reading the process control block of the process P1, right? I'm repeating again, whenever the CPU is executing a process, it means the CPU is reading the process control block of that particular process, or you can say the context of that particular process, क्योंकि process control block को आप context भी बोलते हैं. So if you take this process out of the CPU and if you bring another process, let us suppose the process P2 in the CPU, that means you have changed the context of the process. Earlier you were reading the process P1, now you are reading the process P2. So this is called as a context switching. This is called as context switching. So context switching means you are taking one process in the CPU and you are taking one process out to the CPU. So whenever the process changes, then the context switch happens. So context means we are reading the process control block of a process. If you take one process out of the CPU, if you bring another process inside the CPU, that means we will read the context of another process. उस केस में हम किसी दूसरी process के context को read करेंगे, then that will be called as a context switching. Okay. Context of a process means we are reading the process control block of the process. Context of a process means what are the process attributes. Process attributes का जो set है उसको हम कॉन्टेक्स्ट ऑफ अ प्रोसेस की बोलते हैं. जब हम किसी प्रोसेस को सीपीयू से निकाल कर दूसरी प्रोसेस को सीपीयू के अंदर डालते हैं, इसका मतलब है कि हम कॉन्टेक्स्ट स्विचिंग कर रहे हैं. वी आर चेंजिंग द कॉन्टेक्स्ट ऑफ वन प्रोसेस विद द कॉन्टेक्स्ट ऑफ अनदर प्रोसेस. So we have this state of the process. We have already seen the state. We can have a new state, we can have a ready state, we can have a running state, we can have waiting state. Waiting state is also called as a blocked state. We can have completed state, which is also called as a termination state. We can have suspended block state, as well as we can have suspended ready state. We have already seen all of these states of a process. So this is your process state diagram. In the beginning of the lecture itself, we have seen this process state diagram. Here we have a new state. New state, the process is in secondary memory. Then we have a ready state, that means the process is in main memory. Then we have a running state, that means the process is in CPU. From running state, the process can go to a waiting or blocked state. Blocked state means the process is still in main memory. From waiting or blocked state, the process can go to suspended wait. So that means the process is in secondary memory. From suspended wait, the process can go to a suspended ready. That means the process still in secondary memory. And if the process is completed, terminated, that means the process is in main memory. तो यहाँ पर process जो है वो that means the process in secondary memory. Okay. So there are a lot of events that can happen. So for example, this is taken care by the long-term scheduler. This is taken care by the short-term scheduler, right? So this short-term scheduler might take decision on the various criterias. So we'll look at these criterias later on. कि criterias क्या है, that means what is priority, what is time quantum, what is scheduler, what is dispatcher. तो हम ये सब चीज़ों को discuss करेंगे one by one. Okay, and what is this IO request and what is IO complete. तो ये सब चीज़ें हम लोग अभी discuss करेंगे. Okay, so right now you just have to make sure that you understand this process state diagram, because अगर आपको process state diagram पता है, then you will be able to solve a lot of questions. Okay. So we already know if this transition is present, that means we can have preemption. अगर ये transition present है तो हमारे पास system के अंदर preemption possible है. If this transition is not present, that means the system is not having preemption. ये हमने कल previous session में हमने discuss किया था. We have discussed that we have a batch operating system, we have multiprogramming operating system, we have multitasking operating system. तो ये हमने in yesterday's class we have discussed all of these things. ठीक है. Fine. So let us keep this diagram as of now. We will discuss about this diagram in more details. We have seen this one also. Okay, so यहाँ पर इन सभी schedulers के बारे में है. The first scheduler is a long-term scheduler and it is also called as a job scheduler. तो जो long-term scheduler है, it is responsible for degree of multiprogramming. Long-term scheduler जो है वो degree of multiprogramming के लिए responsible है. And what is the degree of multiprogramming? What is the degree of multiprogramming? Degree of multiprogramming होता क्या है? Degree of multiprogramming is how many processes can be in the ready queue at the same time. How many process can be in ready state at the same time. Or you can say how many processes can be in the main memory at the same time, right? So when you see a degree of multiprogramming, it means कि हमारे पास जो ready state है वहाँ पर कितनी processes है at any given point of time. Ready state पर एक समय पर कितनी processes हैं. Then we have a short term scheduler and it is also called as a CPU scheduler, right? जो short term scheduler हमने बताया था उसको हम CPU scheduler भी बोलते हैं. Okay, तो CPU scheduler का काम क्या है? That means it is going to select one process from ready state and it will take this process to the running state. एक process को ready state से select करके हम running state पर लेकर जाएंगे and that is taken care by the short term scheduler. Now this short term scheduler uses something called as a dispatcher. तो हमारे पास एक term आते हैं यहाँ पर dispatcher. Okay, so this short term scheduler is only possible for selecting the process ये सिर्फ ये सेलेक्ट करता है कि कौन सी प्रोसेस को लेकर जाना है मेन मेमोरी के अंदर, बट डिस्पैचर की रिस्पॉन्सिबिलिटी ये है कि उस प्रोसेस को मेन मेमोरी में लोड कैसे, उस प्रोसेस को सीपीयू में लोड कैसे करना है. लेट मी अगेन टेल यू. सो व्हेन यू हैव अ शॉर्ट टर्म शेड्यूलर, द रिस्पॉन्सिबिलिटी ऑफ शॉर्ट टर्म शेड्यूलर इज़ ओनली टू सेलेक्ट कि किस प्रोसेस को हमने रेडी स्टेट में से एग्जीक्यूशन के लेकर जाना है, उसकी जो उसको सेलेक्ट करने की जो रिस्पॉन्सिबिलिटी है वो शॉर्ट टर्म शेड्यूलर के पास है. इट इज़ ओनली गोइंग टू सेलेक्ट बट इट इज़ नॉट गोइंग टू लोड द प्रोसेस इन द मेन मेमोरी. ये उस प्रोसेस को मेन मेमोरी पे लोड नहीं करेगा, ये बस उस प्रोसेस को सिलेक्ट करेगा कि हमें किस प्रोसेस को मेन मेमोरी पे एग्जीक्यूट करना है. बट देन यू हैव अ डिस्पैचर. सो डिस्पैचर इज रिस्पॉन्सिबल फॉर लोडिंग द प्रोसेस सेलेक्टेड बाय द शॉर्ट टर्म शेड्यूलर ऑन द CPU. यानी कि कौन सी, जब मैं डिस्पैचर की बात करूंगा तो डिस्पैचर का काम क्या है कि शॉर्ट टर्म शेड्यूलर ने जिस प्रोसेस को सेलेक्ट किया है उस प्रोसेस को हमें CPU के अंदर लोड करना है. सो इट इज़ द रिस्पॉन्सिबिलिटी ऑफ द डिस्पैचर टू लोड द प्रोसेस दैट इज सेलेक्टेड बाय द शॉर्ट टर्म शेड्यूलर टू लोड इन द CPU. Okay, so dispatcher will do the context switching. Context switching will also be done by the dispatcher. So dispatcher does the following tasks. First, do a context switch. So that means there will be a change in the context of the process. Context switch means you are going to change the प्रोसेस कंट्रोल ब्लॉक. कॉन्टेक्स्ट स्विच का मतलब क्या है कि आप अभी अगर एक प्रोसेस को एग्जीक्यूट कर रहे थे तो आप उसके प्रोसेस कंट्रोल ब्लॉक को रीड कर रहे थे. जब आपने कॉन्टेक्स्ट स्विच किया यानी कि आप किसी दूसरी प्रोसेस के प्रोसेस कंट्रोल ब्लॉक को रीड करेंगे. करेक्ट. तो जो कॉन्टेक्स्ट स्विचिंग है, सो दिस कॉन्टेक्स्ट स्विचिंग इज डन बाय द डिस्पैचर. राइट. स्विचिंग टू द यूज़र मोड. सो वी कैन हैव सिस्टम प्रोसेसेस and we can have the user processes. We'll look at it later on. तो आपके पास सिस्टम प्रोसेस हो सकती हैं, यूज़र प्रोसेसेस हो सकती हैं. सो इफ़ इट इज़ एग्जीक्यूटिंग अ यूज़र प्रोसेस दैट मीन्स इट इज़ रनिंग इन अ यूज़र मोड. तो सिस्टम की इनबिल्ट प्रोसेस को एग्जीक्यूट नहीं कर रहे तो हम उस पर यूज़र मोड पर रन कर रहे हैं. सो it is the responsibility of the dispatcher to switching to the user mode, and then it is the responsibility of the dispatcher to jump to the proper location in the newly loaded program. So ऐसा हो सकता है if there is a one program, you have executed this one program to some point of time, and now when you again load this program in the main memory, you have to start execution from this point onwards. अब इस प्रोग्राम को स्टार्टिंग से एग्जीक्यूट नहीं करेंगे बल्कि इस पॉइंट ऑनवर्ड से ही स्टार्ट करेंगे. सो जंपिंग टू अ प्रॉपर लोकेशन इन द प्रोग्राम इज़ अगेन डन बाय द डिस्पैचर. कि कहाँ से प्रोग्राम को एग्जीक्यूट करना स्टार्ट करना है या कहाँ से प्रोसेस को एग्जीक्यूट करना स्टार्ट करना है, दैट इज़ टेकन केयर बाय द डिस्पैचर. ओके ओके, आई बिलीव ये कुछ ज़्यादा कॉम्प्लिकेट हो रहा है. सो आई फील इट इज़ बिकमिंग अ लिटिल कॉम्प्लिकेटेड फॉर यू टू अंडरस्टैंड, बट आई विल ट्राई टू एक्सप्लेन दिस अगेन इन अ सिंपल लैंग्वेज. लेट अस just follow through me. Okay, then we have medium term scheduler. So medium term scheduler is responsible for suspending and resuming the process. मीडियम टर्म शेड्यूलर जो है वो किसी प्रोसेस को सस्पेंड करने के लिए या फिर रेज्यूम करने के लिए यूज़ होती है. एंड इफ़ दैट मीन्स इफ़ द प्रोसेस इज सस्पेंडिंग मीन्स वी आर गोइंग टू टेक द प्रोसेस टू द सेकेंडरी मेमोरी, एंड रेज्यूमिंग मीन्स यू आर टेकिंग द प्रोसेस फ्रॉम सेकेंडरी मेमोरी टू द मेन मेमोरी. ओके, सो देयरफॉर इफ़ यू हैव टू प्रोसेस, यू हैव टू सस्पेंड द प्रोसेस. सस्पेंड करने मतलब है कि मेन मेमोरी से सेकेंड मेमोरी में मूव किया तो अगेन देयर इज अ मूवमेंट ऑफ द प्रोसेस इज इंक्लूडेड. Right, so this medium term scheduler also do this swapping. That means it also perform this movement of the process. Okay, clear? So why we do swapping here? I told you जब भी आपके पास when your main memory is not having enough space and your main memory cannot hold every process at the same time, then in that case we do swapping. अगर मेन मेमोरी सभी प्रोसेसेस को होल्ड नहीं कर पा रही है उस केस में हम लोग स्वैपिंग करते हैं. ओके, फाइन. देन वी हैव मल्टी प्रोग्रामिंग. सो वी नो व्हाट इज़ अ प्रीएम्पशन. मैंने आपको कल बताया था what do you mean by preemption and what do you mean by non preemption, and we have already seen what is degree of multiprogramming. So degree of multiprogramming means how many processes are present in the ready state at any time. That is the degree of multiprogramming. If the degree of multiprogramming is 100, that means the 100 processes can reside in the ready state at maximum. अगर डिग्री ऑफ मल्टी प्रोग्रामिंग 100 है तो यानी कि 100 प्रोसेसेस जो है वो रेडी स्टेट पर हो सकती है एट एनी गिवन टाइम. ठीक है, so maximum 100 processes can be in the ready state at any time, that is degree of multiprogramming. Okay, so your long-term scheduler controls the degree of multiprogramming, controls degree of multiprogramming. आपका जो लॉन्ग टर्म शेड्यूलर है वो डिग्री ऑफ मल्टीप्रोग्रामिंग को कंट्रोल करता है. सो दिस इज रिगार्डिंग द कॉन्टेक्स्ट स्विचिंग. व्हेन डज द कॉन्टेक्स्ट स्विचिंग हैपन? कॉन्टेक्स्ट स्विचिंग कब होती है? देखो कॉन्टेक्स्ट स्विचिंग का मतलब क्या है. देखो दिस इज योर CPU. अभी CPU जो है वो P1 प्रोसेस को एग्जीक्यूट कर रहा है. नाउ इफ देयर इज अ हायर प्रायोरिटी प्रोसेस P2 इज कमिंग, सो हमें P1 को CPU से बाहर निकालना पड़ेगा एंड देन वी हैव टू गिव दिस प्रोसेस P2 इन द CPU. राइट, तो हमने यहाँ पर क्या हुआ, प्रोसेस को हमने चेंज किया. सो दिस इज बेसिकली अ कॉन्टेक्स्ट स्विच. ये हुआ हमारे पास कॉन्टेक्स्ट स्विच. यानी कि अगर आप CPU के अंदर एक प्रोसेस से चेंज कर दूसरी प्रोसेस को एग्जीक्यूट करते हैं तो उस केस में हमारे पास एक कॉन्टेक्स्ट स्विचिंग ऑकर्स होता है. दिस इज योर कॉन्टेक्स्ट स्विच. राइट, सो कॉन्टेक्स्ट स्विचिंग मीन्स यू आर रीडिंग द प्रोसेस कंट्रोल ब्लॉक ऑफ प्रोसेस P2 आफ्टर द प्रोसेस कंट्रोल ब्लॉक ऑफ प्रोसेस P1. जब P1 को एग्जीक्यूट कर रहे थे यानी कि उसके प्रोसेस कंट्रोल ब्लॉक को रीड कर रहे थे. व्हेन वी चेंज्ड फ्रॉम प्रोसेस P1 टू P2 यू आर रीडिंग द प्रोसेस कंट्रोल ब्लॉक ऑफ प्रोसेस P2. ओके, so what is this context switching? The process of saving the context of one process and loading the context of another process is called as context switching. जब भी आप P1 प्रोसेस को CPU से बाहर निकालेंगे तो यानी कि P1 प्रोसेस के जो भी प्रोसेस एट्रीब्यूट्स हैं आप सभी को सेव करेंगे. So whatever the information was stored in the process control block of the process P1, if you are going to take the process P1 out of the CPU, that means you have to store all the values of those attributes of process P1. तो आपको सबसे पहले process P1 के context को save करना पड़ेगा and then you are going to load the context of the another process. आप पहले process की context को save करेंगे फिर दूसरे process की context को load करेंगे. So it is more like a loading and unloading process. So when does this context switching happens? Context switching कब होता है? So when a higher priority process is coming, जैसे कि here if P1 process was executing in the CPU and there is a process P2 which is a higher priority process as compared to P1. P2 की जो priority है वो P1 से ज़्यादा high है, तो उस केस में हम P1 को CPU से बाहर निकालेंगे और P2 को CPU के अंदर डालेंगे. So if a higher priority process is coming, then a context switching happens. Okay. Secondly, if an interrupt occurs, अगर आपके पास कोई interrupt होता है, so what are these interrupts? So interrupts are events. Interrupts क्या होता है? These are events in your operating system. जो आपके operating system events occur होते हैं, those are called as interrupts. Correct? So events जैसे कि you have a mouse click. Mouse click is a event. CPU heating issue is a event. Button press is a event. So whenever there exists some kind of a event, right? So then interrupt occurs. So these events can be your software events, they can also be your hardware event. Event जो है वो आपके software event भी हो सकते हैं और hardware events भी हो सकते हैं. So we are going to discuss more about interrupts in computer architecture and organization. So we'll look at events in computer architecture and organization also. Okay. Then we have a switch between a kernel mode and the user mode. If you are executing a user process, that means you are running in a user mode. If you are executing a system process, that means you are running in a kernel mode. And in kernel mode we cannot have preemption. Kernel mode पे preemption नहीं होता. So you can note it down. I have not written the PPT. In the kernel mode, if the system is running in the kernel mode, that means preemption does not occur. Okay, or if we have a preemptive CPU scheduling, जैसे कि हमारे पास अगर round robin scheduling है which uses a time quantum just like in movies, right? So in that case also the context switching happens. So again these are the four conditions when the context switching happens. Number 1, when a high priority process is coming. Number 2, when an interrupt occurs. Number 3, when a mode switch is required. And number 4, according to the CPU scheduling decision. जो process है CPU scheduling जो CPU scheduling algorithm है उसका जो decision है उसके basis पर we are going to perform the context switching. Okay. So let us discuss later on about what is a mode switch. इसके बारे में हम बाद में discuss करेंगे. We are not discussing about mode switch as of now. Then this is more about a dispatcher. So as I told you, we have a short term scheduler, we have a medium term scheduler, and we have a long term scheduler. and with this short term scheduler we also have something called as a dispatcher. So I told you the responsibility of the dispatcher is loading and unloading the program. It is loading and unloading, मतलब जो प्रोसेस को CPU के अंदर लोड करना और प्रोसेस को CPU से बाहर लेकर आना यानी कि अनलोड करना, दैट इज द रिस्पॉन्सिबिलिटी ऑफ डिस्पैचर. ओके, so the dispatcher takes the process to the desired state or the queue. The dispatcher is a module that gives a process control over the CPU after it has been selected by the short term scheduler. यानी कि जिस प्रोसेस को हमें CPU के अंदर एग्जीक्यूट करना है हम उस प्रोसेस को सेलेक्ट करेंगे शॉर्ट टर्म शेड्यूलर से और फिर हम डिस्पैचर की हेल्प से उसको CPU के अंदर लोड करेंगे. We will load the process in the CPU with the help of a dispatcher and we will select the process with the help of this short term scheduler. So the responsibility of dispatcher is context switching, switching to the user mode and jumping to the proper location. These are the responsibility of a dispatcher. Sometimes it also takes time to perform dispatching operation, that is called as a dispatch latency. कई बार आपके पास जैसे हमें करना क्या होता है कि जब भी आप किसी प्रोसेस को CPU से बाहर निकालेंगे तो सबसे पहले उसके कॉन्टेक्स्ट को सेव करना पड़ेगा, राइट. तो आपको पता है कि अगर आप किसी प्रोसेस के कॉन्टेक्स्ट को सेव करेंगे तो सेविंग के अंदर हमें कुछ टाइम लगेगा, फिर हमें उस प्रोसेस को CPU से बाहर निकालना पड़ेगा, दैट मीन्स अनलोडिंग. तो अनलोडिंग में भी कुछ टाइम लगेगा और फिर अपने किसी दूसरी प्रोसेस को CPU के अंदर डालना है तो यानी कि लोडिंग, तो लोडिंग में भी कुछ टाइम लगेगा. तो सेविंग द कॉन्टेक्स्ट ऑफ अ प्रोसेस, अनलोडिंग द प्रोसेस, लोडिंग द प्रोसेस, ऑल ऑफ दीज थिंग्स आर गोइंग टू टेक सम टाइम. इन सभी में कुछ ना कुछ टाइम लगेगा एंड दिस टाइम इज कॉल्ड एज ए डिस्पैच लेटेंसी. इस टाइम को हम डिस्पैच लेटेंसी बोलते हैं. नाउ वी हैव वेरियस क्यूज़. अब हम लोग काफ़ी सारी क्यूज़ को मेंटेन करते हैं. आई टोल्ड यू दैट व्हेन अ न्यू प्रोसेस इज क्रिएटेड देन यू टेक दिस प्रोसेस इन समथिंग कॉल्ड एज ए रेडी क्यू. तो ये हमारे पास एक क्यू है, दिस रेडी इज़ अ क्यू. इन द सेम वे व्हेन द प्रोसेस इज़ इन वेटिंग स्टेट, तो वेटिंग स्टेट पर एक से ज़्यादा प्रोसेसेस हो सकती है. सो इन दैट केस वी मेंटेन अ वेटिंग क्यू. तो हम वहाँ पर वेटिंग क्यू को मेंटेन करते हैं, राइट. सो व्हाट आर द डिफरेंट क्यूज दैट वी मेंटेन. हम कौन कौन सी क्यू को मेंटेन करते हैं. सो फर्स्ट ऑफ ऑल वी मेंटेन अ जॉब क्यू, राइट. Job queue means it is in the secondary memory. That means the jobs which we can execute, which are available for execution, or they are called as a job queue. Then we take one job from the job queue and we take it to the ready queue. So that means ready queue means the process is in the main memory. जब process ready queue के अंदर है इसका मतलब है process main memory के अंदर है, right. So then we have something called as device queue. So device queue means if the process want to access some device, अगर process को किसी device को access करना है, for that purpose we maintain a device queue. So for example the device can be a scanner, the device can be a printer. So if multiple processes want to execute want to access the printer, so in that case we are going to maintain a device queue. So all of those processes will be in this device queue for printer, correct. So this is all the queues that we maintain. So सबसे पहले आपकी जो queue है, this is your ready queue, right. Then we have input output request queue, then we have IO queue, then we have IO. So right. So what does this mean? इस सब का मतलब क्या है. देखो, you have a process in secondary memory. So you are going to bring all these processes from secondary memory to the main memory. Process P1, P2, P3, P4, अब इन सभी प्रोसेसेस को सेकेंडरी मेमोरी से मेन मेमोरी पर लेकर आएंगे. नाउ यू आर गोइंग टू सेलेक्ट वन प्रोसेस फ्रॉम हियर फॉर एग्जीक्यूशन. आपने P2 प्रोसेस को CPU के अंदर भेजा एग्जीक्यूशन के लिए. नाउ इफ़ द P2 प्रोसेस वांट टू डू सम IO, सो इफ़ द P2 प्रोसेस वांट टू डू सम IO, इट विल बी प्लेस्ड इन द IO रिक्वेस्ट क्यू. तो ये भी आपके पास क्यू है. ऑल दिस रेक्टेंगल बॉक्सेस आर रिप्रेजेंटिंग अ क्यू. ये सभी रेक्टेंगुलर बॉक्सेस एक क्यू को रिप्रेजेंट कर रहे हैं. So if the P2 process want to perform some input output, so first of all it will be placed in the input output request queue and then it will be placed in the input output queue. उसके बाद वो input output queue में place होगा. जैसे कि if the P2 process want to do some print operation, so for this print operation we have to place this P2 process in the IO queue. हम इस P2 process को IO queue के अंदर place करेंगे. बिकॉज इफ़ देर आर मल्टीपल प्रोसेसेस, जितनी भी प्रोसेस को प्रिंट करना है उन सभी प्रोसेसेस को हम लोग IO क्यू के अंदर प्लेस करेंगे एंड देन वी आर गोइंग टू परफॉर्म दिस IO वन बाय वन, और फिर हम उन सभी IO को एक से एक कर परफॉर्म करेंगे. ओके फाइन. Then we have something called as a time slice. What do you mean by this time slice? इस time slice का मतलब क्या है? I have given you an example that in a movie theater, whenever you have this camera, so in this camera we have some images, right? And we project these images on the screen. हम इन images को screen पर project करते हैं because this reel is moving at a very fast pace. That means if this reel is moving at 24 frames per second, it feels like the character on the screen is moving. Screen पर जो भी character है वो movement ले रहा है. Okay, so because of this, इसी वजह से हमें यहाँ पर इसके अंदर continuity feel होती है. In the same way, when in your computer system, if you have multiple process, you have a process P1, you have a process P2, you have a process P3, you have a process P4, and this is your CPU. So what you can do is you will execute the process P1 for some time quantum which is maybe 2 nanosecond. आप सबसे पहले process P1 को 2 nanosecond तक execute करेंगे, then you will take it out. Then you will execute process P2 for 2 nanosecond, then you will take it out. Then you will execute process P3 for 2 nanosecond, then again you will take it out. Then you will execute the process P4 for 2 nanosecond, then you will take it out. आप इन सभी process को 2 nanosecond तक execute करेंगे, फिर आप इन सबको बाहर निकालेंगे, और then this cycle will continue, right? So this 2 nanosecond is your time quantum and it is also called as your time slice. इसको हम time slice या फिर time quantum भी बोलते हैं, right? So whenever this 2 nanosecond expires, then you have to take this process out of the CPU. आप इस process को CPU से बाहर निकालेंगे. So if a process, let us suppose a process P3 is currently being executed in the CPU and this time slice or time quantum of 2 nanosecond is expired, then again we place this process in this time slice expired queue, जहाँ से process जो है दोबारा से ready queue के पास चला जाएगा. Again the process can go to a ready queue. Okay. और if a process perform a fork operation, अगर कोई process fork operation को perform करता है या फिर fork command को perform करता है. Fork command means if a process want to create a child process, अगर इसको कोई child process को create करना है, then it is going to perform a fork command. अगर किसी process को किसी child process को execute करना है तो उसके लिए हम fork operation को perform करेंगे. So then the child process executes and after this again we go back to the ready state. Or if some kind of interrupt has occurred, interrupt means maybe a keyboard button is pressed, maybe a mouse button is pressed, or maybe an interrupt from another software, किसी और software से interrupt आया है, or maybe a CPU heating issue. So whatever kind of interrupt it is, right? So whenever there exists some kind of interrupt, so we'll take this process out of the CPU, we will perform the interrupt and again we will take this process back in the ready queue. तो उस केस में भी हम लोग यहाँ पर इसको ready queue में place करेंगे. So roughly all in all you should know what are the queues which are present. कौन कौन सी queue present होती है हमारे पास? एक ready queue present है, एक IO request queue है, एक IO queue है, एक आपके पास time slice expired वाली queue है कि जिन जिन process का time slice expire हो गया है we are going to put it them here. Then we have a fork queue and then we have interrupt queue. तो आपके पास ये सभी queues हैं जो हम maintain करते हैं in your system, so you should know all of these queues. आपको इन सभी queues के बारे में पता होना चाहिए. Okay, clear? Good. So then we have CPU scheduling terminologies. तो आपके पास कुछ terminologies हैं. The first terminology is arrival time, the second is completion time, third is burst time, fourth is turnaround time, then we have waiting time. Okay, मतलब क्या है? Let us first read the definition and then I'll take an example. So what is this arrival time? जिस टाइम पर एक प्रोसेस रेडी क्यू पे अराइव होगी दैट इज़ कॉल्ड एज अराइवल टाइम. द टाइम एट विच द प्रोसेस अराइव्स इन द रेडी क्यू इज कॉल्ड एज ए अराइवल टाइम. कंप्लीशन टाइम विच द टाइम एट विच द प्रोसेस कंप्लीट्स इस एग्जीक्यूशन. जिस समय पर प्रोसेस अपने एग्जीक्यूशन को कंप्लीट कर देगी तो उस टाइम को हम बोलेंगे कंप्लीशन टाइम. देन द बर्स्ट टाइम, द अमाउंट ऑफ CPU टाइम रिक्वायर्ड बाय अ प्रोसेस. कि CPU कितना ही देर प्रोसेस को CPU के अंदर एग्जीक्यूट करना है, कितना CPU टाइम की रिक्वायरमेंट है, दैट इज़ कॉल्ड एज योर बर्स्ट टाइम. तो उसको हम बर्स्ट टाइम बोलते हैं. देन देयर इज समथिंग कॉल्ड एज ए टर्न अराउंड टाइम. तो टर्न अराउंड टाइम क्या होता है? द टाइम डिफरेंस बिटवीन कंप्लीशन एंड अराइवल. सो इट इज़ कंप्लीशन टाइम माइनस अराइवल टाइम इज़ योर टर्न अराउंड टाइम. देन वी हैव वेटिंग टाइम विच इज़ टर्न अराउंड टाइम माइनस बर्स्ट टाइम, यानी कि किसी प्रोसेस को टोटल कितना वेट करना पड़ा. ओके. सो वेन एवर यू आर परफॉर्मिंग अ CPU शेड्यूलिंग, जब भी आप प्रोसेस शेड्यूलिंग या CPU शेड्यूलिंग करते हैं, तो व्हाट आर द ऑब्जेक्टिव्स ऑफ CPU शेड्यूलिंग? वी वांट टू यूटिलाइज द CPU एट मैक्सिमम, वी वांट मैक्सिमम यूटिलाइजेशन ऑफ द CPU, वी वांट अ फेयर अलोकेशन टू द CPU. ऐसा नहीं होना चाहिए दैट सम प्रोसेसेस आर गेटिंग द CPU सो ऑफन बट कुछ प्रोसेस को CPU मिल ही नहीं रहा है. इफ द सम प्रोसेसेस आर नॉट गेटिंग द CPU, दे विल गो इन द स्टारवेशन मोड. सो स्टारवेशन शुड नॉट ऑकर. स्टारवेशन शुड नॉट ऑकर. तो कुछ प्रोसेसेस जो कि स्टारवेशन मोड पे है, मतलब कहने का मतलब फेयर अलोकेशन का मतलब क्या है कि हर एक प्रोसेस को CPU मिलना चाहिए, ऐसी कोई भी प्रोसेस नहीं होनी चाहिए जिसको CPU ना मिले. तो स्टारवेशन शुड नॉट ऑकर इन एनी ऑफ द केसेस. देन वी शुड गेट मैक्सिमम थ्रूपुट. मैक्सिमम थ्रूपुट मीन्स मैक्सिमम नंबर ऑफ जॉब्स शुड कंप्लीट पर यूनिट टाइम. हम ज़्यादा से ज़्यादा जॉब्स को फिनिश कर पाएँ. देन वी हैव मिनिमम टर्न अराउंड टाइम. We do not want to the process to remain in the CPU for a long time. तो देखो टर्न अराउंड टाइम का मतलब क्या है, प्रोसेस ने सिस्टम के अंदर कब एंटर किया और प्रोसेस सिस्टम से कब एग्जिट हुई, राइट. तो ये जो बीच का टाइम होता है इसको हम टर्न अराउंड टाइम कहते हैं. जैसे कि अगर एक प्रोसेस सिस्टम के अंदर 9 AM पर आई और प्रोसेस ने 11 AM पर सिस्टम को लीव किया, यानी कि जो प्रोसेस है टोटल 2 आवर्स सिस्टम के अंदर रही, दैट इज़ योर टर्न अराउंड टाइम. ओके. तो टर्न अराउंड टाइम को हमें मिनिमाइज करना है, बिकॉज इफ़ वी कैन मिनिमाइज द टर्न अराउंड टाइम देन वी कैन फिनिश मोर नंबर ऑफ प्रोसेसेस पर यूनिट टाइम. तो हम ज़्यादा प्रोसेस को फिनिश कर पाएंगे. देर वी वांट अ मिनिमम वेटिंग टाइम, कि हम नहीं चाहते कि प्रोसेस जो है वो उसको ज़्यादा वेटिंग लगे. जैसे कि देखो, द प्रोसेस अराइव्ड एट द सिस्टम एट 9 AM, राइट. देन प्रोसेस लेफ्ट द सिस्टम एट 11 AM. प्रोसेस 9 बजे आई और उसने प्रोसेस ने 11 बजे सिस्टम को छोड़ दिया. और जो प्रोसेस का काम था, द प्रोसेस नीडिड द CPU ओनली फॉर 5 मिनट्स. प्रोसेस को सिर्फ 5 मिनट ही CPU चाहिए था. दैट मीन्स इन दैट केस द प्रोसेस यूटिलाइज्ड ओनली 5 मिनट्स. प्रोसेस ने सिर्फ 5 मिनट्स CPU को यूटिलाइज किया, एंड रेस्ट ऑफ द 115 मिनट्स द प्रोसेस हैज़ टू वेट. जो बाकी जितने भी 115 मिनट्स थे उस समय पर हमें प्रोसेस को वेट करना पड़ा. सो वी वांट टू मिनिमाइज दिस वेटिंग टाइम. हम नहीं चाहते कि कोई भी प्रोसेस बहुत ज़्यादा देर तक वेट करे, बिकॉज वेटिंग इज़ नॉट गुड. सो वी वांट दैट the CPU utilization should increase and the waiting time should decrease. So we want to minimize this waiting time. Then we have minimum response time. Minimum response time का मतलब क्या है कि प्रोसेस को पहली बार कब रिस्पॉन्स मिला. जैसे कि प्रोसेस अराइव्ड एट 9 AM, प्रोसेस 9 बजे आई और प्रोसेस को जो CPU मिला है वो 10 बजे मिला है, राइट. सो बिटवीन 9 AM to 10 AM द प्रोसेस हैज़ टू वेट. तो पहली बार प्रोसेस को CPU कब मिला उसको हम बोलते हैं रिस्पॉन्स टाइम. What is the first time the process got the CPU? The first time the process hits the CPU. जिस समय पर प्रोसेस को पहली बार CPU मिलेगा उसे हम बोलेंगे रिस्पॉन्स टाइम. सो वी वांट टू मिनिमाइज दिस रिस्पॉन्स टाइम. हम इस रिस्पॉन्स टाइम को मिनिमाइज करना चाहते हैं. ओके. सो व्हाट आर द गोल्स? Maximum CPU utilization is a goal. Fair allocation of a CPU is a goal. Maximum throughput is a goal. Minimum turnaround time is a goal. Minimum waiting time is a goal. And minimum response time is a goal. तो ये सभी टाइम जो है ये हमारे गोल्स हैं. Okay. Now we are having so many CPU scheduling algorithm. Like we have first come first serve, we have shortest job first, we have priority scheduling, we have round robin scheduling, we have highest response ratio next, we have multi-level queue scheduling, and we have multi-level feedback queue scheduling. We are going to study all of these things one by one. हम इन सभी चीज़ों को complete डिटेल में स्टडी करेंगे. But because I believe today's morning session is very hectic, so I'm going to take only one example. मैं अभी सिर्फ एक ही शेड्यूलिंग एल्गोरिथम को कवर करूँगा, and maybe in the evening session we will be able to cover these other algorithms also. ठीक है. So let me take this example. First of all, I'll explain this. So in this case you can see कि हमारे पास एक टेबल गिवन है. इस टेबल में it is given that what is the process ID of the process, what is the arrival time of the process, and what is the burst time of the process. कि process ID क्या है, process system में कब आई थी और process को कितना CPU टाइम चाहिए. burst time means the amount of CPU time required by a process. ठीक है. So when we say first come first serve, it means we are going to schedule the process in the CPU on the basis of अराइवल टाइम, कि कोई प्रोसेस सिस्टम में कब अराइव आई उसके बेसिस पर हम लोग शेड्यूल करेंगे प्रोसेस को. ठीक है, जैसे कि दिस इज़ योर CPU and this process P1 is available, P2 is available, P3 is available. So in this case सबसे पहले जो process आई है that is P3. So P3 process arrived at time 0. Okay, this is basically relative time. तो जो P3 process है वो time 0 पर arrive हुई. So first of all I'm going to execute the P3 process in the CPU for 2 units of time and then I will take this process P3 out of the CPU. उसके बाद P3 के बाद the next process that is arrived is P1. So I'm going to execute the P1 process inside the CPU for 4 units of time और फिर हम P1 process को CPU से बाहर निकाल देंगे. So on the basis of their arrival time we are going to schedule the process. Okay, I'm going to represent this with the help of a Gantt chart. हम इसको Gantt chart की हेल्प से रिप्रेजेंट करेंगे. So Gantt chart says at time 0 we will execute the process P3. P3 process को आप time 0 पर execute करेंगे. From 0 the burst time is 2. 0 से लेकर 2 तक P3 process execute होगी. After this P3 process the next process that arrived is process P1. इसके बाद process P1 arrive हुई है. So from 2 to 3 because time 0 से लेकर 2 तक तो हमने CPU को बिजी लिखा, but next process is arriving at time 3. तो 2 से लेकर 3 तक at this time the CPU was idle. इस समय पर जो CPU है वो idle रहेगा. Okay, because CPU is not doing any task. At time 3 process P1 arrived. तो हमने P1 को execute किया 3 से लेकर 7 तक because the burst time of the P1 is 7. तो burst time of the P1 is 4. So 3 plus 4 is equal to 7. P1 को हमने 7 पे finish किया. So now P1 process is finished, P3 process is finished. Now for time 7 अब आपके पास 3 process available है. You have P2 process, P4 process और P5 process. ये तीनों process arrive हो चुकी है. So the first arrived process is P5. अब आप P5 को execute करेंगे for till time 10. P5 जो है उसको टाइम 10 तक एग्जीक्यूट करेंगे. करेक्ट. आफ्टर दिस अब आपके पास 2 प्रोसेस अवेलेबल है P2 एंड P4. नाउ अराइवल टाइम इज सेम. इफ इन FCFS अराइवल टाइम ऑफ प्रोसेस इज सेम, अगर किसी भी प्रोसेस का अराइवल टाइम सेम है इन दैट केस वी शेड्यूल द प्रोसेस अकॉर्डिंग टू द प्रोसेस ID. तो उस केस में हम प्रोसेस ID के बेसिस पर प्रोसेस को शेड्यूल करते हैं. द प्रोसेस विच इज़ हैविंग अ लोअर प्रोसेस ID विल बी शेड्यूल्ड फर्स्ट. जैसे कि यहाँ पर इसका और इसका अराइवल टाइम सेम है तो हम देखेंगे किसकी प्रोसेस ID कम है. जैसे कि P2 इज़ अ स्मॉलर प्रोसेस ID, सो आई एम गोइंग टू एग्जीक्यूट अ P2 प्रोसेस हियर फ्रॉम 10 to 13 and then I'm going to execute the P4 process here from 13 to 14. Okay, so in this way you can schedule all of these processes in the CPU. Then what is the completion time? P4 process कब complete हुई? P4 process is completing at time 14. P2 process is completing at time 13. P5 process is completing at time 10. P5 जो है वो time 10 पर complete हुआ. P1 process is completing at time 7. And then this P3 process is completing at time 2. P3 ने time 2 पर complete किया. Okay, so you should know the completion time of each of these processes. After this I'm going to find the turnaround time. Turnaround time is your completion time minus arrival time. Completion time में से arrival time को आप subtract करेंगे, then that is your turnaround time. So what the turnaround time of each of these processes? For P1 process the turnaround time is 7 minus 3 is 4, 13 minus 5 is 8, 2 minus 0 is 2, 4 minus 5 is 9, 10 minus 4 is 6. So this is the turnaround time for each of these processes. Okay, after turnaround time we are going to find what is the waiting time of each of these processes, and waiting time is basically turnaround time minus the burst time. आप turnaround time में से burst time को subtract करेंगे, then that is your waiting time. So 4 minus 4 is 0, यानी कि process P1 को बिल्कुल भी wait नहीं करना पड़ा. 8 minus 3 is 5, यानी कि 5 minutes time तक process P2 को wait करना पड़ा. 2 minus 2 is 0, process P3 को wait नहीं करना पड़ा. As soon as process P3 arrived it got the CPU. 9 minus 5 is 4, 6 minus 4 is 2. So this is the waiting time. Now you can find what is the average turnaround time and you can find what is the average waiting time. यहाँ पर average turnaround time क्या रहेगा और average waiting time क्या रहेगा. Okay, so add all this turnaround time. 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 8 is 20, 20 plus 9 is 20 plus 9 कितना होगा आपके पास 29 divided by 5. So this is average turnaround time. Okay, so where is 9 minus 1? Sorry, this is 9 minus 1 is 8. Fine. Then you have so this average turnaround time is 29 divided by 5, which is basically 5.8. 5.8 is your average turnaround time. And what is your average waiting time? On an average हर एक प्रोसेस को कितना वेट करना पड़ा. Add all of this time. 8 plus 2 is 10, 10 plus 5 is 15, divided by total 5 process, which is equal to 3. So for every process, on an average, each of these processes have to wait for 3 units of time. And on an average, each of these processes are in the system for 5.8 units of time. Right? So हर एक process को on an average 5.8 units of time तक CPU के अंदर system के अंदर रहना पड़ा और इन सभी processes को 3 units of time तक wait करना पड़ा. This is what you are going to calculate. Let me repeat again. सबसे पहले हमें प्रोसेस आईडी गिवन है, अराइवल टाइम गिवन है और बर्स्ट टाइम गिवन है. फर्स्ट कम फर्स्ट सर्व पे हम उनके अराइवल टाइम के बेसिस पर उनको P5 टर्न अराउंड, yes it is 3. I'm so sorry, I do a lot of mistakes. Waiting time is 6 minus 3, so waiting time is going to be 3 only. So this is 16 divided by 5, which is equal to 3.2, I guess. 3.2 will be average waiting time. Okay, sometimes I make a lot of mistakes. चलो, anyways, तो यहाँ पर on first come first serve is going to schedule on the basis of arrival time. जो प्रोसेस पहले आई आप सबसे पहले उसको शेड्यूल करेंगे, राइट. तो सबसे पहले कौन सी प्रोसेस आई? P3 प्रोसेस सबसे पहले आई, उसके बाद P1 प्रोसेस आई, P1 के बाद P5 प्रोसेस आई और P5 के बाद P2 प्रोसेस आई और P2 के बाद P4 प्रोसेस आई. ठीक है, फिर उनके बेसिस पे हम निकालेंगे कि ये सभी प्रोसेस कब कंप्लीट हुई. वी विल फाइंड द कंप्लीशन टाइम ऑफ ईच ऑफ दिस प्रोसेसेस. देन वी विल फाइंड द टर्न अराउंड टाइम ऑफ ईच ऑफ दिस प्रोसेस. टर्न अराउंड टाइम इज कंप्लीशन टाइम माइनस अराइवल टाइम. Then we will find the waiting time for each of these process. Waiting time is turnaround time minus burst time. वो आपका waiting time होगा. Okay. So you can also see the same Gantt chart here. तो यहाँ पर आप same Gantt chart को भी देख सकते हैं. So average waiting time is add all of those waiting time on सबका average ले लीजिए. जितने भी waiting time आपके पास आएंगे सबको add करो. और because हमारे पास 5 process थी तो हमने उसको 5 से divide कर दिया. So because we had 5 process, so we had to divide it by 5. So the first come first serve means the process which arrives first in the ready queue is firstly assigned to the CPU. जो सबसे पहले आएगी आप उसको पहले CPU के अंदर असाइन करेंगे. Whenever you have a tie, if two processes arrived at the same time, then a process with a smaller process ID is executed. जिस process की process ID smaller है आप उसको execute करेंगे. It is always non-preemptive. यहाँ पर preemption कभी भी occur नहीं होता है. First come first serve algorithm is always non-preemptive. Advantage क्या, it is very simple to understand, it is very easy to implement and it does not lead to starvation. यहाँ पर starvation भी occur नहीं होगा. So you can clearly see here what is the completion time of each of this process. So process P4 completed at time 14. The process P2 completed at time, sorry, process P4 जो है, process P4 completed at time 14. Process P2 completed at time 13. प्रोसेस P5 completed at time 10. P5 ने 10 टाइम पर कंप्लीट किया. प्रोसेस P1 completed at time 7 एंड प्रोसेस P3 completed at time 2. तो सभी का कंप्लीशन टाइम आपको कैलकुलेट करना है. आफ्टर दिस यू आर गोइंग टू कैलकुलेट द टर्न अराउंड टाइम. टर्न अराउंड टाइम इज कंप्लीशन टाइम माइनस अराइवल टाइम. सो इट इज़ 7 minus 3 is 4 for yes. So 7 minus 3 is 4. Then this 13 minus 5 is 8. Then this 2 minus 0 is 2. Then we have 14 minus 5 is 9. Then we have 10 minus 4 is 6. then we are going to find waiting time. Waiting time is turnaround time minus burst time. So 4 minus 4 is 0, यानी कि प्रोसेस P1 को बिल्कुल भी वेट नहीं करना पड़ा, right? And then you have 8 minus 3 is 5, 2 minus 2 is 0, प्रोसेस P3 को भी बिल्कुल भी वेट नहीं करना पड़ा. And this is 9 minus 1 is 8, 6 minus 3 is 3. Okay, so if you can add all of them, you can add all of these turnaround time and you can take average of them, so you can find average turnaround time. Average turnaround time will be 4 plus 8 is 12, 12 plus 2 is 14, 14 plus 6 is 20, 20 plus 9 is 29, so 29 divided by 5. And what is the waiting time? So 8 plus 6 is 11, 11 plus 5 is 16, so it is 16 divided by 5. So this is your average waiting time. तो ये आपका average waiting time आएगा. Okay, so you should remember what is the average waiting time and you should know what is the average turnaround time for each of these process. Okay, why P3 is having the average waiting time as 0? Because as soon as P3 arrive, P3 time 0 पर arrive हुई थी और P3 को आते ही CPU मिल गया. Because P3 को आते ही CPU मिला, that is why the waiting time for P3 is 0. In the same way, whenever P1 arrived at time 3 and P1 got the CPU at time 3, P1 को आते ही CPU मिला, that is why the waiting time for the process P1 is also 0. P3 and P1 do not have to wait to get the CPU. दोनों को CPU लेने के लिए wait नहीं करना पड़ा. Okay, so what is the advantage here? Advantage is it is very simple and easy to understand. It can be implemented very easily using a queue as a data structure and it does not lead to starvation. यानी कि जितनी भी प्रोसेस है सबको CPU मिलेगा ही मिलेगा, कोई ऐसा प्रोसेस नहीं हो सकता जिसको CPU ना मिले. Disadvantages, it does not consider the priority of the burst time of the process. हम किसी प्रोसेस की प्रायोरिटी को यहाँ पर कंसिडर नहीं करते हैं and it suffers from the convoy effect. तो convoy effect को हम बाद में चेक करेंगे. We'll look at the convoy effect later on. So whatever we have covered so far in today's session, please revise this and take care to all of you. Have a good day. Bye bye and take care. Let us continue with our session. So as I said, in this session also again we are taking the same topic that we started in the morning, which is the process scheduling algorithm. And in the morning session we have taken the example of first come first serve, which is FCFS algorithm. So in this session we will be continuing with our FCFS algorithm, that is first come first serve algorithm. And now I'm going to take one more example of FCFS. If any one of you is having any doubt in first come first serve, I believe with this example your doubt will be cleared. Okay, so let us continue. Read the question first. They are saying consider the set of 6 processes whose arrival time and the burst time are given below. We have the arrival time of the processes. This is representing the process ID, this is representing the arrival time of the process, and this is representing the burst time of the processes. Now they are saying if the CPU scheduling policy is FCFS, अगर हम first come first serve algorithm CPU scheduling policy को use करते हैं, and there is 1 unit of overhead in scheduling the process. So this is 1 unit of overhead, and this 1 unit of overhead is basically your overhead due to context switch. तो context switch करने की वजह से ये हमारे पास एक overhead given है. Now they are asking find the efficiency of the algorithm. Here we have to find the efficiency. Okay, so this question is little different as compared to the previous questions that we have done, because in the previous question we were asked to find what is the average waiting time, what is the average turnaround time, but in this question it is more about finding the efficiency. So I'll take an example here and we'll try and find out everything, turnaround time, the waiting time, सब कुछ हम find out करेंगे so that everything should be clear. So here we are using the first come first serve algorithm. That means the process which came first, जो सबसे पहले process आएगी, we are going to schedule that process for execution. Okay, so this is representing your Gantt chart. So this Gantt chart basically represents that what is a process which is in the CPU at a given time. किस time के अंदर कौन सी process CPU के अंदर है, उसको हम Gantt chart से represent करते हैं. Now because it is using the first come first serve scheduling algorithm, so the process which arrived first, जो सबसे पहले आई, we are going to schedule that process in the CPU. So the process P1 arrived first, so I'm going to schedule the process P1 to be executed in the CPU. It will start executing from time 0, and the total burst time of this process is 3. So from time 0 to time 3, the process P1 will execute in the CPU. Okay, now look at it very carefully. They are saying that there is an overhead of 1 unit of time. That means between switching the context of one process to the next process, यानी कि जो हमारे पास context switching होती है, context को switch करने के लिए हमारे पास 1 unit का time लगेगा. there is a 1 unit of overhead. So the next process can only come at the time unit 4. So the next process according to the arrival time is process P2. So I'm going to execute the process P2 for how much time? For 2 units of time. So process P2 will finish at time 6. Again, there will be an overhead for context switching. Then the next process is process P3. I'm going to execute the process P3 till 8 units of time. Again, there will be a context switching overhead. Then I'm going to execute the process P4 till 4 units of time. So basically it will finish at time 13. Again, there will be some context switching overhead, and then I'm going to execute the process P5. So process P5 will execute till 19, and again there will be context switching overhead, and then I'm going to execute the process P6, and this process P6 will finish at time 22. So you can clearly see what is the finishing time of these processes, right? So if I write what is the finish time, or you can say the completion time. So what is the finish time or completion time? So process P1 finished at time 3, process P2 finished at time 6, process P3 finished at time 8, process P4 finished at time 13, process P5 finished at time 19, and process P6 finished at time 22. So this is the finishing time of each of these processes. Now what is the turnaround time? So turnaround time is completion time minus arrival time. So for process P1, 3 minus 0 is 3, 6 minus 1 is 5, 8 minus 2 is 6, 13 minus 3 is 10, 19 minus 4 is 15, 22 minus 5 is 17. Now what is the waiting time? So waiting time is basically your turnaround time minus the burst time of each of these process. So for the waiting time for the process P1 is 3 minus 3, which is 0, 5 minus 2, which is 3, 6 minus 1 is 5, 10 minus 4 is 6, 15 minus 5 is 10, 17 minus 2 is 15. So if you add the total waiting time here, the total waiting time is 3 plus 5 is 8, 8 plus 10 is 18, 18 plus 6 is 24, and 24 plus 15 is 39. In the same way, the total turnaround time, this is 8, 8 plus 6 is 14, 14 plus 10 is 24, 24 plus 15 is 39, and if you add 39 plus 17, that is going to be 56. So the average turnaround time here is going to be 56 divided by total number of process, which is 6, and the average waiting time here is going to be 39 divided by 6. I hope it is clear. So you can easily find out what is the average waiting time. So average waiting time is going to be 6.5 units. In the same way, you can also find what is the average turnaround time. So this average turnaround time, that is going to be 9.333 something. Okay, question is, waiting time should be the first response time minus arrival time. No, that is not the waiting time. The waiting time is basically for what the turnaround time minus the burst time. That means, let me explain you with the real world example. This is a bank. Okay, in a bank you entered at 9 a.m. and you want to deposit some amount, and this is the first counter and this is your second counter. So you reach the first counter at 10 a.m. you are done, your work is 10 a.m. and 5 minutes. Then you reach the second counter at 11 a.m. and you have finished your work is 11 a.m. 5 minutes, and then you left the bank at 11 a.m. 5 minutes. So basically it took you total 10 minutes of your time to do the work. The rest of the time that you were there, you waited in the queue. You are waiting for your work to be done. In the same way, In this case also, when you calculate what is the waiting time, so waiting time is basically how much time you have to wait to execute the task, to finish your work. So even if you are present in the system for 10 minutes of time, आप 10 minutes of time तक system के अंदर present है, but your work was only of 4 units of time, so rest of the 6 minutes of time you wasted your time or you have done something else, right? तो आपने जो ये total time है इतना wait आपने किया है. Okay, clear? Now out of all this time, ये जितना भी आपके पास time था, if I want to find efficiency, efficiency is useful time divide by the total time. Always efficiency is always useful divided by total. तो हमेशा जब भी हम efficiency को निकालेंगे तो वहाँ पर सारा useful divided by total ही हमारे पास efficiency आएगा. So if you see in this entire time how much time the CPU was busy, कितने time तक CPU busy था, so that is the total burst time here. If you add the total burst time from here, it is going to be 3 plus 2 plus 1 plus 4 plus 5 plus 2, right? So that is going to be 6, 10, and that is going to be 17 units. So for 17 units you have done some work, but rest of the total time, that is 22 units, there was some time that you have wasted, right? So यहाँ पर जो time है आपके पास, this entire time that you have done in the context switching, that was a complete waste. So how much time was the wastage? That is 5 units of time. So efficiency is going to be 17 divided by 22, or if you want to find efficiency in terms of percentage, then you have to multiply it by 100. So this much is your efficiency in terms of percentage. Okay, the same thing you can see from here also. Okay, so here what they have done is they have assumed that in the beginning of the process, in the beginning first process, when it is arrived, before arriving the first process, there was a time which they have used for overhead, right? In many of the questions they will be giving that this context switching overhead will not be counted in the beginning as well as in the end. काफ़ी क्वेश्चंस में दिया होगा आपके पास एग्जाम के अंदर कि जो context switching end जो है वो beginning में हमें calculate नहीं करना. So here in my case I have not evaluated this context switching before executing any process. After I execute the first process, then only I have evaluated the context switching overhead. But in this question they have not mentioned anything like this. Therefore I had to take a context switching overhead before the first process. हमें यहाँ पर first process से पहले context switching overhead लेना पड़ेगा. Okay, so you can calculate the total overhead here, and then you can also find out what is the total efficiency in this case. Okay, so this is one more example for first come first serve algorithm. Here we have 4 processes, P0, P1, P2 and P3. आपके पास 4 processes हैं, and this is the arrival time of each of these processes, right? And this is the execution time for each of these processes, right? So in this way you can calculate कि आपके पास total completion time क्या रहेगा and what is the service time. So service time here is kind of the response time here. Response time is the time at which the process got the CPU for the very first time. Process P0 got the CPU at time 0. Process P1 got the CPU at time 5. Process P2 got the CPU at time 8. Process P3 got the CPU at time 16. Now what is the completion time of each of this process? Process P0 finished at time 5. Process P1 finished at time 8. Process P2 finished at time 16. And process P3 finished at time 22. So now you can calculate the other values. There is a turnaround time as well as the waiting time. These things you can evaluate after this. इसके बाद आप इन चीज़ों को भी evaluate कर सकते हैं. I hope it is clear. So the next algorithm that we will be studying after this is going to be your shortest job first algorithm. Shortest job first algorithm. Okay, so we have studied this first come first serve. अब तक हमने फर्स्ट कम फर्स्ट सर्व एल्गोरिथम को कंप्लीट कर लिया है. सो नेक्स्ट इज योर शॉर्टेस्ट जॉब फर्स्ट. सो इन केस ऑफ फर्स्ट कम फर्स्ट सर्व, द क्राइटेरिया जो फर्स्ट कम फर्स्ट सर्व था वहाँ पर जो क्राइटेरिया था, क्राइटेरिया फॉर शेड्यूलिंग इज़ योर अराइवल टाइम. यहाँ पर अराइवल टाइम क्राइटेरिया था. ओके, एंड इफ देयर इज़ अ टाई, इन केस ऑफ अ टाई वी यूज्ड द प्रोसेस आईडी. and the mode of execution was non-preemptive. Mode of execution यहाँ पर non-preemptive था. Okay, but when we take the shortest job first, here the criteria is the burst time of a process. Criteria is burst time of a process. किसी प्रोसेस का क्या बर्स्ट टाइम है उसके बेसिस पर हम प्रोसेस को शेड्यूल करेंगे. नाउ इफ देयर इज अ टाई बिटवीन एनी टू प्रोसेसेस, इफ द बर्स्ट टाइम ऑफ टू प्रोसेसेस आर सेम, then we are going to break the tie on the basis of their arrival time. तो हम उस टाई को उसके अराइवल टाइम के बेसिस पर हम ब्रेक करेंगे. एंड देयर आर टू मोड्स ऑफ एग्जीक्यूशन. द शॉर्टेस्ट जॉब फर्स्ट कैन बी एग्जीक्यूटेड implemented in a non-preemptive fashion, as well as it can also be implemented in a preemptive fashion. तो नॉन प्रेम्प्टिव फैशन में भी हम इसको एग्जीक्यूट करते हैं और प्रेम्प्टिव के अंदर भी. सो इफ़ वी हैव अ शॉर्टेस्ट जॉब फर्स्ट विद प्रीएम्पशन, so that algorithm is called as shortest remaining time first algorithm. Shortest remaining time first algorithm, which is SRTF, shortest remaining time first algorithm. Okay, so I'll take example of shortest job first in a non-preemptive fashion first. First we will try and understand what is a non-preemptive shortest job first, and then we will take an example of preemptive shortest job first. Okay, so let us assume that we have the following process. This is the process IDs, this is the arrival time, and this is the burst time of a process. So process ID is P0, P1, P2, P3 and P4. Arrival time is 0, 2, 4, 1 and 3. The burst time is 5, 1, 2, 1 and 6. Okay, so same example I am taking for first come first serve also. This is your process ID, this is the arrival time, and this is the burst time of the processes. Process ID is P0, P1, P2, P3 and P4. The arrival times are 0, 2, 4, 1 and 3. The burst times are 5, 1, 2, 1 and 6. These are the burst time of these processes. Okay, now in this case, when we execute these processes, in case of a shortest job first, we are going to look at their burst time. हम shortest job first में उनके burst time को check करेंगे, and according to the burst time we are going to schedule the processes. The process which is having a smaller burst time, उसको हम सबसे पहले execute करेंगे, and the process which is having a larger burst time we will execute it later. But how we are going to do it? देखो, we are only going to make a scheduling decision whenever we have more than one process. अगर आपके पास एक से ज़्यादा processes हैं तभी आप scheduling decision लेंगे. If you have only one process at a given time, then you cannot make a scheduling decision. जैसे कि टाइम 0 पर ये सभी processes arrive नहीं हुई है. The process P1, P2, P3 and P4, they have not arrived at time 0. Only process P0 is available at time 0. Because only one process is available, so we are going to execute that process. टाइम 0 पर सिर्फ एक ही प्रोसेस अवेलेबल है, इसी वजह से हम सिर्फ उसी प्रोसेस को एग्जीक्यूट करेंगे. सो at time 0 only P0 is available, so I'm going to schedule process P0 here, and the process P0 will finish at time 5. Process P0 है वो टाइम 5 पर फिनिश होगी. Then till time 5 all these processes arrived. ये सभी प्रोसेस आ चुकी है सिस्टम के अंदर. All these processes arrived till time 5. Now we can make a scheduling decision. So how we are going to make a scheduling decision? On the basis of burst time. हम burst time के basis पर scheduling decision लेंगे. Okay, the process which is having a smaller burst time, we are going to execute that process. Fine. So here process P1 and P3, they are having the same burst time, so we are going to break the tie on the basis of arrival time. I am going to execute the process P3 here, and P3 will execute for till time 6. After this, process P1 will be executed till time 7. After this, process P2 will be executed till time 9, and then process P4 will be executed till time 15. So you can clearly see here, यहाँ पर between the process P4 and process P2, because P4 is having a larger burst time, इसी वजह से हमने P4 को बाद में किया. That is why we have done P4 later and we have done P2 earlier than P4. Okay. So what is the completion time of this process? Process P0 finished at time 5, process P1 finished at time 7, process P2 finished at time 9, process P3 finished at time 6, and process P4 finished at time 15. Okay, what is the turnaround time? Turnaround time is completion time minus arrival time. So 5 minus 0 is 5, 7 minus 2 is 5, 9 minus 5, 4 is 5, 6 minus 1 is 5, and 15 minus 3 is 12. So everyone is getting a turnaround time as 5. Now what is the waiting time? The waiting time is turnaround time minus the burst time. Turnaround time में से हम burst time को minus करेंगे. So 5 minus 5 is 0, 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 1 is 4, 12 minus 6 is your 6. This is the waiting time, right? So add the total waiting time is 17. So if you see what is the average waiting time, that is going to be 17 divided by 5, which is 3.4. 3.4 is the average waiting time if I am using the shortest job first algorithm. But if I am using the first come first serve algorithm for the same question, अगर हम यहाँ पर first come first serve को use करते, then what could have been the answer? So in case of first come first serve, at time 0 only P0 is available. So I'm going to execute P0 from time 0 to 5. Then I'm going to execute the process P3 from 5 to 6, because after this process arrived. Then I'm going to execute the process P1 from 6 to 7, and then I'm going to execute the process P4. उसके बाद हम process P4 को execute करेंगे from 7 to 13, and then I'm going to execute the process P2 from 13 to 15. So you can see the total completion time is same, but there's a difference here. Where is the difference? This is the place where you can see a difference. यहाँ पर आप difference देख सकते हैं. Okay. So what is the completion time here? Completion time for P0 is 5, P1 is 7, P2 is 15, P3 is 13, I think P3 is 6, and P4 is 13. What is the turnaround time? Turnaround time is completion time minus arrival time. So turnaround time is 5 minus 0 is 5, 7 minus 2 is 5, 15 minus 4 is 11, 6 minus 1 is 5, and 13 minus 3 is 10. And what is the waiting time here? Waiting time is turnaround time minus arrival time. So I hope I have not done any calculation mistake. Please do check if I have done any calculation mistakes. So waiting time is turnaround time minus arrival time. So 5 minus 0 is 5, 5 minus 2 is 3, 11 minus 4 is 7, 5 minus 1 is 4, 10 minus 3 is 7. So the total waiting time here, so I'm so sorry, I think I've done a big mistake here, because the waiting time is turnaround time minus burst time. Waiting time is turnaround time minus the burst time. Okay. So it is 5 minus 5 is 0, 5 minus 1 is 4, 11 minus 2 is 9, 5 minus 1 is 4, 10 minus 6 is 4. So the total waiting time here is basically 21. 21 is the total waiting time. So if I ask what is the average waiting time in this case is 21 divided by 5, which is equal to 4.2. In case of first come first serve algorithm, we are having the same data. आपके पास exactly same data है. This is exactly the same data we are using here, exactly the same data. But the problem is, in case of first come first serve, the average waiting time that these processes are getting is 4.2 units. But in case of shortest job first, the average waiting time is 3.4 units. Shortest job first में average waiting time 3.4 units आ रहा है, और first come first serve में average waiting time 4.2 units आ रहा है. Is it clear so far? So arrival time 3. See, in case of the shortest job first, P0 process is finishing at time 5. P0 जो है वो time 5 पर finish होगी. Until time 5 all these processes have already arrived. Time 5 तक ये सभी processes already arrive हो चुकी है. Okay. Okay, let me explain you why do we need shortest job first. Why shortest job first is better than, why shortest job first is better than FCFS. फर्स्ट कम फर्स्ट सर्व से शॉर्टेस्ट जॉब फर्स्ट एल्गोरिथम बेटर क्यों है, एंड दिस प्रिंसिपल वी कैन ऑल्सो अप्लाई इन आवर डे टू डे लाइफ. तो आपकी डे टू डे लाइफ में वेन एवर यू आर डूइंग सम वर्क, अगर आप कुछ भी काम करते हैं डे टू डे लाइफ के अंदर, सो टू इंक्रीज योर प्रोडक्टिविटी यू शुड डू द वर्क विच इज़ स्मॉलर, द शॉर्टर टाइम वर्क फर्स्ट, एंड डू अ वर्k which is a larger work, right? Because if you do a larger work in the beginning, then all the smaller works has to wait. तो जो waiting time है उन सभी कामों का वो increase हो जाएगा. So it is always better to a shorter work first as compared to the larger work. Okay. So why it is better? Because this FCFS algorithm, it suffers with the convoy effect. It suffer with convoy effect. ये कॉन्वॉय इफेक्ट से सफ़र करता है. एंड वट एग्जैक्टली इज़ अ कॉन्वॉय? कॉन्वॉय होता क्या है? हैव यू सीन समथिंग लाइक दिस कॉन्वॉय? सो यू मस्ट हैव हर्ड दिस वर्ड कॉन्वॉय फ्रॉम हियर, और यू कैन टेक दिस एग्जाम्पल, राइट? व्हेन लॉट ऑफ व्हीकल्स दे आर मूविंग टुगेदर इन अ लाइन, मोस्ट ऑफ द टाइम इट इज़ फॉर आर्मी, राइट? सो व्हेन लॉट ऑफ आर्मी व्हीकल्स आर moving together in a line, that is called as a convoy. Correct? So a lot of things you can see, they are shown online. तो काफ़ी चीज़ें हैं जो convoy के लिए online show की गई है, right? So what exactly is a convoy? Convoy means if a lot of things are going together, it is a kind of a group. Convoy जो है वो एक group की तरह होता है. I'll take two examples. So there is a example number 1. So this is a road, right? On this road you have various vehicles. You might be having a truck. So maybe this is a truck like this, huge truck. Okay. Then after this truck you have a mini bus. And then you have a car, and then you have a bike. Correct? But what is the problem here? The problem here is when these vehicles are going together in one direction, in one line, and they cannot overtake each other. जैसे this bus cannot overtake the truck, this car cannot overtake the bus, this bike cannot overtake the car. So the biggest problem in that case is because truck is the slowest one. ये सबसे slow move करता है because truck is the slowest one, and truck runs at a speed of 30 kilometers per hour, right? Even though this bus can run at a speed of 60 kilometers per hour, this car can run at a speed of 100 kilometers per hour, this bike can run at a speed of maybe 100 kilometers per hour, but because in the front of them there is a truck, तो सबसे एक heavy process जो है, जो सबसे heavy एक truck है, वो इन सबसे आगे है. So because of this all of them have to slow down. ये जितने भी हैं हमारे पास, ये सबको slow down करना पड़ेगा. All of them have to slow down somehow because they cannot overtake each other. Correct? So if you have a process which is a very very heavy process, and if your heavy process is going in the front in the beginning, मतलब आपकी जो heavy processes हैं वो आगे जा रही है, if your big process or heavy process is executing, then during that time all of other processes has to wait. All these processes are going to slow down, right? This is a convoy effect. But instead of this, if we have something like this, that we have a bike which is going in the beginning, आपका bike जा रही है, so after this bike you are having a car like this, आपके पास एक कार है, then you have a mini door or mini bus like this, right? And then you have a truck like this. Correct? तो इस तरीके से अगर आपके पास एक complete concept है. Now in this case, because this bike is not dependent on this car, तो बाइक जो है वो सबसे आगे स्पीड से जा सकती है. इट कैन टेक अ स्पीड ऑफ 110 किलोमीटर्स पर आवर. दिस कार कैन रन एट स्पीड ऑफ 100 किलोमीटर्स पर आवर. दिस मिनी बस कैन run at a speed of 60 kilometers per hour, and this truck can run at a speed of 30 kilometers per hour, because they are not affecting each other. If a lighter process is going in the beginning, then it is not affecting all the other processes. वो बाकी सभी processes को इतना affect नहीं करेगा, because it is the lightest process. Correct? So this is the issue. This is a convoy, and this FCFS algorithms suffers from this convoy effect. And this shortage of first algorithm actually resolves this issue. Shortage of first algorithm जो है वो इसी issue को resolve करता है. Let me explain you, let me prove you with the help of example. Let me prove you with the help of an example. Assuming this is the process IDs, this is the arrival time, and this is the burst time. Process P0, P1, P2 and P3. Or let us take 3 processes only for simplicity. The process P0 at time 0, 1 and 2. The burst time of these processes are 40, 1 and 3. Correct? And then we have the same data. This is the process ID, arrival time and the burst time. So P0, P1 and P2. Burst times are again 40, 1 and 3. But the problem here is that the difference here is P0 arrived in the last. तो P0 जो है वो सबसे लास्ट में अराइव हुई है. Correct? P0 arrived in the last. Okay, and in both of those cases I'm using FCFS here. I'm also using FCFS here, first come first serve algorithm. In the first case, at time 0, process P0 will execute from 0 to 40. Then process P1 will execute from 40 to 41. Then process P2 will execute from 41 to 44. So the completion time of P0 is 40, the completion time of P1 is 41, the completion time of P2 is 44. Then the turnaround time is 40 minus 0 is 40, 41 minus 1 is 40, 44 minus 2 is 42. And the waiting time here is going to be 0, 39 and again 39. So the total waiting time in this case is 78. So average waiting time will be 78 divided by 3, which is equal to 26. 26 will be the average waiting time in this case. But in the second example, we have the same data. The only thing is the arrival time we have changed. So because of this arrival time, the order of execution of these processes changed. Arrival time की वजह से इनका जो order of execution है वो change हो गया. So P1 will finish at time 1, P2 will finish at time 4 and P0 will finish at time 44. So the completion time is going to be 44, 1 and 4. The turnaround time is going to be 42, 1 and 3, and the waiting time is going to be this is 42 minus 40 is 2, 0 and 0. So total waiting time is 2. So average waiting time in this case is going to be 2 divided by 3, which is 0.66, right? So you can clearly see the difference. अगर हम first come first serve में पहले उस प्रोसेस को एग्जीक्यूट करते हैं जो सबसे छोटी है. इफ़ यू एग्जीक्यूट अ प्रोसेस विच इज़ द स्मॉलेस्ट प्रोसेस इन द बिगिनिंग, देन द वेटिंग टाइम कैन बी मिनिमाइज्ड. उस केस में जो आपका वेटिंग टाइम है वो मिनिमाइज किया जा सकता है. इट्स अ प्रूफ दैट द कॉन्वॉय इफेक्ट एग्जिस्ट. इट इज़ रिप्रेजेंटिंग द कॉन्वॉय इफेक्ट इन FCFS algorithm. The second one is your shortest remaining time first algorithm. Shortest remaining time first algorithm. So what does this shortest remaining time first algorithm says? It is basically shortage of first algorithm with preemption. यहाँ पर हमारे पास preemption का concept आता है. ठीक है, we do preemption with this shortest remaining time first. Let me explain you with the help of an example. This is the process ID, this is the arrival time of these processes, and this is representing the burst time of these processes. Process ID is P0, P1, P2, P3 and P4. The arrival times are 0, 1, 2, 3 and 4. The burst time is 5, 2, 3, 6 and maybe 1. Okay. Now I'm going to solve the same question with the shortest remaining time first, which is SRTF, as well as the shortest job first. सेम क्वेश्चन को हम shortest job first और shortest remaining time first से भी सॉल्व करेंगे. ओके, सो अगेन P0, P1, P2, P3 and P4. The arrival times are 0, 1, 2, 3 and 4. The burst times are 5, 2, 3, 6 and 1. Clear? So सबसे पहले हम लोग सॉल्व करते हैं शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट को. Look at it very very carefully because here we are going to have preemption and because of preemption it will make the question very complicated. preemption की वजह से जो क्वेश्चन है वो काफ़ी कॉम्प्लिकेट हो जाएगा. ओके, देखो एट टाइम ज़ीरो ओनली वन प्रोसेस इज़ अवेलेबल. टाइम ज़ीरो पर सिर्फ एक ही प्रोसेस अवेलेबल है. द प्रोसेस इज़ प्रोसेस P0. सो आई हैव टू एग्जीक्यूट द प्रोसेस P0 बट टिल हाउ मच? आई एम गोइंग टू एग्जीक्यूट टिल टाइम 1 ओनली. यानी कि हमने टाइम ज़ीरो पर, यह आपका CPU था, हमने टाइम ज़ीरो पर प्रोसेस P0 को CPU के अंदर दिया. बट एट टाइम 1 P1 प्रोसेस अराइव्ड एंड दिस P1 प्रोसेस इज़ हैविंग अ बर्स्ट टाइम ऑफ ओनली 2 यूनिट्स. P1 प्रोसेस का जो बर्स्ट टाइम है वो सिर्फ 2 यूनिट्स का है. इट इज़ ओनली हैविंग अ बर्स्ट टाइम ऑफ 2 यूनिट्स विच इज़ वेरी लेस एज कम्पेयर टू P0, राइट? बिकॉज P0 जो है वो 0 से लेकर 1 टाइम तक 1 यूनिट तक एग्जीक्यूट हो गया था. सो द बर्स्ट टाइम रिमेनिंग फॉर प्रोसेस P0 वॉज 4. Now you can see between P0 and P1, P1 is a shorter process because the burst time is 2. तो हमने क्या किया? हमने P0 को CPU से बाहर निकाला. We removed P0 out of the CPU. We took it out of the CPU forcefully and then we have given this P1 process in the CPU. अब हमने P1 प्रोसेस को CPU के अंदर डाला and we are executing this P1 process till time 3. Why? Because even if at time 2 आपके पास P2 प्रोसेस आ रही है बट दिस P2 प्रोसेस इज़ हैविंग अ हायर बर्स्ट टाइम. इसका बर्स्ट टाइम अभी भी हाई है. नाउ टिल टाइम 3 यू हैव द प्रोसेस P1 विच इज़ फिनिश्ड. नाउ अब टाइम 3 तक, टिल टाइम 3 यू हैव द प्रोसेस P0, यू हैव द प्रोसेस P2 एंड यू हैव द प्रोसेस P3. अब आपके पास 3 प्रोसेसेस अवेलेबल हैं, P0, P2 एंड P3. आउट ऑफ दीज 3 प्रोसेसेस P2 इज़ हैविंग द स्मॉलेस्ट बर्स्ट टाइम. तो हम P2 को एग्जीक्यूट करेंगे till time 4 because at time 4 the burst time of P2 will become 2. time 4 तक P2 का जो burst time है वो 2 हो जाएगा. and now the other process P4 which is arriving at time 4 which is having a smaller burst time. P4 का जो burst time है वो P2 से कम है. so I'm going to take P2 out of the CPU forcefully and I'm going to give P4 in the CPU. अब हम CPU के अंदर P4 को देंगे. so this P4 will finish at time 5. Now you can see all of these processes are arrived. अब सभी processes आ चुकी है. Now in this case I'm again going to execute the smallest process. The smallest process is P2. I'm going to execute P2 till time 7. Then I'm going to execute this next smallest process which is the P0. P0 will execute till time 11. Then I'm going to execute the process P3. It will finish at time 17. So what is the completion time here? P0 finished at time 11. P1 finished at time 3. Then we have P2 finished at time 7. P3 finished at time 17. And P4 finished at time 5. And what is the turnaround time here in this case? So turnaround time is completion time minus arrival time. So it is 11, 2, 5, 14 and this is 1. Okay. And the same way you can find what is the waiting time. Waiting time is turnaround time minus the burst time. So waiting time here in this case. So what will be the waiting time of these processes? The waiting time is going to be 11 minus 5 is 6. 2 minus 2 is 0. 5 minus 3 is 2. 14 minus 6 is 8. 1 minus 1 is 0. So the total waiting time is 16. And the average waiting time is going to be 16 divided by 5 which is 3.2. 3.2 will be the average waiting time in case of shortest remaining time first algorithm. Now let us try and solve the same question using shortest job first. इसको हम shortest job first से करने की कोशिश करते हैं and maybe you will be able to understand the difference because of this. So in case of shortest job first you cannot have preemption. यहाँ पर preemption नहीं हो सकता. This one is a non-preemptive algorithm that I am taking. It is non-preemptive. It is a non-preemptive algorithm. So at time 0, P0 is available and I'm going to execute P0 till time 5. P0 जो है वो time 5 तक execute होगा. Then P0 is finished. Now I'm going to execute the smallest process which is the process P4 बिकॉज P4 प्रोसेस अराइव्ड एट टाइम 4 जो कि टाइम 5 से कम है, सो P4 प्रोसेस ऑलरेडी अराइव्ड विच इज़ फिनिशिंग एट टाइम 6. देन the next smallest process is P1 which is finishing at time 8. Next smallest process is process P2 which is finishing at time 11, and the next smallest process is process P3 which is finishing at time 17. So what is the turnaround time or what is the completion time for each of this process? P0 finishing at time 5, P1 at 8, P2 at 11, P3 at 17 and P4 at 6. What is the turnaround time? That is 5 minus 0 is 5, 7, 9, 14 and 2. And what is the waiting time here? 5 minus 5 is 0, 7 minus 2 is 5, 9 minus 3 is 6, 14 minus 6 is 8, 2 minus 1 is 1. So the total waiting time in this case will be 5 plus 8 is 11, 11 plus 9 is 20. So average waiting time is going to be 20 divided by 5 which is equal to 4 units. So you can see even the shortest remaining time first algorithm is doing better than shortest job first. The shortest remaining time first algorithm है वो shortest job first algorithm से better behave कर रही है. Okay? You can also do the same question using FCFS. आप इसको first come first serve से भी कर सकते हैं. So using FCFS, first of all I'm going to execute the process P0 which will finish at time 5. Then I will execute the process P1 which will finish at time 7. Then I will execute the process P2 which will finish at time 10. Then I will execute the process P3 which will finish at time 16. And then I will execute the process P4 which will finish at time 17. So again you can find what is the average waiting time in case of FCFS. आप FCFS से भी average waiting time निकाल सकते हैं, and you will find that even this FCFS algorithm is doing worse as compared to SJF. तो FCFS में waiting time और increase हो जाएगा. So in general for waiting time this FCFS algorithm will be having the highest waiting time. Then the waiting time, it will be having the highest waiting time. Then SJF will be there, and then SRTF will be there. So this will be having the lowest waiting time. इसका जो waiting time है वो lowest रहेगा. So I hope all of you are able to understand this कि कैसे काम कर रहा है. So in case of shortest remaining time first, we will give the precedence as compared to their burst time, right? And in short first come first serve, we'll give preference as compared to their arrival time. Okay. Now in the same way, there's one more variation of this which is called as longest remaining time first. तो हमारे पास जो algorithms है, first we have studied FCFS algorithm. The second algorithm that we studied is shortest job first algorithm. The third algorithm was shortest remaining time first algorithm. The fourth algorithm will be longest job first algorithm. Fifth will be longest remaining time first algorithm. Sixth will be your priority based scheduling algorithm. Then your seventh algorithm will be your round robin algorithm. Then your eighth algorithm that we will be studying is highest response ratio next algorithm. Then ninth algorithm will be feedback queue scheduling. Right? And the 10th will be multi-level feedback queue scheduling. Right, so these are all the algorithms that we will be studying. So we have already seen the FCFS algorithm, we have seen the SJF algorithm, we have seen the SRTF algorithm. Now the next algorithm that we are covering here is longest remaining time first algorithm and longest job first algorithm. तो अब हमारे पास longest remaining time और longest job first algorithm है. Okay, so let us go through this. LJF or first longest job first, and this is longest. Let me do the same questions here with multiple algorithms. This is longest job first, this is shortest job first, this is longest remaining time first, and this is let me draw the screen into 4 portions because I have to explain all the 4 algorithms here. Let me do it this way. So here I'm going to explain the shortest job first, this will be longest job first. Okay, then I will explain the shortest remaining time first algorithm, then I will explain the longest remaining time first algorithm. Okay, I'll take a data and we are going to work on the same data for all of these algorithms. We will be having a process ID, we will be having the arrival times, and then we will be having the burst time of these processes. Process IDs P0, P1, P2 and P3. Arrival times are 0, 1, 2 and 3. The burst time are 4, 1, 2 and maybe 6, or maybe let me change it here. So let me make it as a 4, 1 and maybe 6 and maybe 2. Okay, let me take the same data here, process ID, arrival times and burst time. So we have P0, P1, P2 and P3. Arrival time is 0, 1, 2 and 3. The burst times are 4, 6, 1 and 2. SRTF, again process ID, arrival time and burst time. P0, P1, P2 and P3. 0, 1, 2 and 3. Burst times are 4, 6, 1 and 2. Longest remaining time first, process ID, arrival time and burst time. So again P0, P1, P2 and P3. Arrival times are 0, 1, 2 and 3. Burst times are 4, 6, 1 and 2. Okay, so this is the question that we have so far. Okay, so both of these shortest job first is non-preemptive. ये भी आपके पास non-preemptive है, and in this longest job first is also non-preemptive. ये भी आपके पास non-preemptive है. Let me explain it step by step. Simple step पे हम explain करने की कोशिश करेंगे. I'll try my best to make you understand everything very easily. ठीक है? So in case of shortest job first, at time 0 only one process is available. Time 0 पर सिर्फ एक ही process available है और कोई process available नहीं है. So we have to execute the process P0. It will finish at time 4. Correct? Now till time 4 all the other processes arrived. Time 4 पर बाकी सभी processes आ चुकी है. So I'm going to find the process which is having the shortest burst time. The shortest burst time is with the process P2. So I'm going to execute P2 till time 5. Then I will execute the process P3 till time 7. And then I will execute the process P1 till time 13. So the completion time of these processes are going to be 4, 13, 5 and 7. Okay. In the same way, let us find for longest job first. At time 0 only one process is available. Time 0 पर सिर्फ एक ही process available है, एक से ज़्यादा processes available नहीं है. So we cannot make a scheduling decision time 0. So I'm going to execute the process P0 from time 0 to 4. After this, all these processes arrived. So I have to find a process which is having the longest burst time. So longest burst time is with the process P1. So I'm going to execute the process P1 till time 10. Then I will execute the process P3 till time 12. And then I will execute the process P2 till time 13. So the completion time of these processes are going to be 4, 10, 13 and 12. Let us do shortest remaining time first. So at time 0 only one process available which is P0. So I will execute P0 till time 2. हम P0 को time 2 तक execute करेंगे because after this the burst time of P0 will become 2. अब time 2 पर you already have a new process which is P2 which is having a smaller burst time. P2 पर time 2 पर P2 एक process available है जिसका burst time कम है. So you are going to execute the process P2 here till time 3. Then you will now you have 3 processes available which is P0, P1 and P3. Because P0 and P3 are having the same burst time, so I will break the tie according to the arrival time. So I will execute P0 here till time 5. Then I will execute the process P3 here which is having a burst time of 2. Then I will execute the process P1 here which will finish at time 13. So the completion time here for P0 it will be 5, for P1 it will be 13, for P2 it will be 3 and for P3 it will be 7. Okay, You can clearly see the difference between the completion time in all of these three cases. तीनों cases में completion time में difference आया है. The completion time at which the time at which a process is finishing, that is changing in all these three cases. Now the most complicated out of all, इन सब में जो सबसे ज़्यादा complicated है वो है longest remaining time first algorithm, because after some point of time you will see the number of context switches will increase. इस केस में आपके पास जो number of context switch है वो increase होंगे. At time 0 only P0 is available, right? So you will execute P0 from 0 to 1. क्यों? क्योंकि after this the burst time will become 3. Now you can clearly see we have a process P1 which is having a highest burst time. इसका burst time सबसे high है. So I'm going to execute process P1 till what time? कब तक execute करेंगे? I'm going to execute it till time again 4. हम इसको टाइम 4 तक execute करेंगे because the burst time of P1 will become 3. उस केस में P1 का जो burst time है वो 3 बन जाएगा. Okay? Now you can clearly see there are two processes which are having the same burst time. P0 और P1 का burst time same है. So I'm going to break the tie on the basis of arrival time. So again I will execute P0 till time 5. हम इसको 5 तक ही execute करेंगे. Then the burst time will become 2. Now you can clearly see P1 process is having a higher burst time. अब P1 का burst time ज़्यादा है. Again I am going to execute P1 till time 6. So burst time will again become 2. Then you can see after this that there are three processes which are having the same burst time. I'm going to break the tie on the basis of arrival time. I will execute P0 here till time 7. The burst time will become 1. Then I will execute P1 here till time 8. The burst time will become 1. Then I will execute the P3 process here till time 9. Again the burst time will become 1. Now all of these processes are having burst time as 1. So again I'm going to execute P0 till time 10. Then I will execute P1 till time 11. Then I will execute P2 till time 12, and then I will execute P3 till time 13, right? So what is the completion time? P0 finished at time 10, P1 finished at time 11, P2 finished at time 12, and P3 finished at time 13. So again the number of context switching is maximum in case of longest job first. यहाँ पर जो number of context switch है वो सबसे maximum है. Okay, so I can write it here. Number of context switches are max in longest remaining time first. तो longest remaining time पर जो number of context switch है वो सबसे ज़्यादा होंगे. See what happened in case of longest remaining time first. After every unit of time जो process का जो burst time है वो छोटा हो जाता है because the burst time of the process is decreasing after every unit of time. Therefore you have to switch it. आपको उसको CPU से बाहर निकालना पड़ेगा so that you can place another process in the CPU. Okay, so right now find what is the turnaround time, what is the waiting time in all of these three cases. Turnaround time and waiting time. Here also turnaround time and waiting time. Here also turnaround time and waiting time. So for SJF we are getting the answer as 2.5. For LJF you are getting the answer as 5. For SRTF you are getting the answer as 2.25. And for LRTF the answer is 6.75. तो यहाँ पर average waiting time 6.75 है. So you can clearly see here this LRTF is having the average waiting time which is bigger as compared to all of other algorithms. तो सबसे ज़्यादा यहाँ पर average waiting time increase हो रहा है. As well as the number of context switches are also increasing. So here number of context switches are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. तो यहाँ पर 10 context switch हैं. There are 10 context switches in case of LRTF. In case of SRTF 1, 2, 3, 4. There are 4 context switch. तो यहाँ पर 4 context switches हैं. In case of SJF 1, 2 and 3 there are 3 context switch. तो यहाँ पर 3 context switches हैं. In this case again 1, 2 and 3 there are 3 context switch. So the number of context switches are maximum in case of LRTF. LRTF में जो number of context switches हैं वो सबसे ज़्यादा है. Okay. Now let me take one more example of LRTF. Let me take one more example of longest remaining time first algorithm here. So we have the process IDs, we have the arrival time, and this is the burst time. Now look at it very carefully because you know that this is the most difficult one till now. The arrival times are 0, 0, 0, 0. Let us assume all of these 4 processes arrived at the same time. ये चारों processes एक ही time पर arrive हुई है. Let us assume the burst times are 4, 6, 5 and 7. This is the burst time of these processes. I have taken a very huge burst time here. So obviously this is going to make our question very lengthy. This is your Gantt chart. So at time 0 all of these 4 processes are available. Time 0 पर ये चारों processes available है. So because all of these 4 processes are available, I'm going to execute a process which is having the highest burst time. So highest burst time is with the process P3. I'm going to execute P3 from 0 to 1. Why? 1 at time 1 the burst time of P3 will become 6. अब P3 का जो burst time है वो 6 हो जाएगा, right? Now the burst time of P1 is also 6 and the burst time of P3 is also 6. P3 और P1 दोनों का burst time 6 है. So we are going to break the tie on the basis of arrival time. Because arrival time भी same है, so we are going to break the tie on the basis of process ID. सबसे पहले हम burst time देखेंगे, अगर वो same है तो arrival time देखेंगे, अगर वो भी same है तो हम process ID देखेंगे. So I'm going to execute the process P1 now, again for 1 unit of time, because the burst time of the process with P1 will become 5. अब इसका जो burst time है वो 5 हो जाएगा. Now the biggest process is process P3. अब सबसे बड़ी process P3 है. So I'm going to execute the process P3 again. So for 1 unit of time. So again you can see the burst time process P3 will become 5. Now there are 3 processes which are having the same burst time. 3 processes का burst time same है. So because these 3 processes are having the same burst time, so again I'm going to execute P1. So the burst time will become 4. Then I will execute P2. Then the burst time will become 4 again. Then I will execute the process P3. Then the burst time will become 4 again. Okay. So now all of these 4 processes are having the same burst time. चारों का जो burst time है वो same हो गया है. Because all of these are having the same burst time, so I have to execute them one by one. Because after every unit of time, जो भी process हम execute करेंगे, that will have a lesser burst time. So for example, if I execute P0 here for 1 unit of time, so burst time will become 3, which is less as compared to others. Then I will execute P1. Again the burst time will become 3. Then I will execute P2. Again the burst time will become 3. Then I will execute P3. Again the burst time will become 3. And we have to continue in the same order. Again we have to execute P0, P1, P2 and P3. Right? So burst times will become 2, 2, 2 and 2. Again we have to execute them in the same order. P0, P1, P2 and P3. So burst times will become 1, 1, 1 and 1. Again we have to execute them in the same order. P0, P1, P2 and P3. So then the burst time here will become 0. So if you see the completion time of P0 is 19, P1 is 20, P2 is 21 and P3 is 22. So in this case you can find what is the average turnaround time and what is the average waiting time. The problem is, in case of longest remaining time first algorithm, after certain point of time, जब भी आप एक process को 1 unit of time तक भी execute करेंगे, the burst time will reduce. जो burst time है वो कम हो जाएगा. So that is why the longest remaining time is having the highest average waiting time. It seems like a round robin, बस यहाँ पर round time quantum नहीं है. It just seems like more like a round robin algorithm. So in average waiting time, in terms of average waiting time, the average waiting time of longest remaining time first algorithm will be the highest. Then we'll be having longest time first algorithm. Then we will be having the first come first serve algorithm. Then we will be having the shortest job first algorithm, and the minimum average waiting time is with the shortest remaining time first algorithm. तो shortest remaining time first algorithm का जो average waiting time है वो यहाँ पर सबसे कम होगा. Now out of all these algorithms, the shortest remaining time first, SJF, longest remaining time first and LRTF, they suffer from starvation. Here a process might get start. कोई process जो है वो starve हो सकती है, किसी process को starvation हो सकती है. Now what do you mean by starvation? Starvation means a process has to wait for a very very long time to get the CPU. किसी process को बहुत लंबे time तक wait करना पड़ेगा CPU लेने के लिए. That is called as starvation. There are two conditions. The first condition is your deadlock and the second condition is your starvation. So starvation means it is a long waiting. It is a long waiting to get the resource. And when we see deadlock, deadlock means it is infinite waiting to get the resource. Right? So here CPU is a resource. CPU जो है, CPU is a resource. CPU जो है वो एक resource है. So sometimes it can happen that in a shortest job first or shortest remaining time first or longest job first or longest remaining time first, in all of these four algorithms it can happen that a process has to wait for a very very long time to get the CPU. किसी process को बहुत लंबे time तक wait करना पड़ेगा CPU लेने के लिए. Okay, let me explain you with the help of example. Let us assume that we have the following process IDs. This is the arrival time and this is the burst time. Okay, so the process IDs P0, P1, P2, P3, P4, P5, P6 up to so on till infinity. Every time a new process is getting created and the new process is coming. Arrival times are 0, 1, 2, 3, 4, 5, 6, 7 and so on. And the burst times are 5, 142, 1, 2, 1, 10, 1, 6 and so on. Now here you can see if you execute the shortest job first algorithm on this, यहाँ पर हो क्या रहा है that your system is running, आपका system run हो रहा है, and when your system is running, dynamically new processes are being created. Dynamically new processes are being created. जैसे कि for example you and me, we guys work on the system. Sometimes we open MS Office, sometimes we open Photoshop, sometimes we open a web browser, sometimes we open a movie player. So when we work on the system, so dynamically new and new processes can get created. आपकी जो नई नई process हैं वो create हो सकती हैं. Now what if we have a process which is having a very very high burst time? किसी process का जो burst time है वो बहुत ज़्यादा high है. Then if all the new processes that are coming, इन सभी processes का जो burst time है वो अगर इससे कम है, if all the new processes are having a burst time which is less than this, then you will find that for a long time this process will never get the CPU. This process will never get CPU. इस प्रोसेस को CPU मिलेगा ही नहीं काफ़ी लंबे टाइम तक. सो बिकॉज दिस प्रोसेस विल नेवर गेट द CPU, सो व्हाट विल हैपन इन दैट केस, दिस प्रोसेस विल गो टू अ स्टारवेशन मोड. ये जो प्रोसेस है ये स्टार्व हो जाएगी. इट विल गो टू अ स्टारवेशन मोड. स्टारवेशन का मतलब क्या है, भूखा रहना, है ना. सो व्हेन यू हैव हंगर एंड यू डू नॉट ईट फॉर अ वेरी वेरी लॉन्ग टाइम, राइट, सो दैट इज अ स्टारवेशन. सो इन द सेम वे दिस प्रोसेस P1 is waiting for a very very long time to get the CPU, but because all the new processes that are coming, they are having a burst time which is less than this, so this process will never get the CPU. इस process को कभी CPU नहीं मिलेगा क्योंकि जितनी भी नई process आ रही है उन सभी का burst time इससे कम है. So this process P1 will go to starvation. So all of these algorithms, SJF, SRTF, LJF, LRTF, all of these algorithms will suffer from starvation. ये सभी जो algorithms हैं वो starvation से suffer करती हैं. Now in this session again we are discussing about this process scheduling algorithm and we are continuing with our topic. So I explained you so far that the algorithm which is SJF as well as SRTF, these two algorithms are the best algorithms. Apart of all the algorithms that I explained you so far, अब तक मैंने आपको जितनी भी algorithms explain करी है, out of all those algorithms, this SJF as well as SRTF, both of these two algorithms are the best. ये सबसे best है, correct, because they gives the minimum average waiting time as well as the minimum average turnaround time. You will get the minimum average waiting time and minimum average turnaround time in SRTF or SJF algorithm. These are the best algorithm. But the biggest problem here is that they cannot be implemented practically. इनको हम practically implement नहीं कर सकते. Why we cannot implement practically? Because before executing a process, you cannot tell what will be the burst time taken by the process. जब तक आप किसी प्रोसेस को एग्जीक्यूट ही नहीं करेंगे तो आप कैसे बता सकते हैं कि वो प्रोसेस कितना CPU टाइम लेगा एग्जीक्यूट करने के लिए, राइट? यू कैन नॉट टेल what will be the time taken by the process before even executing the process. That is why these SJF and SRTF algorithms are not practically implementation. They are not practically implementable. They are not practically implementable, even though they are the best algorithms, but still we cannot implement them practically. But as we know, the human nature is, if we say someone that you cannot do it, definitely we will try to do it, right? तो अगर मैं आपको बोलूँगा कि like parents says you cannot have a girlfriend or you cannot have a boyfriend, अगर parents ऐसा बोलते हैं then definitely you are going to have a boyfriend. So your parents must be saying, beta, you cannot have a boyfriend, right? Because you cannot have a boyfriend, so what you do, you try to make a boyfriend, right? So it is a human nature. Whatever we say that you cannot do, we will try to do that only. तो हम वही चीज़ करने की कोशिश करते हैं. So here in the same way, in this case, we try to implement SJF and SRTF algorithm. We told that because you cannot predict the burst time, but still we try to find a method that using those methods you can try and you will try to predict the burst time. हम कुछ methods को identify करने की कोशिश करेंगे जिससे आप burst time को predict कर सकें. So it is burst time prediction techniques. Burst time prediction techniques. How will you predict the burst time of a process? So there are two types of techniques that we have implemented, or we have tried to identify. There are two kinds of techniques. The first technique is your static technique and second technique is your dynamic technique, right? So static technique means here the predicted burst time will not change, so you are going to do some predictions and that predicted burst time will always remain the same. So in case of static technique, you have again two methods. The first one is you can predict the burst time of the process based on the process size. आप किसी प्रोसेस के साइज़ के बेसिस पर बर्स्ट टाइम को प्रेडिक्ट करने की कोशिश करेंगे, और यू कैन ट्राई टू प्रेडिक्ट द बर्स्ट टाइम ऑफ अ प्रोसेस बेस्ड ऑन द प्रोसेस टाइप, कि वो किस तरह की प्रोसेस है उसके बेसिस पे आप बर्स्ट टाइम प्रेडिक्ट करने की कोशिश करेंगे. सो व्हाट यू विल बी डूइंग इज यू आर गोइंग टू मेंटेन अ डेटाबेस. आप एक डेटाबेस को मेंटेन करेंगे. So whatever processes you have executed so far, let us assume that you have executed 1000 processes so far. So based on those 1000 processes, you will try to see that if the size of a process is, let us suppose, 50 KB, that means the burst time of the process should be somewhere 64 units, right? So you will maintain a database. According to the database, if you have a new process and the size of new process is, let us assume, 51 KB, then you will identify what is the value in my database, what is the size in my database which is very close to this current size. इस size का सबसे close match कौन सा है, and accordingly we will find out that currently in my database we have a size which is 50 KB and the burst time is 64 units. So I will predict or assume that the size of the new process is, so the burst time of the new process is going to be 64 यूनिट्स ओनली. जो नई प्रोसेस है उसका बर्स्ट टाइम भी 64 यूनिट्स ही होगा. ओके, सो दिस इज़ द फर्स्ट टेक्निक. द सेकेंड टेक्निक इज़ बेस्ड ऑन द प्रोसेस टाइप, की प्रोसेस किस तरीके की है. सो अगेन द प्रोसेसेस कैन बी ऑफ डिफरेंट टाइप. द प्रोसेस कैन बी अ सिस्टम प्रोसेस, इट कैन बी अ सिस्टम प्रोसेस, और द प्रोसेस कैन बी अ यूज़र प्रोसेस. प्रोसेस जो है वो एक सिस्टम प्रोसेस भी हो सकती है और प्रोसेस जो है वो आपकी यूज़र प्रोसेस भी हो सकती है. सो इफ़ योर प्रोसेस इज़ अ सिस्टम प्रोसेस, सो दैट मीन्स विच आर क्रिएटेड बाय योर ऑपरेटिंग सिस्टम्स, सो द टाइम टेकन विल बी 3 to 5 units. correct? We are going to assume if it is a system process, then the time taken by these system processes are on average 3 to 5 units. Again, if it is a user process, so for this user process we have to identify that whether it is an interactive process or whether it is a foreground process और वेदर इट इज़ अ बैकग्राउंड प्रोसेस. वो किस तरह की यूज़र प्रोसेस है, क्या वो एक फोरग्राउंड प्रोसेस है, क्या वो इंटरेक्टिव प्रोसेस है, क्या वो बैकग्राउंड प्रोसेस है. एंड हाउ विल आई गेट दीज वैल्यूज़, ये वैल्यूज़ मुझे कैसे मिलेगी. आई एम गोइंग टू गेट दीज वैल्यूज़ फ्रॉम माई डेटाबेस. तो जो भी हम डेटाबेस मेंटेन करेंगे, इन दैट डेटाबेस वी विल ट्राई टू फाइंड द एवरेज दैट इफ़ वी गेट अ इंटरेक्टिव प्रोसेस देन व्हाट इज़ द एवरेज बर्स्ट टाइम वी गेट. If we have a user process which is a foreground process, then what is the average burst time we get. If we have a user process which is a background process, then what is the average burst time we will get. For interactive processes, the burst time is 5 to 8 units. This is just an average, right? So do not stick to these values because these values can change in your examination. They can give you some different values also. So I'm just taking these as an example. I'm just telling you this is an example that if you have an interactive process, then for example interactive process might take 5 to 8 units of time, foreground process can take 10 to 15 units of time, and the background processes might be taking 15 to 20 units of time. These are just example of the time that a process might take these kind of times. Okay. So user process means the processes which are created by the user, जो हम लोग क्रिएट करते हैं. वी कैन स्टार्ट द प्रोसेस बाय ओन. मे बी यू आर स्टार्टिंग अ गेम, मे बी यू आर स्टार्टिंग MS Word Office, मे बी यू आर स्टार्टिंग अ वेब ब्राउजर, वट काइंड ऑफ इट इज़, और मे बी यू आर स्टार्टिंग अ टॉरेंट. You might be starting a torrent file, you might be starting a file copy operation, right? So all of these operations are going to create a process. So this torrent runs on the background, and we already know that these background processes that we run, they run for a very very long time. तो उसको हम काफ़ी लंबे टाइम तक रन करते हैं. Okay. Now in the same way we have some dynamic techniques. So there are two major dynamic techniques that we have. The first one is your simple averaging, and second dynamic technique is your exponential averaging. So we have a simple averaging as well as exponential averaging. Simple averaging means whatever processes came so far, you are going to maintain a database and you are going to maintain what is the burst time of all the processes that arrived so far. Then you will take an average of all those processes. You will take the burst time of all those processes and then you will take an average of this. So maybe you have executed till n processes. अगर अब तक आपने n process को execute किया है, so what you are going to do is you are going to add the burst time of the first process plus burst time of the second process plus burst time of the third process up to so on burst time of the n processes, and you are going to divide it by n. So which is equivalent to the burst time of the new process will be equal to summation I is equal to 1 to n t of I divided by n. You will try to find the average of all the burst time that you have received so far. अब तक आपके पास जितने भी burst time आए हैं हम सबका average लेंगे, and then you can use this average to find the burst time of the new process. जो भी new process आप create करेंगे उसका burst time इस average के basis पे find out कर सकते हैं. That is your simple averaging procedure. Correct? And the last procedure is your exponential averaging. Last आपका exponential averaging है. So in this case we use something called as a smoothing factor. तो हम यहाँ पर smoothing factor को use करते हैं. So what is the formula that we use here is burst time of a new process will be equal to alpha burst time of the previous process plus 1 minus alpha burst time that you have predicted for the previous process. So here alpha is a smoothing factor. Alpha जो है वो यहाँ पर smoothing factor है. Let me explain the exponential averaging first, because I believe all of others are very simple. Based on process, static prediction is very easy, but in case of dynamic prediction, simple averaging is also easy. Only this exponential averaging is little complicated, or you can say little tricky. Let me explain you what does exponential averaging mean. Exponential averaging. Exponential averaging. Okay. So what is the formula for exponential averaging? It is burst time of the new process, which is t of n plus 1. Generally we represent it by t. In some books you might also see that they are using tau instead of t. They might be using tau, I think the symbol of tau something like this, tau n plus 1 is equal to alpha tn plus 1 minus alpha into tau n. So where tau is representing the predicted burst time. टाउ जो है यहाँ पर प्रिडिक्टेड बर्स्ट टाइम को रिप्रेजेंट कर रहा है. टाउ इज रिप्रेजेंटिंग अ प्रिडिक्टेड बर्स्ट टाइम. सो हियर देयर आर टू इंपॉर्टेंट क्वेश्चंस. आपके सबसे इंपॉर्टेंट जो क्वेश्चंस है, फर्स्ट ऑफ ऑल यू आर आस्किंग मी सर व्हाट इज दिस स्मूथनिंग फैक्टर. ये स्मूथनिंग फैक्टर क्या है, व्हाट इज दिस टी एन एंड व्हाट इज दिस टाउ एन. सो हियर टी एन इज रिप्रेजेंटिंग द एक्चुअल बर्स्ट टाइम एंड दिस टाउ एन इज रिप्रेजेंटिंग द प्रिडिक्टेड बर्स्ट टाइम. जो टाउ है वो एक प्रिडिक्टेड बर्स्ट टाइम को रिप्रेजेंट करता है, प्रिडिक्टेड बर्स्ट टाइम. एंड व्हाट इज दिस अल्फा. अल्फा इज स्मूथनिंग फैक्टर. तो स्मूथनिंग फैक्टर का काम क्या है, देखो दिस इज योर ग्राफ. तो लेट अस अज्यूम दैट यू हैव फाइंड आउट दैट योर बर्स्ट टाइम विल बी दिस मच. आपका बर्स्ट टाइम ये है जो आपने प्रिडिक्ट किया है, and this is your actual burst time. This is t of n. This is the actual burst time and this is the predicted burst time. So there is a difference between the prediction and there is a difference between the actual. तो predicted burst time और actual burst time में difference है. So what you try to do is you try to take a middle value. तो यहाँ से आप एक middle value को find out करने की कोशिश करते हैं. This is a middle value, right? सो वट यू डू इज़ यू स्मूदन बोथ ऑफ दीज वैल्यूज़. जो आपने प्रिडिक्ट किया था और जो एक्चुअल में रिसीव हुआ है, उन दोनों को स्मूथ करके यू वांट टू फाइंड अ यूनिक वैल्यू. आप एक ही वैल्यू को फाइंड आउट करना चाहते हैं. फॉर दैट पर्पस आई यूज़ अल्फ़ा. तो उसके लिए हम लोग अल्फ़ा का यूज़ करते हैं. ओके, सो लेट मी रिपीट अगेन. व्हाट आई एम ट्राइंग टू से इज़ कि आप कुछ प्रिडिक्शंस करेंगे, यू विल प्रिडिक्ट सम बर्स्ट टाइम और आपके पास कुछ एक्चुअल बर्स्ट टाइम आया होगा. देन यू विल ट्राई टू आइडेंटिफाई कि जो मैंने प्रिडिक्शंस की थी और जो मेरे पास एक्चुअल आया है उसमें कितना डिफरेंस है. सो आई विल ट्राई टू टेक अ मिडल वैल्यू ऑफ दैट, राइट. जैसे इफ़ यू गो टू अ शॉपकीपर, द शॉपकीपर सेज दैट एप्पल आर 100 रुपीज़ kg एंड यू से नो आई विल बाय द एप्पल्स एट 50 रुपीज़ kg. देन यू डू बार्गेनिंग विद द शॉपकीपर एंड यू बोथ एग्री एट 75 रुपीज़ kg. आप 75 रुपीज़ kg में settle down होते हैं. So you can assume that your actual burst time is 100 rupees and your predicted burst time was 50 rupees, but then you take a smoothing factor, you take a tau value so that you settle down at 75 rupees. तो आप उसको इस तरीके से imagine कर सकते हैं. Let me explain you with the help of an example. ठीक है. So I'm taking a very good example here. Example is as follows, that calculate the predicted burst time using exponential averaging for the fifth process if the predicted burst time for the process is 10 units. Just let me check. For the first process, the predicted burst time for the first process is 10 units and actual burst time for first 4 processes is 4, 8, 6, 7 units. Given that smoothing factor alpha is 0.5. तो यहाँ पर आपकी जो अल्फ़ा की वैल्यू है वो 0.5 है. Okay, let me explain the question again. In this question they are saying that the actual burst time of first 4 processes are 4, 8, 6 and 10. ये आपका actual burst time है. और जो आपने फर्स्ट प्रोसेस का बर्स्ट टाइम प्रिडिक्ट किया था वो 10 यूनिट्स है. पहली प्रोसेस का बर्स्ट टाइम 10 यूनिट्स है और पहली 4 प्रोसेसेस का जो एक्चुअल बर्स्ट टाइम है वो 4, 8, 6 एंड 7 है. देन यू हैव टू प्रिडिक्ट व्हाट इज़ द बर्स्ट टाइम ऑफ द फिफ्थ प्रोसेस. फिफ्थ प्रोसेस का बर्स्ट टाइम क्या रहेगा. ओके, So what values we have? We know that the actual burst time of the first process is 4 and the predicted burst time for the first process is 10. Now we can find what is the predicted burst time for the second process. You can find tau 2 will be equal to alpha t1 plus 1 minus alpha tau 1. तो आप second prediction को use करेंगे from the previous prediction. This is how you are going to find these values. So this is going to be 0.5 into t1 is 4 plus 0.5 into tau 1 is 10. So the value you will get is 2 plus 5 is 7. That means the burst time of the second process, जो आप second process का burst time predict करेंगे, the prediction for the second process is 7 units, but the actual burst time for the second process is 8, right? So that is tau 3. हम tau 3 find out करेंगे. That is a prediction for the third process. That is alpha actual burst time of the second process plus 1 minus alpha predicted burst time for the second process. So tau 3 is going to be 0.5 into 7 plus 0.5 into so actual burst time here is 8 into 7. So that is going to be 4 plus 3.5, which is 7.5. Now we get tau 4. That means our fourth process का जो burst time क्या predict करेंगे? So tau 4 will be alpha t3 plus 1 minus alpha tau 3. So alpha is 0.5 and t3 here is 6 plus 1 minus alpha, which is 1 minus 0.5 and tau 3 is 7.5. So actual जो है वो 6 units था, prediction आपकी 7.5 थी. So the value is 3 plus 3.75, so which is going to be 6.75. So prediction for the first process is 6.75, but the actual burst time for the fourth process is 7. So I can find what is the prediction for the fifth process. That is alpha t4 plus 1 minus alpha tau 4. So alpha is 0.5. The actual burst time for the fourth process is 7 plus 0.5 in the actual burst time. Predicted burst time for the fourth process is 6.75. So if you calculate this value here, this value is going to be 3.5 plus 3.375, and this entire value is going to be 6.875. So you will say जो भी आपकी fifth process आएगी, the next fifth process will be having a predicted burst time of 6.875. जो new process आएगी उसका predicted burst time 6.875 के equal होगा. In this way you can do predictions for burst time. इस तरीके से आप burst time के basis पर predictions कर सकते हैं. So the next algorithm is your priority based scheduling algorithm. Priority based scheduling algorithm. Okay. So in case of priority based scheduling algorithm, you are going to assign priority to each of these processes. आप हर एक process को कुछ priorities assign करेंगे. Okay. And according to the priorities, we are going to see which process we have to execute. Okay. And this priority based scheduling algorithm, it can be implemented in a non-preemptive fashion, as well as it can also be implemented in terms of preemptive fashion. तो यहाँ पर नॉन प्रेम्प्टिव भी हो सकती है और प्रेम्प्टिव भी हो सकती है. So let me take an example. This is representing the process ID, this is representing the arrival time, and this is representing the burst time. Process IDs are P0, P1, P2 and P3. Let us assume the arrival time of each of these processes are 0, 0, 0, 0, 0. For simplicity purpose, I am assuming their arrival time like this, or let me take some arrival time. Let me not make the question easy for you. So 0, 1, 2, 3 and 4. The burst time of these processes are 4, 1, 2, 6 and 5. And then again we have something called as priority. What is the priority of each of these processes? Some priority will be assigned, maybe 1, 2, 5, 3 and 4. Here they will be telling what is the least priority and what is the maximum priority. Let us assume 1 is representing low priority and 5 is representing high priority. Okay. अगर आप जावा पढ़ेंगे, if you study Java, in case of Java you have threads and you can assign priorities to the threads. So you can assign the priority from 1 to 10, जावा में आप थ्रेड्स को 1 से लेकर 10 के बीच में प्रायोरिटीज असाइन कर सकते हैं, वेयर 1 इज रिप्रेजेंटिंग अ लो प्रायोरिटी एंड 10 इज रिप्रेजेंटिंग हाई प्रायोरिटी. एंड इफ़ वी से द प्रायोरिटी इज़ 5, दैट मीन्स इट इज़ अ नॉर्मल प्रायोरिटी. 5 जो है वो एक नॉर्मल प्रायोरिटी को रिप्रेजेंट करता है. सो इन योर जावा प्रोग्रामिंग लैंग्वेज you can assign priorities to the processes. In the same way, when you work on Windows, जैसे अब for example I'm working on Windows or any of the operating systems, I can assign priority to each of these processes. So here you can see we have many processes. I can go to details, I can see the process name, I can see the process ID, I can see whether the process is running or not, right? So I can see all of this information. I can go to any process, I can do a right click and I can set the priority of the process. I can say the priority of the process is above normal, the priority of the process is normal, the priority of the process is below normal or low. In this way, I can set the priority of a process in this details section. तो विंडोज़ के अंदर भी यू कैन असाइन प्रायोरिटी ऑफ अ प्रोसेस एज वेल एज इफ़ यू हैव अ प्रोग्रामिंग लैंग्वेज देयर ऑल्सो यू कैन असाइन प्रायोरिटी ऑफ अ प्रोसेस. तो दोनों जगह पर आप किसी प्रोसेस की प्रायोरिटी को असाइन कर सकते हैं. फाइन. सो हियर आई एम सेइंग इफ आई हैव अ प्रायोरिटी एज 1, दैट मीन्स इट इज रिप्रेजेंटिंग अ लो प्रायोरिटी. इफ आई हैव अ प्रायोरिटी एज 5, इट इज रिप्रेजेंटिंग अ हाई प्रायोरिटी. आई विल टेक द सेम एग्जांपल इन प्रीएम्प्टिव फैशन ऑल्सो. This is process ID, this is the arrival time, this is the burst time, and this is the priority. So process ID is again 0, 1, 2, 3 and 4. The arrival times are 0, 1, 2, 3 and 4. The burst times are 4, 1, 2, 6 and 5. The priorities are 1, 2, 5, 3 and 4. 5 is representing high priority and 1 is representing low priority. So when you are going to execute this process in your system, so you will be assigning these process to the CPU on the basis of priority. जिसकी priority सबसे ज़्यादा है आप उसको CPU के अंदर assign करेंगे. Okay. So in the first example you can see at time 0 only one process is available. Time 0 पर सिर्फ एक ही process आई है, इसके अलावा कोई और process आई नहीं है. So we are only going to execute the process P0. We'll execute the process P0 from time 0 to 4. अब टाइम 4 पर ऑल ऑफ दीज प्रोसेसेस हैव अराइव्ड. ये सभी प्रोसेसेस आ चुकी है. नाउ आई एम गोइंग टू एग्जीक्यूट द प्रोसेसेस ऑन द बेसिस ऑफ प्रायोरिटी. सो द प्रोसेस P2 इज हैविंग द हाईएस्ट प्रायोरिटी. इट विल फिनिश एट टाइम 6. Process P3, then we'll execute the process P4, second highest priority. This will finish at time 11. Then we will execute the process P3, it will finish at time 17, and then we will execute the process P1, it will finish at time 18. So on the basis of priority, I can assign the order in which the processes are being executed. Process किस order में execute होगी उसके लिए हम priority को assign करेंगे. Now when we discuss about preemptive में क्या होगा? So at time 0 only one process available, which is process P0. So process P0 will execute from time 0 to 1. Why? Because at time 1 एक new process आ रही है and this new process is having a higher priority as compared to process P0. जो process P1 है उसकी priority P0 से ज़्यादा है. So I'm going to take P0 out of the CPU and I will assign process P1 in the CPU for again one more unit of time. So process P1 will be finished. Process P1 आपकी finish हो जाएगी. Now at time 2 we have a process P2 which is having the highest priority as compared to any other process. P2 की priority सभी processes से ज़्यादा है. So I'm going to execute the process P2 here and the process P2 will execute till 4 units of time. Then this will be finished and then till time 4 all the other processes are arrived. So I'm going to execute the process P4 here till time 9. Then I'm going to execute the process P3 here till time 15. Then I will execute the process P0 here till time 18. So again you can see the completion time of these processes are changing. So in case of preemptive priority based, again according to the priority of the process we will assign the process to the CPU. तो हम किसी प्रोसेस की प्रायोरिटी के अकॉर्डिंग हम उस प्रोसेस को CPU के अंदर असाइन कर सकते हैं. Good. If this everything was easy, let me give something very complicated to you. I'll give you a very complicated example. So all of you know that if a process is currently doing input output, then another process can do CPU at the same time, right? So I've shown you the process state diagram. If you remember the process state diagram, अगर आपको process state diagram याद हो, so what I've done in the process state diagram, I told you that we have a new process, then we take the process to a ready state, and from here the process go for execution. Then we have a transition here, it representing preemption. Then the process might go to a waiting state or a blocked state. Again it can come to the ready state, or the process can go to a suspended state, or it can go to a suspend ready state. From here the process can go to ready state, and from execution the process can go to termination. तो यहाँ से जो process है वो termination पर जा सकती है. Okay. Now in this entire process state diagram, I told you that execution, if a process is executing at the same time, there can be more than one processes which are doing input output. आपके पास वेटिंग स्टेट पर एक से ज़्यादा प्रोसेसेस हो सकती है जब कोई एग्जीक्यूट कर रही है. दैट मीन्स देयर कैन बी मोर देन वन प्रोसेसेस विच आर परफॉर्मिंग IO at the same time as compared to, I mean, as if one process is executing in the CPU, then more than one processes can also do input output parallelly. On the basis of this, I can create questions. इसके basis पे मैं कुछ questions को create कर सकता हूँ. Okay. So from suspended state, that is more like a forced close, right? Because there is no point of terminate a process from a suspended state, because in a suspended state the process is doing IO, right? So even if the process has completed its IO, so again you have your CPU has to verify that the IO is done. तो CPU को verify करना पड़ेगा कि input output हो चुका है. Okay. So again let me explain more here. So here I'm taking two very good examples, and which algorithm should I choose? Let me choose the shortest job first. For simplicity purpose, I'm using shortest job first algorithm here. So here this is the first example. This is the process ID. This is the arrival time. Now here I'm saying that every process requires the CPU time. Then the process requires the input output time. Again the process requires the CPU time, right? So this is CPU and this is CPU. So here I'm telling you कि a process can be having multiple demands. Process को कभी CPU time चाहिए हो सकता है, कभी IO time हो सकता है. So they can have demands like this. Okay. So this is the process IDs P0, P1, P2 and P3. Arrival times are 0, 1, 2 and 3. The burst times are 4, 2, 6 and maybe 1. IO time here is 5, 5, 2 and 1. Burst times again here is 1, or maybe we'll make it 2, 5, 3 and let us say it is 6. Okay, this is the first example, and this is the second example here. This is representing the process ID. This is the arrival time. Now in the second example, every process is going to perform an input output, then the process is going to perform CPU, and then the process is going to perform input output. This is the process ID. This is the arrival time, and this is the burst IO times here 5, 5, 2, 3, 4, 1, 6, maybe 2, and here it is 1, 4, 3 and 2. So these are two questions. तो इन क्वेश्चन को थोड़ा सा ध्यान से समझिएगा, because these questions are little complicated. You might feel there are some complications in this case. ठीक है, तो थोड़ा इसको ध्यान से समझिएगा. Please focus here because it is very very important. These questions are little complicated, so focus here. Okay. In the first case, what we are trying to say is every process is going to perform CPU. हर एक process सबसे पहले CPU के अंदर execute होगी. After this, the process is going to perform input output, and after this, the process is going to perform CPU. When the process finished all these three times, जब भी कोई process ये तीनों time को finish करेगी, then only we can say the process is finished. Otherwise, the process is not finished. So for a process to finish, all these three times should be done. Okay. Now here in the first case, So at time 0 only one process is available. So because there is shortage of first, so time 0 पर सिर्फ एक ही process available है. I'm going to execute process P0 from time 0 to 4. तो process P0 है finish हो जाएगी. After this, all the remaining processes, I have to execute a process which is having the shortest burst time. अब देखो, as soon as the P0 process will finish, it will go for IO. P0 process जैसे ही finish होगी वो IO में जाएगी, and parallelly at the same time I can also execute a process in the CPU. For example, after P0 I can execute the process P3 from 4 to 5, but at the same time, exactly at the same time, the P0 process will perform 1 unit of input output. P0 process जो है वो 1 unit of input output कर सकती है. Then again we are going to execute the process P1. So P1 is going to take 2 units of time. So P1 will finish at time 7. But at the same time, parallelly, both P0 and P3 will be doing IO. So P0 ने 2 units of IO finish करेगा and P3 will also finish its IO. P3 जो है वो भी अपना input output finish कर लेगा. Okay. Now this is also done. Now you can see how many processes are available to execute. अब आपके पास 2 processes available है. You have a process P2 जिसको CPU चाहिए, as well as you have a process P3 जिसको CPU चाहिए. Now these 2 processes are available for the CPU at the same time. Both P2 and P3 are having the same CPU burst. दोनों का CPU time जो है वो same है. So I'm going to execute P2 now. So I will execute the process P2 here from time 7 to 13. Right? At the same time, this process will finish its IO, this process will finish its IO. Okay, and now you can see P2 process can go for IO from here. Right, अब जो process अपना input output finish कर चुकी है, these processes are available to execute on CPU. So we have process P0, P1 and P3, they are available to execute on CPU. Now I will execute the process P0 here from 13 to 15. At the same time, P2 will also finish the input output. So basically क्या हो रहा है कि whenever a process is executing in the CPU, parallelly more than one process will perform its input output. एक से ज़्यादा processes अपना input output perform कर सकती है. Now this is also finished. Now I'm going to execute the process P2 from 15 to 18. This is also finished. Then I will execute the process P1 from 18 to 23. This is also finished. Now I will execute the process P3 from 23 to 29. Now this is also finished. So what is the completion time here? The completion time for process P0 is 15. Process P1 is 23. Process P2 is 18 and process P3 is 29. This is the completion time for each of these process in the first case. ठीक है. Let me explain the second example. जिसको first example समझ में नहीं आया, those who could not understand the first example, please focus on second example because second example here is important. Okay. Now you can see at time 0 when we started the system, only P0 process was available. But you are seeing that P0 process, look at it carefully, follow through it through my lecture, then you will understand it here. So at time 0 only P0 process is available, right? So because only P0 process is available, but before performing a CPU, these processes have to perform input output. CPU perform करने से पहले सभी processes को input output perform करना है. Okay, so from time 0 to time 1 nothing will be done because no process is available for execution. At that time P0 process will perform its input output. तो P0 process जो है 1 unit of input output perform कर लेगा. अब time 1 पर एक और process available है which is P1. So we will execute from time 1 to time 2. Again the system will remain idle because उस time पर P1 और P0 both of them are performing input output. दोनों जो processes हैं वो input output perform कर रही है. Okay. Now at time 2 these 3 processes are available, but all these 3 processes have to perform input output. So time 2 से लेकर time 3 तक, from time 2 to 3 these 3 processes will perform input output. P0 will finish 1 unit of input output, P1 will finish 1 unit of input output, and P2 will also finish 1 unit of input output. Now at time 3 P3 process arrived. So time 3 से लेकर 4 तक all these 4 processes will perform input output. So the input output for P0 will become 1, input output for P1 will become 2, input output for P2 will become 0, and input output for P3 will become 2. So now you can clearly see what is the IO time here, right? So time 0 से लेकर 4 तक, between 0 and 4 all of these processes, some of these processes are performed input output, only P2 process is able to finish its IO. सिर्फ P2 process का ही input output finish हो पाया है 0 से लेकर 4 तक. Otherwise P1 still have to do IO, P0 still have to do IO, and P3 still have to do IO. Now because only one process is available for CPU, so I will execute the process P2 now for 6 units of time, that is from 4 to 10. Meanwhile all the other processes will also finish their IO. P0 will finish their IO, P1 will finish its IO, P3 will also finish its IO. तो P0, P1 और P3 जो है वो अपना इनपुट आउटपुट फिनिश कर लेंगे. ओके, नाउ ऑल द अदर प्रोसेसेस आर अवेलेबल फॉर एग्जीक्यूशन. बाकी सभी प्रोसेस अब जो है वो एग्जीक्यूशन के लिए अवेलेबल है. नाउ वी विल एग्जीक्यूट देम ऑन द बेसिस ऑफ देयर प्रायोरिटीज, I mean their CPU time. So now we will execute P1, so it will finish at time 11, right? So meanwhile this P2 process will finish its IO at time, so 2 units of time is still remaining. Okay, now you can see after this we will execute the P3 process from 11 to 13. अब P3 जब हम execute करेंगे, meanwhile P1 finished 1 unit of IO and P2 also finished 1 unit of IO. P1 और P2 ने 1 unit of IO finish कर लिया है. Okay, now when P3 is finished, so I will execute the process P0 here till 17. Meanwhile this process finished at IO, इसका भी IO finish हो जाएगा और इसका भी IO finish हो जाएगा. Okay, so when this P0 process finished इस CPU टाइम, जैसे ही P0 का फिनिश हुआ CPU टाइम, उसके बाद स्टिल फॉर 1 unit of टाइम द CPU विल रिमेन आइडल, बिकॉज फॉर दैट 1 unit of टाइम P0 विल डू इट्स IO. P0 जो है वो अपना IO फिनिश करेगा. सो ऑल दिस प्रोसेसेस हियर दे विल फिनिश एट टाइम 18. तो टाइम 18 पर सभी प्रोसेस फिनिश करेंगी. इन दिस टोटल टाइम द 4 units of टाइम CPU was idle and this 1 unit of time CPU was idle. So out of 18 time units, out of 18 total 5 units of time CPU was idle. 5 unit of time तक CPU जो है वो idle रहेगा. Okay, clear? So I believe you guys have not understood this. आप सबको अच्छे से समझ में नहीं आया है. I will take more examples, but just make sure that whenever a process is doing its IO, जब भी कोई process अपना input output perform कर रही है, at the same time other processes parallelly also can perform, I mean if one process is performing CPU, other processes can parallelly perform IO. तो अगर कोई process CPU को perform कर रही है तो बाकी processes parallelly IO perform कर सकती है. Okay, so let me explain you with the help of a previous year question here. Read this question here. So this question is based on priority. Okay, first you try this question, then I will solve this question in the session. ठीक है, पहले आप इस क्वेश्चन को ट्राई कीजिए. This question is again based on priority. First you try it, then I will solve it. So let us try and solve it. I believe you have tried it. अब मेरा टाइम है इसको सॉल्व करने का. You must have read the question clearly. So the arrival time, priority and duration of CPU and IO burst for each of the 3 processes P1, P2 and P3 are given in the table below. Each process has a CPU burst followed by an IO burst followed by another CPU burst. Assume that each process has its own IO resource. The multi-programmed operating system uses preemptive priority scheduling. What are the finish times of the process P1, P2 and P3? अगर हमारे पास preemptive priority scheduling है तो P1, P2 और P3 processes finish कब होगी? Okay, so let us make the Gantt chart here. So this is the process at time 0. Only one process is available. Time 0 पर सिर्फ एक ही process available है which is having a priority 2. So this process P1 will execute from time 0 to 1. At that time the burst time of the process will become 0. उस समय पर process का जो burst time है वो 0 हो जाएगा. Now we have a process P2, correct? So which is having the lowest priority. P2 की जो priority है वो सबसे low है. So I'm going to execute the process P2 here from 1 to 2. That time the burst time of the P2 will become 2, and meanwhile P1 process will perform 1 यूनिट ऑफ IO. P1 प्रोसेस जो है वो 1 यूनिट ऑफ IO परफॉर्म कर लेगा. आफ्टर दिस एट टाइम 2, I think I've also done some mistake. Let me solve it again. I've done some mistake here. So here in this case, at time 0, only P1 process is available. So I will execute P1 from 0 to 1, and thus burst duration of the process P1 will be 0. Okay. देन फ्रॉम 1 to 2, 1 से लेकर 2 टाइम तक कोई भी प्रोसेस अवेलेबल नहीं है. सो ड्यूरिंग दैट टाइम P1 प्रोसेस विल परफॉर्म 1 यूनिट ऑफ IO. 1 से लेकर 2 तक कोई भी प्रोसेस अवेलेबल नहीं थी. नाउ एट टाइम 2 प्रोसेस P2 अराइव्ड. अब P2 सिस्टम में अराइव हो गई है. सो विल एग्जीक्यूट P2 फॉर 1 यूनिट ऑफ टाइम. द CPU टाइम ऑफ P2 विल बिकम 2 and the IO time of P1 will become 3. Now we have a highest priority process, so I will execute the process P3 here till time 5 because it is having the highest priority. So the burst time of P3 will become 0. Meanwhile P1 will also finish 2 units of IO. P1 जो है वो अपना 2 यूनिट ऑफ IO फिनिश कर लेगा. Okay. After this I will execute the process P2 again for 1 यूनिट ऑफ टाइम. तो हम P2 को 1 यूनिट ऑफ टाइम एग्जीक्यूट करेंगे. सो P2 विल एग्जीक्यूट टिल 6 यूनिट ऑफ टाइम. दिस बर्स्ट टाइम विल बिकम 1, बट एट द सेम टाइम दिस P3 process will do 1 unit of IO as well as P1 process will also do 1 unit of IO. So you can clearly see at time 6 P2 needs a CPU as well as P1 also needs a CPU. I think this will become 2. Right, so P2 needs a CPU as well as P1 also needs a CPU. Okay, clear है? Fine. So after this, because P1 is having higher priority as compared to P2. P1 की जो priority है वो P2 से ज़्यादा है. So I will execute P1 now. I will take P2 out of the CPU. I will execute P1 for another 2 units of time. अब हम P1 को एग्जीक्यूट करेंगे 2 यूनिट ऑफ टाइम तक. Meanwhile this will perform its this will do 2 units of CPU and this will also complete its IO. अब P3 भी अपना IO फिनिश कर लेगा. Now we have P1, P2 and P3 तीनों प्रोसेसेस को CPU चाहिए, but P3 is having the highest priority. I will execute P3 again till 1 unit of time. Then I will execute P1 again till again 1 unit of time. Then I will execute P2 here. I will execute P2 again till 1 unit of time. This will finish, and now P2 has to go for IO. अब जो P2 है वो IO के लिए जाएगा for 3 units of time. It will finish at 14, and then after this P2 will go for CPU time for 1 unit of time. तो P2 जो है दोबारा से CPU टाइम के लिए जाएगा. Okay, so you can see CPU will remain idle between 1 to 2 and CPU will remain idle between 11 to 14. So in total the process P1 will finish at time 10, the process P2 will finish at time 15, and the process P3 here we will finish at time 9. So this is the finish time of each of these processes. The correct answer is option number B. ठीक है. See what happened during 11. At time 11 process P2 finished its CPU time. उसके बाद process P2 को अपना IO perform करना है. Then process P2 has to perform IO. Okay, so this is the IO time that P2 process is doing. But during this time P2 process is doing its IO. Again after this, when P2 will finish its IO, it will take the CPU time. This is the CPU time of P2 process in this case. So by this you can identify what is the finish time of each of these processes. The correct answer will be option number B in this case. Okay, don't worry if you do not understand. I have more examples here. Please try and solve this question here. आप इसको solve कीजिए. Take 5 minutes. So I believe all of you have read the question and you understood what they are trying to say in the question. आप सभी को समझ में आया होगा कि वो क्वेश्चन में क्या कहना चाहते हैं. So I believe right. So we can try and solve this here. Let me explain this here also. Consider 3 processes all arriving at time 0. आपके पास 3 process है. You have a process P1, you have a process P2 and you have a process P3. And the arrival time of these 3 processes are 0. The total execution time is 10, 20 and 30 units. तो हर एक process का जो total execution time है वो 10, 20 और 30 units है. Each process spends first 20% of the time during execution during IO. तो पहले 20% टाइम हर एक प्रोसेस IO परफॉर्म करेगी. नेक्स्ट 70% ऑफ द टाइम हर एक प्रोसेस CPU यानी कंप्यूटेशन परफॉर्म करेगी. एंड द लास्ट 10% ऑफ द टाइम एवरी प्रोसेस विल परफॉर्म IO. So that means every process will do IO first, then the process will do CPU and then the process will do IO. So that means for the first process the total time is 10. So first process will do 2 units of IO, 7 units of CPU and 1 unit of IO. The second process will do 4 units of IO, 14 units of CPU and 2 units of IO. Third process will do 6 units of IO, 21 units of CPU and here 3 units of IO. Right, so this is the total time that they are giving. Right, so you can clearly see the total execution time here. For P1 process the total execution time is 10. For P2 process the total execution time is 20 and for P3 process the total execution time is 30. So this is what they are trying to specify. Okay, so that is 20% here, 70% here and 10% here. And now they are telling that the operating system uses shortest remaining computation time first. So because they are already giving that they are using SRTF algorithm, it means it is SJF plus preemption. So shortest remaining computation time first means SJF plus preemption. Schedules a new process either when the running process gets blocked or on IO or when the process finishes its compute burst. Okay. Now assuming that all the IO operations can be overlapped as much as possible, what is the percentage of time the CPU does not the CPU remains idle? कितने percentage of time तक CPU idle रहेगा? Okay, so let us do this. At time 0 कोई भी process available नहीं है. No process is available for execution at time 0. Every process will do IO for the first 2 units of time. Right, it will finish its 2 units of IO, it will finish its 2 units of IO, it will also finish its 2 units of IO. Okay, see they are already mentioning shortest remaining compute time first, that is SRTF algorithm. Obviously it is SJF plus preemption, so SJF plus preemption होगा. Okay, so now in this case when every process done 2 units of IO, now only P1 process is available to perform CPU. अब P1 process ही CPU perform करने के लिए available है. So because only P1 process is available to perform CPU and P1 is the shortest process, P1 सबसे smallest process है, so I'm going to execute the P1 process. It is from 2 to 9, 2 से लेकर 9 तक I'm going to execute the P1 process. Okay, I'll come back to this non-preemptive portion. So yes, I think because of the second line, this second line is a little confusing. इस second line की वजह से थोड़ा सा confusion हो रहा है because they are telling us that it is SRTF algorithm. At the same time they are saying that when a process is going to waiting state, then you can schedule a new process, or when a running process completes its CPU burst. Right, so from the second line they are saying that they are not having preemption. Right, so that is a non-preemptive manner. Correct, but from the first line when they are saying it is shortest remaining compute time first, it says that it is a preemptive. Right, so let us assume that this is a non-preemptive, because in this question even if the scheduling algorithm is preemptive or even if it is non-preemptive, in both the cases you will get the same answer. इस पूरे क्वेश्चन में चाहे आपके शेड्यूलिंग एल्गोरिथम प्रीएम्प्टिव हो या फिर नॉन प्रीएम्प्टिव हो, आपका आंसर सेम ही आएगा. ओके, so they are adding these 2 lines just to create confusion between the students, ताकि in most of the time you'll get confused whether it is a preemptive, whether it is a non-preemptive, because of this line they are saying it is preemptive, because of this line they are saying it is non-preemptive. It is just added so that you get confused in the exam. Fine. So the process P1 will finish at time 9, so P1 finished its CPU. Then at the same time all of these other processes are also, they have also finished their IO. Okay, now we are going to schedule the process P2 here. Process P2 will finish at time 23. So this will be done. This will be done. Correct. Then we have process P3. P3 will be scheduled from 23 to 44. This will be done. After this, from 44 till 47, 44 से लेकर 47 तक the CPU will remain idle because P3 process will be doing its IO. P3 process जो है वो अपना IO finish करेगी. Now they are asking clearly what is the percentage of the time CPU remain idle. कितने टाइम तक CPU idle रहेगा. In this total time from here to here, CPU was idle here as well as CPU was idle here. 2 units of time here and 3 units of time here. Total 5 units of time the CPU was idle out of 47. Out of 47, total 5 minutes of time तक CPU idle रहेगा. If you multiply this value by 100, then you will get 500 divided by 47 percentage. And if you calculate this value, you will get a value which is 10.6 percentage. So for 10.6%, your CPU will be idle. 10.6% तक CPU आपका idle रहेगा. Out of the total time, 10.6% time the CPU will be idle, and 89.4% time the CPU will be busy. इतने टाइम तक CPU बिजी रहेगा और इतने टाइम तक CPU आइडल रहेगा. ओके, आई होप इट इज़ क्लियर विद एवरीवन. लेट मी सी इफ आई हैव अनदर क्वेश्चन. ओके, आई बिलीव आई डोंट हैव एनी अदर क्वेश्चन हियर. तो सभी क्वेश्चन जो है वो 2 ही क्वेश्चन थे. देयर वर ओनली 2 क्वेश्चंस. अभी भी हमें 3 और एल्गोरिथम्स करनी है. सो वी हैव टू कवर द राउंड रॉबिन एल्गोरिथम. राउंड रॉबिन अभी बचा हुआ है हमारे पास. So round robin will take approximately half hour. Round robin algorithm जो है वो half hour लेगा. After this we are going to take highest response ratio next. This will take another 20 minutes, and then we will look at feedback queue scheduling as well as multi-level feedback queue scheduling. This will take approximately 5 to 10 minutes. ये 5 से लेकर 10 मिनट लेगा. सो रफली वी हैव अ टॉपिक ऑफ 1 more hour. आपका 1 घंटे का टॉपिक और बचा है. इन 1 more hour दिस प्रोसेस शेड्यूलिंग एल्गोरिथम चैप्टर विल बी फिनिश्ड. प्रोसेस शेड्यूलिंग एल्गोरिथम का जो चैप्टर है ऑपरेटिंग सिस्टम का, ये फिनिश हो जाएगा. गुड. सो इन दिस सेशन अगेन वी विल बी स्टार्टिंग विद आवर एल्गोरिथम्स, द रिमेनिंग एल्गोरिथम्स. सो विल फिनिश द एंटायर चैप्टर टुडे इटसेल्फ. सो द फर्स्ट एल्गोरिथम दैट वी विल बी डिस्कसिंग इज राउंड रॉबिन एल्गोरिथम. Then the next algorithm will be highest response ratio next, and the last algorithm will be multi-level feedback queue scheduling. Multi-level feedback queue scheduling. ठीक है. So currently we are starting with the round robin algorithm. अभी हम round robin algorithm के साथ start कर रहे हैं. Correct. So round robin algorithm is just like a movie camera. I have told you this example many times in the previous sessions. So if you have seen a movie camera like this, in a movie camera we have a projector, right? So this is a projector which projects some light on the screen. So this is your screen. It projects some light and we have a reel here. And with this reel is basically images. This reel is containing all the images here. So in these images there might be some person who is performing some action. Maybe the person is dancing, maybe she is Priyanka Chopra or something. So this person is dancing or doing something, right? So when you throw a light on this reel, it creates an image on the screen. So this is just an image. It is not a moving person, it is not a digital image, it is just an image. But when you change these images at 24 images per second, then we feel like that character on the screen is moving, he is talking, he is performing some actions. So this is the standard for movie theaters, that they project 24 images per second on the screen so that you feel like that this person is doing some actions, right? So आप उसको कैरेक्टर्स को मूवी के अंदर मूविंग कैरेक्टर्स को देख सकते हैं इस तरीके से, right? So that means to every image we have given some kind of time quantum. हर एक इमेज एक स्पेसिफिक टाइम के लिए ही शो होगी. अब 1 image is shown for 60 divided by 20 maybe So one image, you can say, you can show one image for how much of a second. So in 1 second there are 1000 microsecond. So you are representing one image for 1000 divided by 24 microsecond, or sorry, millisecond. This is not microsecond, this should be millisecond, right? So you are representing one image for 1000 divided by 24 millisecond, which represents a time quantum, or it can also be called as a time slice. इसको हम time slice भी कह सकते हैं. In the same way, in round robin algorithm, we use something called as a time quantum, or we call it as a time slice. So that means in your CPU you are going to execute a process for this time quantum. If this time quantum is 2 nanosecond, then you will be executing one process for 2 nanosecond. आप हर एक process को 2 nanosecond तक execute करेंगे, and again you will take this process out of the CPU and you will put another process in the CPU, right? So just like you are going to perform rounds and rounds and rounds like this, so you are going to change the process which are being executed in the CPU, and you are going to execute every process for this given time quantum only. Okay, that is your round robin algorithm. So how does this algorithm work? Let me show you here. So in this image you can see the process of working. So this is your ready queue, this is your ready state. In this ready state we maintain a ready queue, and this is your CPU, right? So what we do here is, we have multiple processes here. We have a process P1, we have a process P2, we have a process P3, we have a process P4. We select one process from the ready state. You select a process from the ready state, and you are going to check if the burst time of the process is less than the time quantum or not. For example, if the time quantum is 2 nanosecond and the burst time of this process is only 1 nanosecond, क्या इस process का burst time इस time quantum से कम है या नहीं है? If the burst time of the process is less than the time quantum, then you are going to execute the process till completion in the CPU, and then you will be terminating the process. But what if the burst time of the process is more than the time quantum? जैसे कि अगर P1 का जो burst time है वो 10 nanosecond का है और time quantum आपका 2 nanosecond का है. If the burst time of the process is more than the time quantum, then you are going to execute the process for the time quantum. That means आप इस P1 process को 2 nanosecond तक execute करेंगे, and then again you can take this process P1 out of the CPU and you put it in the ready queue again. So you are going to execute it for the time quantum, and then you are going to check whether the process is completed or not. If the process is not completed, again you are going to put the process in the ready queue. आप दोबारा से process को ready queue में रख देंगे. This is the entire process for round robin. पूरी जो round robin algorithm है, it works on this principle. Clear so far? अब तक clear है? Now if it is clear, let me show you with the help of an example. I'll show you with the help of an example here. So let us assume that we have these processes. This is the process ID, this is the arrival time, and this is the burst time of the process. We have 5 process P1, P2, P3, P4 and P5. The arrival times of these processes are 1, 2, 3 and 4, and the burst time of these processes are 5, 3, 1, 2 and 3. Now let us assume, let the time quantum here is 2 units. आपका जो time quantum है वो 2 unit का है. Now how will you perform a round robin scheduling algorithm on this? How will you do round robin on this? अब इस पे round robin algorithm को कैसे implement करेंगे? Okay, so in a round robin algorithm we are going to maintain a queue here. This is a queue, and this queue will be called as a ready queue. ये आपकी ready queue है, and this is representing your Gantt chart, right? So whenever a new process arrives, जब भी कोई नई process आएगी, you are going to put this process in the ready queue. For example, we have the process P1, so I'm going to put the process in the ready queue. ठीक है? So at time 0 in the ready queue only one process is available, so I'm going to schedule this process P1 in the Gantt chart for 2 nanoseconds, or can say for 2 units. हम इसको 2 unit तक ही schedule करेंगे. Now look at it very carefully. When you schedule this process for 2 nanoseconds here, जब आप इस प्रोसेस को 2 नैनोसेकंड तक शेड्यूल करेंगे, मीनवाइल अदर प्रोसेसेस कैन कम, बीच में आपकी दूसरी प्रोसेसेस भी आ सकती हैं. So you are going to schedule this process P1 for 2 nanoseconds, and meanwhile at the first nanosecond you are getting a process P2. You are going to put this process P2 in the ready queue, and then you are going to put this process P3 in the ready queue. And as soon as after 2 nanosecond if P1 is out, जैसे ही 2 nanosecond के बाद P1 वापस बाहर आएगी, then you are going to put the P1 process in the ready queue again. ठीक है, तो बेसिकली करना ये है कि जब भी कोई न्यू प्रोसेस आएगी, वेन एवर अ न्यू प्रोसेस इज कमिंग, यू आर गोइंग टू पुट द न्यू प्रोसेस इन द रेडी क्यू. जब भी कोई न्यू प्रोसेस आएगी आपको उसे रेडी क्यू के अंदर डाल देना है. ओके, नाउ देयर आर 3 प्रोसेसेस इन द रेडी क्यू, और हम लोग इसको सेम ऑर्डर में ही एग्जीक्यूट करेंगे. वी विल एग्जीक्यूट एवरी प्रोसेस इन द सेम ऑर्डर. सो द नेक्स्ट प्रोसेस इज P2. आई विल टेक दिस P2 आउट फ्रॉम द रेडी क्यू. आई विल एग्जीक्यूट दिस P2 फॉर द टाइम क्वांटम, एंड यू कैन सी द टाइम क्वांटम फॉर P2, I mean the burst time of P2 is 3 units. P2 का जो burst time है वो 3 units है, which is greater than the time quantum, जो कि time quantum से बड़ा है. So I'm going to execute P2 for the time quantum, and the burst time of P2 will now become 1, right? Between this time quantum, between 2 to 4, P4 and P5 also came. 2 से लेकर 4 के बीच में P4 और P5 भी आ गए. So I'm going to put this P4 and P5 इन द रेडी क्यू. हम P4 और P5 को रेडी क्यू में डाल देंगे, एंड एज सुन एज P2 कम आउट ऑफ दिस CPU, हम P2 को भी रेडी क्यू के अंदर डाल देंगे. ओके, नाउ यू कैन सी ऑल ऑफ दीज प्रोसेसेस आर प्रेजेंट इन द रेडी क्यू. अब सभी प्रोसेसेस रेडी क्यू में प्रेजेंट है. ऑल यू हैव टू डू इज यू हैव टू टेक वन प्रोसेस फ्रॉम द रेडी क्यू, यू हैव टू एग्जीक्यूट फॉर द टाइम क्वांटम, एंड अगेन यू हैव टू सी क्या हम इसको दोबारा से पुट बैक करना है या नहीं करना. सो फॉर एग्जाम्पल इफ आई टेक P3 आउट ऑफ दिस रेडी क्यू, द टाइम क्वांटम ऑफ द बर्स्ट टाइम ऑफ P3 इज 1 यूनिट. सो हम P3 को सिर्फ 1 यूनिट तक ही एग्जीक्यूट करेंगे, बिकॉज इन 1 यूनिट P3 विल गेट फिनिश्ड. सो P3 इज नाउ फिनिश्ड. आई डोंट हैव टू पुट P3 अगेन इन द रेडी क्यू. ठीक है, देन वी हैव अ प्रोसेस P4, सॉरी अगेन वी हैव अ प्रोसेस P1 इन द रेडी क्यू. P1 है, अब रेडी क्यू में आपके पास P1 है. सो आई एम गोइंग टू एग्जीक्यूट P1 अगेन. So I will execute P1 here from 5 to 7, and the burst time of P1 will become 1, because P1 का जो burst time है वो अभी भी 0 नहीं हुआ. The burst time P1 जो है, P1 का burst time वो अभी भी 1 है. The burst time of P1 is still 1, it is not 0. So that means I have to again put P1 back in the ready queue. जब तक किसी प्रोसेस का burst time 0 नहीं हो जाता तब तक हमें उस प्रोसेस को दोबारा से रेडी क्यू में डालना पड़ेगा. Now we have a process P4. So burst time of P4 is 2 units. So हम P4 को रेडी क्यू से निकालेंगे. We are going to execute P4 here till time 9 units, और उसके बाद P4 का जो burst time है वो 0 हो जाएगा. So that means I do not have to P4 back in the ready queue. मुझे P4 को दोबारा से रेडी क्यू में नहीं डालना है. After this we have a process P5 in the ready queue. रेडी क्यू में P5 process है. I'm going to take P5 here. I'm going to execute it till the time quantum. Then the burst time of P5 will become 1. So because it is not 0, so I have to again put P5 back in the ready queue. Now we have a process P2 here in the ready queue. हम दोबारा से P2 को लेंगे. I'm going to execute P2 again for 1 time unit. So the burst time will become 0. Then that means it is finished. Then I'm going to execute P1 again. So burst time will become 0. That means this was P2. Sorry. I've executed P2, I've executed P1, so P1 will also be finished. Then I'm going to execute P5. So burst time of P5 is also 1, so P5 is also finished. So this is the order of execution. यहाँ पर ये जो है ये आपका execution का order रहेगा. So what is the completion time? Completion time of P1 is 13. Completion time of P2 is 12. Completion time of P3 is 5. Completion time of P4 is 9. And the completion time of P5 is 14. So in this way you can schedule these processes using the round robin algorithm. Okay, I believe it is not clear to some of you. I have to take one more example. मुझे एक और example लेना पड़ेगा so that I can make you understand this everything more clearly. So this is the process ID. We have P1, P2, P3, P4, P5 and P6. I'm taking a bigger example here because some of you who are not able to understand this, you should be able to follow through with this example. The arrival times are 0, 1, 2, 3, 4 and 5. This is the burst time. So burst time is 4, 5, 2, 1, 6 and 3. नाउ जिसको समझ में नहीं आया, दोज हु कुड नॉट अंडरस्टैंड, प्लीज़ लुक एट इट वेरी वेरी केयरफुली, बहुत केयरफुली देखना, बिकॉज दिस इज लिटिल कॉम्प्लिकेटेड एज कम्पेयर टू एनी अदर शेड्यूलिंग एल्गोरिथम, एंड मोस्ट ऑफ योर क्वेश्चंस विल बी फ्रॉम राउंड रॉबिन ओनली. सो लेट अस से द टाइम क्वांटम इज ऑफ 2 यूनिट्स. आपका टाइम क्वांटम 2 यूनिट्स का है, और ये आपके पास है गैंट चार्ट. दिस इज रिप्रेजेंटिंग योर गैंट चार्ट एंड दिस इज रिप्रेजेंटिंग योर रेडी क्यू. ये रिप्रेजेंट कर रहा है आपके पास रेडी क्यू. ओके, सो रेडी क्यू मीन्स दिस रेडी क्यू इज प्रेजेंट इन द मेन मेमोरी. रेडी क्यू आपकी मेन मेमोरी के अंदर प्रेजेंट होती है. सो एनी प्रोसेस दैट यू हैव टू एग्जीक्यूट, right? So first you have to bring the process in the ready queue, and then only you can take the process from the ready queue to execute in the CPU. Now at time 0, अब time 0 पर सिर्फ एक ही process system में आई है. So at time 0 only one process is available. So that means I have to put only one process in the ready queue. अगर हमें CPU के अंदर वो process को देना है तो time 0 पर, because only one process is available in the ready queue, therefore I have to schedule this one process P1 in the ready queue for the time quantum. तो P1 को हमें टाइम क्वांटम के लिए शेड्यूल करना पड़ा. तो इसका जो बर्स्ट टाइम है वो हो गया अब आपके पास 2. नाउ लुक एट इट वेरी केयरफुली, बहुत ध्यान से समझिएगा. जब आपने P1 को एग्जीक्यूट कर रहे थे, जिस समय पर आप P1 को एग्जीक्यूट कर रहे थे CPU में, उस समय पर P2 और P3 भी रेडी क्यू में आ चुकी है. बिकॉज P2 कब आई? टाइम यूनिट 1 पे, और P3 कब आई? टाइम यूनिट 2 पर. जब आप P1 को एग्जीक्यूट कर रहे थे तो P2 आपके पास रेडी क्यू में आ गई और P3 भी रेडी क्यू में आ गई. अब उसके बाद जब P1 ने 2 टाइम क्वांटम के लिए एग्जीक्यूट किया, आफ्टर दैट द बर्स्ट टाइम ऑफ P1 इज स्टिल 2, यानी कि P1 जो प्रोसेस है वो फिनिश नहीं हुई है, इसलिए हमने P1 प्रोसेस को दोबारा से रेडी क्यू में रखा. ओके, वी हैव टू पुट द P1 प्रोसेस अगेन बैक इन द रेडी क्यू बिकॉज P1 प्रोसेस इज नॉट फिनिश्ड. नाउ अगेन टेक वन मोर प्रोसेस फ्रॉम द रेडी क्यू टू एग्जीक्यूट इन द गैंट चार्ट. देखो, जो भी प्रोसेस आप एग्जीक्यूट करेंगे, एनी प्रोसेस दैट यू हैव टू एग्जीक्यूट, यू हैव टू सेलेक्ट दैट प्रोसेस फ्रॉम द रेडी क्यू ओनली. आप उसको रेडी क्यू से ही सेलेक्ट करेंगे. सो द नेक्स्ट प्रोसेस इन द रेडी क्यू इज P2. सो आई विल टेक दिस P2, आई एम गोइंग टू रिमूव दिस P2 फ्रॉम द रेडी क्यू. आई एम गोइंग टू एग्जीक्यूट दिस P2 इन द CPU फॉर 2 टाइम यूनिट्स. हम इसको 2 टाइम यूनिट्स तक एग्जीक्यूट करेंगे. सो बिकॉज ऑफ दैट द बर्स्ट टाइम ऑफ P2 विल बिकम 3. P2 का बर्स्ट टाइम 3 हो जाएगा. बट बिटवीन दिस टाइम यूनिट 2 एंड 4, टाइम यूनिट 2 और 4 के बीच में वी हैव अ प्रोसेस P4 एंड P5 जो कि सिस्टम में आ चुकी है. P4 और P5 रेडी क्यू में आ चुकी है. सो आई हैव टू पुट P4 here in the ready queue, I have to put P5 here in the ready queue, and after this because P2 is not finished, P2 फिनिश नहीं हुई है, so I have to put P2 back in the ready queue. तो मुझे P2 प्रोसेस को दोबारा से रेडी क्यू में डालना पड़ेगा. ओके, नाउ अगेन टेक वन मोर प्रोसेस आउट ऑफ द रेडी क्यू. हमने प्रोसेस P3 को रेडी क्यू से निकाला, सो यू हैव टू रिमूव प्रोसेस P3 फ्रॉम द रेडी क्यू. यू हैव टू एग्जीक्यूट द प्रोसेस P3 फॉर 2 टाइम यूनिट्स और टाइम क्वांटम. सो यू कैन सी द प्रोसेस P3 इज नॉट फिनिश्ड. P3 जो प्रोसेस है वो अब कम्प्लीटली फिनिश हो गई है. सो मीन वाइल बिटवीन 4 to 6 P6 प्रोसेस ऑल्सो अराइव्ड. P6 प्रोसेस भी अराइव हो चुकी है. सो आई हैव टू पुट P6 प्रोसेस इन द रेडी क्यू. हमने P6 को रेडी क्यू के अंदर डाल दिया. अब देखो, अब कोई भी नई प्रोसेस नहीं आने वाली. नो न्यू प्रोसेस हैज़ टू अराइव. अब किसी भी नई प्रोसेस को नहीं आना है. सो ऑल आई एम गोइंग टू डू नाउ इज आई एम गोइंग टू टेक अ प्रोसेस फ्रॉम द रेडी क्यू. आई विल एग्जीक्यूट फॉर द टाइम क्वांटम एंड दैट्स इट. सो आई एम गोइंग टू टेक द P1 process from the ready queue. I will execute this P1 process and the time quantum for P1 process 2 units. So this P1 process will be finished at time 8. तो ये time 8 पर finish हो जाएगी. Okay. After this, I will take P4 process. I will execute the P4 process. The burst time of P4 is only 1. So I will execute it only for 1 unit of time. It will be finished at time 9. Then I will execute the P5 process. P5 the burst time is 6. So I'm going to execute P5 for 2 units of time, and then again I'm going to put the P5 in the ready queue. Because P5 finish नहीं हुई थी, इसी वजह से हमने P5 को दोबारा से ready queue में डाल दिया. After this I will take P2 out of this ready queue. हमने P2 को ready queue से बाहर निकाला. We are going to execute P2 for 2 time units. हम इसको 2 time unit तक execute करेंगे. So because P2 is not finished, so I have to again put P2 back in the ready queue. हमने P2 को दोबारा से ready queue में वापस डाल दिया. After this I will again take P6 out of this ready queue. हम P6 को निकालेंगे. I'm going to execute P6 for 2 time units. Then because P6 is not finished, so again I have to put P6 back in the ready queue. हमें दोबारा से P6 को ready queue में डालना पड़ा. Then I will take P5 out of the ready queue. I will execute P5 for 2 time units. Then again P5 is not finished, so I have to again put P5 in the ready queue. हमें दोबारा से P5 को ready queue में डालना पड़ा. Then I have to take P2 out from the ready queue, and now we are going to execute P2 for 1 time unit only. हम इसको सिर्फ एक ही time unit तक execute करेंगे. Then P2 is finished, so because वो finish हो गई, so again we do not have to put this in the ready queue. हम इसको दोबारा से ready queue में नहीं डालेंगे. Then I'm going to take P6. I'm going to execute P6 for 1 time unit. P6 is now finished, and then I will take P5 and I will execute P5 for 2 time units, and now P5 is also finished. So now all the processes are finished. So what is the completion time? Completion time for the process P1 is 8. The completion time for the process P2 is 13. The completion time for the process P3 here, P3 is finished here, so it is 6. The completion time for the process P4, P4 is finished here, so it is 9. The completion time for the process P5, P5 finished here, so it is 21. And the completion time for the process P6 is 19. So I've got the completion time for each of these processes. Okay. So completion time for P2 is 18. Yes, P2 is 18. That is correct. P2 का जो completion time है वो 18 है. Yes, completion time for P2 is 18. Now you can find the turnaround time. So turnaround time for each of these processes are going to be 8, 17, 4, 6, 17 and 13. And the waiting time for these processes are going to be 4, 12, 2, 5, 11 and 10. So in this way you can find the waiting time for each of these processes. So if you calculate what is the average waiting time, so average waiting time is going to be 7.33, and if you calculate what is the average turnaround time is going to be 10.84. Okay, let me verify. So I think I've written all the values correctly. So P4, the completion time for P4 is 9 only, 14 नहीं है. P4 का completion time आपके पास 9 ही रहेगा. So P6 का completion time 19 है. The completion time for P6 is 19, it is not 14. P6 जो है वो यहाँ पर finish हो रहा है. P6 is finishing here, so it is not 19. Okay. So turnaround time is 8, 17, 4, 6, 17 and 13. I think this is correct. So turnaround time is basically completion time minus arrival time. Completion time minus arrival करेंगे. So turnaround time for P6 is 19 minus 5. Okay, so 19 minus 5 should be 14. That is correct. So 14 है, so this is a small mistake. Turnaround time is going to be 14. That is correct. So in the same way, if the turnaround time is 14, then you can calculate the waiting time. Waiting time is going to be 7, I guess. I think there's some mistake here in the calculation. So it is 7. Sorry, 7 or what? So 7A, this is going to be 11. It is going to be 11. 11 is the turnaround waiting time for P6. P6 process को 11 time unit तक wait करना पड़ा. Okay. Fine. So this is your round robin algorithm. Okay, let me give you one more example, and you have to solve it. So this is the process ID. So process ID is P1, P2, P3, P4, P5 and P6. Let us see if your pura concept is clear or not. After solving this question only, so arrival time is 5, 4, 3, 1, 2 and 6, and the burst times here are 5, 6, 7, 9, 2 and 3. Using round robin algorithm, what will be the average waiting time and the average turnaround time? So again we are going to have two things. One is your ready queue. This is representing your ready queue, and the second one is representing your Gantt chart. Okay. So if you look at it very closely, you will identify that first process is coming at time 1. जो पहली process आ रही है वो time 1 पर आ रही है. At time 0 no process is available. So that means from time 0 to 1 your system will remain idle. आपका जो system है वो idle रहेगा 0 से लेकर 1 time के बीच में. So the first process that is coming is process P4, and this process P4 is coming at time 1. I will take this process P4 and I will execute this process P4 for 3 time units. That means P4 will finish at 4. P4 जो है वो 4 पर finish होगी. Okay. So that means during that time, टाइम 4 तक P5 आ चुका है, P3 आ चुका है और P2 भी आ चुका है. So I'm going to put P5 here, I'm going to put P3 here, I'm going to put P2 here, and after this I will again put P4. उसके बाद हम दोबारा से P4 को put करेंगे. Okay, because the burst time of P4 is still 6. Now the next process that we have to execute is the process P5. तो हम P5 को यहाँ से लेंगे and I'm going to execute the process P5 for 2 time units. P5 का जो time units है वो 2 है, it is not 3. Okay, so for 2 time units P5 will be executed from 4 to 6. So P5 process will be finished. So meanwhile till time 6 you got the process which is P1 and you've got the process which is P6. तो P1 और P6 process भी आ चुके हैं. Now you can see all the processes have arrived. सभी processes आ चुकी हैं. Now all you have to do is you have to execute them in the same order. So now I'm going to execute the P3 process till 6 to 9. So this will become 4. So again I'm going to put P3 in the ready queue. After this I will execute the P2 process. So P2 will execute from 9 to 12. This will become 3. So again I'm going to put P2 here. Then I will execute the process P4 here. P4 will execute from 12 to 15. This will become 3. So I will put P4 again. Then I will execute again P1. So P1 will execute from 15 to 18. This will become 2. So I have to put P1 again. Then I will execute P6. So P6 will execute 18 to 21. Then P6 will be finished. P6 जो है वो finish हो जाएगी. After this I will execute the process P3 from 21 to 24. So this time will become 1. So P3 will be again put back in the ready queue. Then I'm going to execute the P2 process. So P2 will execute from 22 to 27. This will become 0. Then I will execute the process P4. P4 will execute from 27 to 30. So this will become 0. Then I will execute process P1. P1 will finish at 32. This will become 0. Then I will execute P3 and P3 will finish at time 33. तो P3 जो है वो time 33 पर finish होगा. So just by looking at it you can tell the last process that is getting finished is P3 process which is finishing at time 33. P3 जो process है वो time 33 पर finish हो रही है. So using all these values you can find what is the turnaround time and you can find what is the waiting time. आप यहाँ से turnaround time और waiting time को निकाल सकते हैं. You can also find what is the completion time of each of these processes. अब हर एक प्रोसेस का कंप्लीशन टाइम भी बता सकते हैं. सो प्रोसेस कंप्लीशन टाइम फॉर प्रोसेस P1 इज़ 32, फॉर P2 इट इज़ 27, फॉर P3 इट इज़ 33, फॉर P4 इट इज़ 30, फॉर P5 इट इज़ 6 and for P6 it is 21. So using these values you can find the average turnaround time as well as you can also find the average waiting time. Okay, I hope that all of you understood this. आप सभी को clear होगा. I don't have to take any one more example. I think next algorithm is highest response ratio next. Highest response ratio next. आपके अगली एल्गोरिथम है हाईएस्ट रिस्पॉन्स रेशो नेक्स्ट. ठीक है, इन केस ऑफ दिस हाईएस्ट रिस्पॉन्स रेशो वी कैलकुलेट द रिस्पॉन्स रेशो फॉर एवरी प्रोसेस. हम हर एक प्रोसेस के लिए एक रिस्पॉन्स रेशो कैलकुलेट करेंगे before executing the process, and the process which is having highest response ratio we will execute that process. So response ratio is basically your waiting time plus burst time divided by the burst time of the process. It is waiting time plus burst time divided by the burst time. That will be calculated, that will be called as your response ratio. So the process which is having the highest response ratio we will execute that process. ठीक है, So let me show you with the help of example, then we will look at theory regarding both the round robin as well as highest response ratio. This is the process ID, this is the arrival time, and this is the burst time. Process IDs are P0, P1, P2, P3 and P4. The arrival times are 0, 2, 4, 6 and 8. The burst times are 3, 6, 4, 5 and 2. ठीक है. So what is the benefit of this highest response ratio? Highest response ratio का benefit क्या है कि it favors the shorter jobs. It favors the shortest job, the shorter jobs, as well as it also limits the waiting time for longer jobs. ये लंबी जो बड़ी जॉब्स है उसका वेटिंग टाइम को भी लिमिट करता है और शॉर्टर जॉब्स को फेवर करता है. व्हाट डू आई मीन टू से बाय दिस इज, देखो व्हेन यू हैव अ शॉर्टेस्ट जॉब फर्स्ट एल्गोरिथम, so in case of your shortest job first algorithm, there's a problem of starvation. Shortest job first algorithm में starvation occur हो सकता है. So when you have shortest job first algorithm, there can be a starvation. When you can have shortest remaining time first algorithm, there can be a starvation. When you have longest job first algorithm, there can be a starvation. With longer remaining time first algorithm, starvation occur हो सकता है. Then with priority based scheduling, again you can have a starvation. यहाँ पर भी starvation occur हो सकता है. In round robin you will not have starvation. Round robin में starvation occur नहीं होगा. In FCFS algorithm starvation will not occur. FCFS में भी starvation occur नहीं होगा. In highest response ratio next algorithm there will not be any starvation. यहाँ पर भी starvation नहीं होगा. So what does this highest response ratio next does is it favors a process which is a shortest job. कोई प्रोसेस अगर छोटी है तो ये उसको फेवर करेगा, लेकिन अगर कोई प्रोसेस बड़ी है जिसको CPU नहीं मिल रहा तो उसके वेटिंग टाइम को भी लिमिट करेगा बाय यूजिंग दिस रिस्पॉन्स रेशो. तो रिस्पॉन्स रेशो में हम यहाँ पर वेटिंग टाइम को एक फैक्टर को इवेल्युएट करते हैं. वी यूज़ दिस वेटिंग टाइम, right? So if you have a process which is a big process, for that process we limit the waiting time of that process. हम उस process के waiting time को भी limit करते हैं so that starvation does not occur. That is why highest response ratio next algorithm is very good algorithm. How does we do it? देखो here at time 0 पर सिर्फ एक ही process available है. This is representing your Gantt chart. So at time 0 only one process is available, so I'm going to execute the process P0 from 0 to 3. तो हम P0 को 0 से लेकर 3 तक एग्जीक्यूट कर रहे हैं. दिस इज़ नॉन प्रीएम्प्टिव. ये नॉन प्रीएम्प्टिव है. दिस इज़ नॉन प्रीएम्प्टिव एंड दिस राउंड रॉबिन इज़ ऑलवेज प्रीएम्प्टिव. राउंड रॉबिन हमेशा प्रीएम्प्टिव होता है एंड दिस हाईएस्ट रिस्पॉन्स रेशियो नेक्स्ट एल्गोरिथम इज़ ए नॉन प्रीएम्प्टिव एल्गोरिथम. ये नॉन प्रीएम्प्टिव एल्गोरिथम है. नाउ एट टाइम 3 पर यू हैव ओनली प्रोसेस P1. टाइम 3 पर सिर्फ एक ही प्रोसेस अवेलेबल है जो कि प्रोसेस P1 है. उसके अलावा कोई भी प्रोसेस यहाँ पर नहीं आई है. ओनली वन प्रोसेस इज अवेलेबल एट टाइम 3. सो वी आर गोइंग टू एग्जीक्यूट द प्रोसेस P1 फ्रॉम 3 to 9. हम 3 से लेकर 9 तक हमने प्रोसेस P1 को एग्जीक्यूट किया. नाउ देयर इज़ अ प्रॉब्लम हियर बिकॉज नाउ देयर आर मल्टीपल प्रोसेसेस. अब एक से ज़्यादा प्रोसेसेस अवेलेबल हो चुकी हैं. लुक एट इट वेरी केयरफुली. If more than one processes are available here for execution, to make a scheduling decision, we are going to evaluate the response ratio for every process. हम इन सभी process का response ratio calculate करेंगे. So response ratio for the process P2, response ratio for the process P3, as well as the response ratio for the process P4. So response ratio is waiting time plus burst time divided by burst time. ठीक है. तो अभी current time क्या है? The current time is 9. And the P2 process arrived at time 4. So waiting time will be 9 minus 4 plus the burst time of P2 process is 4 divided by 4, which is going to be 5 plus 4 divided by 4, 9 by 4, which is 2.125 something. Okay, so 2.25. So this is 2.25 will be the response ratio for the process P2. In the same way, you will evaluate the response ratio for the process P3. P3 के लिए रिस्पॉन्स रेशो क्या रहेगा? सो करंट टाइम इज़ 9, द अराइवल टाइम ऑफ P3 इज 6. सो 9 minus 6 प्लस बर्स्ट टाइम ऑफ P3 डिवाइड बाई बर्स्ट टाइम ऑफ P3, विच इज़ 3 plus 5 divided by 5, which is 8 divided by 5, which is equal to 1.6. This value is 1.6. After this, again we have to evaluate the response ratio for the process P4. P4 process के response ratio निकालेंगे. So 9 minus 8 plus 2 divided by 2, which is equal to 3 divided by 2, which is 1.5. So we have evaluated response ratio for each of these processes. हर एक process के लिए हमने response ratio evaluate कर लिया है. After evaluating the response ratio for each of these processes, find out which process is having the highest response ratio. इन सबसे ज़्यादा जो रिस्पॉन्स रेशियो है, सबसे हाई जो रिस्पॉन्स रेशियो है, वो प्रोसेस P2 का है. तो प्रोसेस P2 इज़ हैविंग द हाईएस्ट रिस्पॉन्स रेशियो. सो आई विल एग्जीक्यूट प्रोसेस P2 हियर एंड वी विल एग्जीक्यूट प्रोसेस P2 टिल टाइम 13. हम प्रोसेस P2 को टाइम 13 तक एग्जीक्यूट करेंगे. आफ्टर दिस अगेन सी P1 इज़ ऑलरेडी फिनिश ना, तो P1 ऑलरेडी फिनिश हो चुके हैं. दैट इज़ वाई वी हैव नॉट इवैल्यूएटेड द रिस्पॉन्स रेशियो ऑफ P1. अगेन आफ्टर एग्जीक्यूटिंग P2 प्रोसेस, अब हमारे पास दो प्रोसेसेस अवेलेबल हैं. अगेन वी हैव टू इवैल्यूएट रिस्पॉन्स रेशियो. हमें दोबारा से रिस्पॉन्स रेशियो को इवैल्यूएट करना पड़ेगा. सो अगेन यू हैव टू फाइंड द रिस्पॉन्स रेशियो फॉर द प्रोसेस P3 एंड यू हैव टू फाइंड द रिस्पॉन्स रेशियो फॉर द प्रोसेस P4 बिकॉज वी हैव टू मेक अ शेड्यूलिंग डिसीजन अगेन, राइट. So current time is 13. Response ratio for the process P3 will be 13 minus 6 plus 5 divided by 5, and the response ratio for the process P4 is going to be 13 minus 8 plus 2 divided by 2. This value is going to be 12 divided by 5, which is 2.4, and this value is going to be 7 divided by 2, which is equal to 3.5. So you will see that response ratio of the process P4 is higher as compared to the response ratio for the process P3. So I'm going to schedule P4 process here from 13 to 15, and then I will schedule the process P3 here from 15 to 20. So this is the final time. Okay. So again, as I'm saying, to schedule a process you have to evaluate response ratios. अगर एक से ज़्यादा ready queue processes ready queue में available है, if more than one process is available in the ready queue, for all those processes we have to evaluate what is the response ratio, and then the process which is having the highest response ratio, I have to schedule that process in the CPU. तो उस process को हम CPU के अंदर schedule करेंगे. Clear? So now the last two algorithms are remaining. One is the first algorithm is multi-level queue scheduling, and second one will be multi-level feedback queue scheduling. So basically both are exactly the same. There's thoda sa difference hai. There's a very, very small difference between both of them. So first let us do the multi-level queue scheduling. Multi-level queue scheduling means we are going to have multiple queues. आप सिर्फ एक queue को maintain नहीं करेंगे, you are going to maintain multiple queues. So because there are different kinds of process in the system, you can have a child process, you can have a batch process, you can have an interactive process, you can have a system process. So because we have multiple different types of processes are present in the system, for each of these processes I'm going to maintain a different queue. हर एक process के लिए हम अलग अलग queue को maintain करेंगे. Okay. So for example, we have a queue for student process. जो आपकी स्टूडेंट प्रोसेसेस है उसके लिए यू आर गोइंग टू हैव अ क्यू फॉर बैच प्रोसेसेस. अब बैच प्रोसेसेस के लिए क्यू को मेंटेन करेंगे. देन यू आर गोइंग टू हैव अ क्यू फॉर इंटरेक्टिव प्रोसेसेस, एंड देन यू आर गोइंग टू हैव अ क्यू फॉर सिस्टम प्रोसेस. हम हर एक प्रोसेस के लिए अलग अलग क्यू को मेंटेन करेंगे. ओके, वी आर गोइंग टू मेंटेन different queue for each of these processes. So if a child process is created by a user, so I will put this process here. अगर P1 एक child process है तो उसको हम इस queue के अंदर डाल देंगे. तो जितनी भी आपकी child process है, if you have 10 child processes or if you have 10 student processes, you are going to put all these 10 student process in this queue, and you are going to put all the batch processes in this queue. You are going to put all the interactive processes in this queue. You are going to put all the system processes in this queue. इन सभी queue के अंदर हम processes को डाल देंगे. And now we are going to say that this queue is going to have a lowest priority. तो इसकी सबसे जो priority है सबसे कम है. And this queue is going to have the highest priority. यहाँ पर हमारे पास highest priority है. What do you do? In the system processes, you are going to apply FCFS algorithm. And in the interactive processes, you are going to apply the shortest job first algorithm. In the batch processes, you are going to apply the round robin algorithm. In the student processes, you are going to apply द प्रायोरिटी एल्गोरिथम। मतलब बेसिकली हमने करा क्या, वी हैव मिक्सड ऑल दीज एल्गोरिथम, जितनी भी एल्गोरिथम्स हमने स्टडी की है हमने सभी एल्गोरिथम्स को मिक्स कर दिया। आई मीन टू से दैट जितनी भी स्टूडेंट प्रोसेसेस अवेलेबल है, ऑल द स्टूडेंट प्रोसेसेस विच आर अवेलेबल, आई एम गोइंग टू सेलेक्ट वन स्टूडेंट प्रोसेस आउट ऑफ दिस ऑन द बेसिस ऑफ प्रायोरिटी। जितनी भी बैच प्रोसेसेस अवेलेबल है, आई एम गोइंग टू सेलेक्ट वन बैच प्रोसेस आउट ऑफ दिस ऑन द बेसिस ऑफ राउंड रॉबिन एल्गोरिथम। जितनी भी इंटरेक्टिव प्रोसेसेस हैं उन सभी में से हम शॉर्टेज ऑफ फर्स्ट एल्गोरिथम को से एक प्रोसेस को चूज़ करेंगे, और जितने भी सिस्टम प्रोसेस है उससे हम FCFS से चूज़ करेंगे। तो एज्यूमिंग यहाँ से जो प्रोसेस आपको मिली है वो P1 मिली है, यहाँ से एक प्रोसेस PX मिली है, यहाँ से एक प्रोसेस PM मिली है, और यहाँ से आपको एक प्रोसेस PY मिली है। तो अभी जितनी भी प्रोसेस मिली है इसके ऊपर हम दोबारा से प्रायोरिटीज़ असाइन करेंगे। हम बोलेंगे दीज प्रोसेसेस आर हैविंग हायर प्रायोरिटी एंड दिस प्रोसेस आर हैविंग लो प्रायोरिटी। ठीक है, तो अब जो भी प्रोसेसेस इन सभी क्यू में से निकल के आई है उसके ऊपर हम दोबारा से प्रायोरिटी बेस्ड एल्गोरिथम लगाएंगे, एंड जो भी रिजल्टेंट आपका रहेगा उस प्रोसेस को हम CPU के अंदर एग्जीक्यूट करेंगे। विल एग्जीक्यूट दैट रिजल्टेंट प्रोसेस इन द CPU। ओके, सो लेट मी रिपीट अगेन, पूरा कॉन्सेप्ट एक बार फिर से रिपीट करता हूँ। वेन एवर यू हैव मल्टी लेवल क्यू शेड्यूलिंग, तो मल्टी लेवल क्यू शेड्यूलिंग में हम अलग अलग क्यूज़ को मेंटेन करेंगे। वी आर गोइंग टू मेंटेन डिफरेंट क्यूज़, वी आर गोइंग टू मेंटेन अ सिस्टम प्रोसेस क्यू, वी आर गोइंग टू मेंटेन इंटरेक्टिव प्रोसेस क्यू, वी आर गोइंग टू मेंटेन अ बैच प्रोसेस क्यू, एंड वी आर गोइंग टू मेंटेन अ स्टूडेंट प्रोसेस क्यू। नाउ ऑन ऑल ऑफ दीज क्यूज़ वी आर गोइंग टू इम्प्लीमेंट डिफरेंट एल्गोरिथम्स। ज़्यादातर जो आपकी सिस्टम प्रोसेसेस है, in your system processes you cannot have preemption. System processes are very necessary for the proper functioning of your operating system. System processes जो है वो आपके operating system की proper functioning के लिए बहुत ज़रूरी होती है। So we do not implement preemption on the system processes. तो इन पर preemption नहीं हो सकता है। So what I'm going to do is all the processes which are available in the system process, I'm going to select one process on the basis of FCFS. Here I'm going to select one process on the basis of SJF. I'm going to select one process on the basis of round robin. I'm going to select one process on the basis of priority. अब जो processes हमें मिली है इन सब से, in all of those processes again I'm going to implement one more algorithm which is a priority based algorithm. इस पे हम दोबारा से priority based algorithm लगाएंगे, and because of this priority based algorithm जो भी process हमारे पास select हुई, for example we have a process P1 जो select हुई है, तो priority based लगा के, so I'm going to execute this process P1 in the CPU. That is your multi-level queue scheduling. Clear? सबको clear हुआ what is a multi-level queue scheduling? Now the last one is multi-level feedback queue scheduling. Multi-level queue